Ladies and gentlemen, good morning, distinguished guests, industry leaders, and esteemed participants. Welcome to third day and final day of Oman Petroleum Energy Show 2025. It has been an incredible journey of insight, innovation, collaboration over the past 2 days. To begin on today's journey of discovery and innovation, let's welcome our first speaker for today, Mr. Majid Al-Majrafi, who is a senior specialist in emergency and crisis management at OQ, and he will be presenting crisis and incident management system. Please come to the stage.
ما ننتظر أشوف حد موجود. لا مشكلة. Assalamu alaikum. So, good morning, everyone. So, may I ask you to come forward a little bit because of the small number we have, please. So, today I'm going to present a software system that we utilize in OQEB to support our emergency and crisis management. But first, before we start, let me ask you this question. Throughout your career, have you been in any emergency or crisis management involved directly in managing the event? So you have been. So you know how it is, what it looks like. And let me ask you a further question here. What is the critical element that you think is the most important to focus on in an emergency and crisis management? Excuse me, can you give him the mic, please?
Hi.
Yes,
Actually, communication.
MashaAllah. Perfect. And that's why we are here today, is to discuss the communication. Always communication plays the crucial part in an emergency and crisis management. And when we talk about communication, then we are talking about information. We are dealing with an information. But how we are going to deal with this information? It's not about just receiving and sending information. There's a lot of a complex process within receiving and sending the information. And this basically is first start with gathering the information and then verify this information before you proceed further to analyze this information, and then based on your analysis with this information, you will come to act based on those informations. And because of the too many lines and channels will be created in emergency and crisis management, it's very crucial that streaming these channels into a less number as minimum to make sure that this information is, the information flow is going to where it's supposed to be. And today, in the next 10 minutes, I'm going to present and talking about a crisis and incident management software system that we use in OQEB and support us in overcoming these issues with the crisis communication. And unfortunately, due to the limited time, I'm not going to talk about the whole benefits of the system, but I'm going to focus today on the communication. So, what is SIMPRO? SIMPRO is a crisis and incident management platform. We utilize it to gather all the responders, teams from the site level and head office and executive level to deal with an emergency and crisis management in one platform that support us in making sure everyone working in the same page. You don't have to go and do thousands of calls just to pass the information you have got from your site. It's all done from the same platform, and you will have an access to each other's team information, so you get the situational awareness up to date, and then you analyze this information. We will go through in the next slides how the Simpro is supporting the communication issues within the emergency and crisis situations. So first, we talked about these 4 processes of the information. So gathering information. So we have, in OQEP, we have adopted incident command systems, FEMA-based, where it's categorized the emergencies into 3 levels. Level 1 start with the site team, and we call it incident management team. The people who dealing or managing level 1, we call it incident management team, IMT. And then once it's escalated, it comes to level 2, where is the emergency management team has to deal with the situation to support the IMT. And the last level we go, which is the highest, is the crisis level, whereas the crisis management team has to involve and support the both teams dealing with the emergency. All those teams, IMT, EMT, CMT, they are able to share the information and any instant updates into the platform, which is a web browser platform, and they don't have to do a single call just to pass any information. Along with the other benefits, dealing with the confirmations, which we will present later on, so that support the situational awareness built correctly and updated within all teams together. So what information that can be shared within all these 3 teams together in these platforms? So we will start with the objectives, priorities, constraints, and any critical information required. And also, its support with the safety analysis get passed through all the teams from level 1 up to level 3. So, and the strategies and tactics built by each team, it will be shared with all of those teams. So you can look at the other teams, how they are working, how they are operating, and that will support you within your team to come with a strategy and plan to make sure the other team's objectives is achieved as well. Resources allocations, and this is where the confusion mostly come. Allocation of the resources, what resources available on site, what resources is en route to the site, and what resources we need, and what resources we think we have to make it standby, so we might utilize it. And it's all there clearly with a friendly formatting forms to support this information get passed to everyone with no single confusion. And then task assignment. So when you deal with the information, you will have to act upon those information. Where you have one of the action is to make a task, and to assign a task in the system, it will enable you to assign a task to a single persons or to a team as a whole team, from IMT to EMT, or you choose a member from the EMT or the IMT. Decisions and directives, which is very crucial. So any decisions and directives been made for each team, it will be recorded there, and it will be passed through all the teams, and it will be recordable and the history backed, so you can see what decisions have been made and what decisions have been, or what's the directives so far. So this is the gathering station or gathering phase of the information. And then here we come to verify this information. And verifying the informations through the systems, it comes as you know the source of information, where this source or where this information came from. So in this example, I'm not sure if you can see what's written there, but you have an update about an injury person's status. We have a severe injury, we have a minor injury. These updates, the source of information is the Block 60 clinic. So you would know then this status of those injury has been assessed and evaluated correctly because it's from the right people. It's not an initial assessment, but it's already with an expert who will get you the right information, which you don't have or which you don't know. And then we have a confirmation. And sorry for the typo here, it's supposed to be the confirmation, not the source. So when you verify an information, you have to make sure, is this confirmed or unconfirmed? Because you are going to deal with this information. You are going to act based on those information. The last things you want is to create any emergency while you are dealing with the emergency. So you have to make sure you deal with the right information so you will come with the right solutions. And then access to CCTV, where the system and the platform enables you to access in some certain plans, which is critical plans, process plans within the site. So you are in head office, you will be able to access the live picture of the situations, how that can support us. That can support us in verifying the information we have received so far from the site level. So I will make sure it's in the right location. Example, if we have a tank fire, so I can see from the CCTV it's in the right tank. I'm dealing with the same tank identification. And then when we come to analyze the information, it's a whole, the analyzations or analysis of this information is a complex, no, I would not say complex, but it's a lengthy process. However, in a short term, I would say providing a supporting document where you can rely on in getting this information analyzed is the big things you are hoping to have during your management of the incidents or emergencies. And the system has a library or a file archive where all the supporting documents you need is in one click. Access it with one click. So you don't have to go back and forth flipping over thousands of leaves of paper, and then you would not find the information. So it's supporting to provide the crucial documents. And those documents, as an example, could be the pre-incident plans or manuals, policies, procedures, or standing operating procedures, SOPs, or site-specific layouts. And also, as it is, the system is providing almost a simplified data you can get. You don't have to go through a complex and unnecessary information, and then you have to go back and filterize those information, which you need, which you don't. The system is already presenting a simplified data. And then, lastly, which I have talked about, which is the friendly formatting design. It's in itself, it's supporting you in analyzing the situation or analyzing the information. So the last phase would be the act. So you have to act based on those information you have received. So acting is about creating a task to move forward, or resource assignment, or in-platform approval, where all the delay comes. You have to go, you have to send an email, I need approval, this and this. The systems enables you to send the appropriate approval you are looking for, and it will be approved within the system from the right or from the authorized personnel. And here is an example in the picture below how the task's been assigned, whether it's executed or it's already started. You would know instantly when the action been done through or against this task. So last question I have to ask you here. Imagine yourself being called to deal with an emergency. You are part of the team and you have been called to take over from already your mate to deal with the situation. And you found this is the handover. What's your situation? How you are going to build the confidence that the situation has been managed correctly and you are confident you are going to continue further. You are not going to make the situational awareness from the right beginning and in the right format. However, the systems, the Simpro, is changing all this information and misinformation and with no clear handwriting into digitalized platform where all the necessary information is there. All right? So we came at the end of this talk, and I hope you have get the message cleared. And the floor is open for any question. For 1 minute? So we have 1 minute, unfortunately. So it will be one question. So anyone has any question? No? So thank you very much for the listening.
Thank you, Mr. Majid. Our next speaker will be Mr. Anshul Tagi, Regional Sales Manager at Hydro, as well as he will be speaking about reducing fugitive emissions in energy transition era. Please come to the stage.
Good morning. Thank you, OPS, for giving me this platform. And yeah, this is an interesting topic. I've been going through many slides, many presentations in the last couple of days. And I'm here. My name is Anshul Tyagi. I'm the Regional Sales Manager for High-Torque. And what I'm going to take you through is to give you some insight about the fugitive emissions, how it's happening and what we can do to control it. So yeah, these are some of the topics which I will be touching upon. We have the fugitive emissions happening, the bolted joint focus, the LDAR, and what High-Torque is doing, and one of the case study. So where exactly the fugitive emissions are happening? Well, it's happening all around us when we talk about the industry specific. We have the upstream, downstream, midstream, wherever you look into the fugitive emissions are there. The thing is, it's only 5%, or it's not only 5% of the global fugitive emissions, it's been documented or it's been recorded, whereas the volume or the size is way more bigger or higher. Diving deep into the industry-wise, we have from the oil production side, 20% fugitive emission coming. We have close to, from the distribution side is 7%. The transmission and storage is contributing around 19%. Processing is 6%, but the major one, the most massive is the gas production, where we have 48% of the fugitive emissions coming. And just to give you an idea how dangerous these emissions are, the methane leaks are 25 times more impactful than the CO2, which we keep hearing day in, day out, the CO2, the global warming and things. And here, what it contributes is 16 million metric tons of methane is been released into the atmosphere every year. And this is not only to the environment, but it's also affecting you onto the commercial front. And because of these difficulties, like I said, it's only 5% we were able to measure. The remaining we are not. We are still not able to identify how much impact it is making into the greenhouse gas. When we walk into the plant, in the plant there are areas where the leakages are happening, and I broadly classify them as the pressure joints. All these pressure joints, we have the leaks happening, and majority of the leaks are coming from the valve side. Then we have the flange and the pumps, the relief valves, and the tanks. Here are some of the pictures, what you see, the heat exchangers, many of you would have seen it, the reactor vessels, the pumps, generators. All of these, some way or other, are contributing to the fugitive emissions, the gas leakages. And where it happens, it starts, first of all, from this area, the bolted joint. Like I said, these are the pressure joints. This is where if we are following the right procedure, that is of the material control, utilizing the competent personnel, that's one very important area, that competent personnel, because that also leads to majority of the leakage. The document procedure should be followed, the right procedure, the hydro test, integrity test, and the records. Now, in a refinery or in a petchem plant, how we can come over these fugitive emissions? We need to implement the LDAR program, which is a leak detection and repair program. In the leak detection and repair, we can first look into the root cause, where exactly the leakage is happening, utilizing the technology, the latest technology, what we have. I have seen many of the companies presenting about the AI, about the new technologies to count or to identify where the leaks are happening, because that is significant. We have close to 600 to 700 tons per year of volatile organic compound which is getting leaked out. And that can be first and foremost important path to arrest this leak will be the LDAR. From high torque side, once the LDAR is been implemented, we come into action, and we have got the technologies where we can go to the root cause, identify where the mechanical joints had an issue, what were the history, and how we can overcome those things. So we identify the leaks, we provide the solutions which is making the alignment of the flanges or the joints in a better way, and then the integrity of the whole assembly is been achieved in the right manner. So what you see here, that green line, it is what we try to target, and this is where the area we would like to keep ourselves when we are doing any kind of untorquing or joint integrity. This is a video which shows about one of the technology. It's one of, I can say, the revolution which has happened. It shows about the washers which has been installed into the flange and how it is helping both onto the safety side as well as on control or providing a better load transfer.
For operators using conventional bolting methods with power torque tools, reaction arms, and backup wrenches. When a power tool is activated on the front side of the flange, a conventional reaction arm creates a pinch hazard. Accidents can occur, leading to major hand injury. The backup wrench can also move, creating a pinch point. An injury occurring on the back side of the flange can be just as devastating as one occurring on the front. The high torque washer system is the only solution that reduces the risk of hand injuries by eliminating pinch points. The washer system is comprised of a reaction washer and a backup washer, which perform all the functions of standard hardened washers and more. The reaction washer features a smooth side to reduce the friction of the turning nut. The opposite side is knurled to keep the reaction washer from rotating. The contoured outer surface braces reaction forces during tightening, eliminating the need for a reaction arm. The reaction washer is installed with the knurled side facing the flange to prevent rotation. The smooth side faces the nut. The outer reaction surface remains accessible for tool engagement. The backup washer has knurls on both sides and is installed between the back nut and the rear flange. The knurled surface prevents the back nut from turning, eliminating the need for a backup wrench. When bolting with the high torque washer system, the dual socket driver is positioned over the nut and the reaction washer. The outer driver engages the outer lobes of the reaction washer. The inner driver is a standard socket that engages the nut. The socket turns the nut within the stationary outer driver. The advantage is obvious. There are no exposed moving parts. All reaction pinch points are safely contained inside the outer driver. On the opposite side of the flange, the backup washer replaces the backup wrench, eliminating rear pinch points. The high torque washer is the only industrial bolting solution that can reduce the risk of hand injury.
Yeah, so just to understand what we have seen in the video, and this is the picture which narrates the whole story. What you are seeing here is a conventional way of doing the torquing, because why I'm mentioning here torquing is the pressure joints, what I mentioned earlier. The pressure joints is where that the leaks are happening. So when we identify using the LDAR, we need to go to the root cause, and that's where this torquing comes into picture. So we have this side load coming, which is, destabilizing the whole joint, which can be avoided by installing the right washers. And this is all eccentric load transfer, which is happening here. And in this picture, you will see the red line, which is the scattering of the bolt onto the flange. So these bolts are being scattered. The load is not uniform. When the load is not uniform, so here for an example, the load requirement was 80,000. And when we go with the conventional way, the load is pretty scattered. And because of that, over the period, initially even during the hydro test, the things were good, but a few months down the line, the leakage starts coming. How we can avoid it is to fix it and correct it, implement the right action from the assembly point, from the assembly stage. Another very good technology offered from our company is regarding the simultaneous torquing. That means operating 4 tools at a time. This is also bringing this parallel joint closer. Normally we follow the 30-60, 100-100 procedure for torquing. Here we can pass on from that procedure to 50, 100, 100, giving a better alignment, better compressive strength to the gasket, and the more stability to the whole structure. These are the technologies what has been offered. So I can say all these products are offering you the live data monitoring. So if an operator is using the tool, he can do the live data monitoring. For the supervisor, he can observe whether the right torque was delivered to that joint. And also there is a traceability. Once the job is complete, a report can be pulled out and he can verify it. The supervisor can verify it. We had an example here. This is a case study happened that a leak was identified in one of the refinery using the LDAR implementation. So they measured with the sensor and it was close to around 50,000 ppm per year. What we did is we, first of all, like I said, the competent personnel, that is very important. So we trained the person in line to the ASME guidelines. We installed those washers. We selected the right tool, customized the tightening procedures because they were not following, they were still doing the flogging things, and then the documentation and quality control. We ticked all those implementation and the site went just perfect. So there were no leakages observed, 30% time saving, safe and easy, and this is the real-time picture which has happened. On your left, you can see on the same site, there will be emission coming. It's a slightly blur, but this is what we can detect from the infrared, that there is an emission coming. But when we implemented the high torque HELP program, that's how we are able to control. No leaks detected on applications. We have reduced 88 tons of VOC from the environment annually. Yeah, quality and fastness, this is what we provide. The award-winning software which helps you with the traceability. And last and most important thing is training the industrial workforce. This is the most important part. With that, thank you very much. If you have any questions, the floor is open. All right. We are, by the way, exhibiting here, and if you would like to see all this technology, you can pass by our booth. Thank you very much. Thank you.
Thank you, Mr. Anashu. Our next speaker is Mr. Shea, Operation Director at Hamo Technologies. He will be presenting on cost efficiency, smart remote terminal units for oil field or digitalization application. Please come to the stage.
Thank you very much. Good morning, everyone. My name is Xie, and thanks OPEX for this great platform to share technology. Today, my subject is regarding the smart RTU for the oil field digitalization. And as we know that in the past decades, most of the oil and gas companies put on the effort for the oil field digitalization, and such as production optimization and save the cost for operation, enhance oil recovery. But how to achieve oil field digitalization? We need some key technology to save the cost. Normally, for example, the feed data transfer and displaying and communication, there's some traditional solution like DCS, SCADA system. And Himo, as a multi-phase and well testing supply for more than 30 years, we already developed our own technology, which can really save the cost for the end user and also improve the operation efficiency. As we know that we have the Pandola. This Pandola box actually, and we call this smart RTU. Totally, there are 4 layers. We have the sensor layer, which is specially to acquire the data and the signal from the flow meter, from the wellhead information pump on the signal can be connected to this system. And the second layer is the internet. So based on the internet, we have wireless, we have the cable for communication between the sensor layer and the platform and software. So the next layer is the platform, and there offer the communication like private server, cloud, and based on, we have 2 options. We can go with the public cloud, also we can go with the private cloud based on the end user requirement. And most of the keys in the oil field, we will go with the private cloud and offer one server and keep in the end user control room. And also we have the software application layer. So we have our own software which can acquire, display on the data. And also we have the AI model which can, after get on the information, so we can do some AI training to improve the efficiency to run the models. And here is the application function framework as we explained the totally 4 layer. So basically the first layer is the oil field equipment. So such as the multi-phase water color meter in the wellhead and the pressure, temperature, downhole information, and the pump parameters. So all this information can be collected by this smart RTU. And the next layer will be the agent computing. So based on the data we collect, we can do some data analysis, and there we can have the AI models which such as to optimize the production and to control the meter with high efficiency, like even control the pump and to save the energy. So next layer, there on the data will be transferred to the data center. Data center is a system. We have the server, we have our applications. So we can do some data like interference cleaning and analysis. And the last layer is platform. So we can do some display the data. And the key technology, what we have for our smart RTU is that we have some AI models which can be utilized for the agent computing, such as we can utilize AI model to optimize the production, and we can utilize AI model to for the well testing optimization for reduce the test duration. Also, we have some other models like intelligent to especially water metering. So in the oil field, is in some of the location, due to the cost saving, we cannot put the flow meter for each well. So we have to utilize the water metering technology. And especially also, we can use this smart RTU for the well testing management system. We can control the multi-phase and the MS way, and compare with the traditional way, like SCADA and DCS, we can save a lot of cost. Here, this is one of the keys for field application. We have the WTO. This system, this AI model is specially to reduce the test duration. As we know that for wear testing, we have we can use in mobile, also we can use a fixed unit. But how long we should test for each wear? We should have something. Usually, the traditional wear is manually. Okay, we test 24 hours, 10 hours, 9 hours. And actually, for the wear condition, the behavior is totally different. We have the slugging wear, and we have the stable wear, ESP, beam pump. So if we can have some AI model, which can automatically to calculate the test duration and confirm the wear is stable or unstable, there we can automatically we can stop the wear testing, which we can improve the wear testing efficiency. For example, before maybe one day we test one wear with 24 hours. Based on the AI model, and we can test maybe 2 wears, 3 wears, and which can optimize the wear testing program as well. And another application here is how we have this strategy flow chart, how we design the model. So based on this follogram, even for the water metering, as we know that for the feed, in most of the production monitoring, we are using the multi-phase or separator. But it's not possible to put a meter for each wear. In most of the cases, we test one wear, maybe in a month, we only testing 1 time or 2 times. But how about the other 28 days or 29 days? We don't have the data, the real-time data. So in this case, we can use in this smart RTU and with aging computing ability. So we can do some calculation, and there we can create our water metering follow model. So in other 28 days, based on the wayhead, pump information, performance, and wayhead pressure, temperature. So we can create the AI motor. Automatically, we can give the flow rate for other days. Other application case like production intermittent pumping. And this application case is that, for example, the beam pump. Some of the wear we are control the beam pump with timing wear, maybe running 2 hours and stop another 1 hour, especially for the matching oil feed with low production. So by this AI model, so we can automatically to optimize. So this control the pump and how many hours we should stop, how many hours we have to run the pump to save the energy. Here you can see there are 2 keys. Based on the comparison, we improved the efficiency more than 25% around that. And here other keys like a site safety monitoring, we can have the unit to collect all the information like wayhead information, and we can use in the camera to monitor the feed operation. If there's any like wrong behaving improperly, so there we can take the action and the system will give the alarm. Other case, this is another case in our company also we have the intelligent water injection system and our oil production system. So we can utilize the smart RTU to control the system. How much water we should inject to each tune, and what is the operation for the water nodes, and what is our production system, how we control that. So we based on this smart RTU, so we can achieve what we want. Another case as we know that in the US, they are doing a lot of operations like a fracture plugging operation. So but in the feed, after operation, most of the keys in the field, there's no facility to communicate with the control room remotely. So, but after operation finished, like drilling finished, they were demobilized. So in this case, we should have some like a device which can be utilized for the digitalization temporarily. So we can use smart RTU to communicate with the feed facility, like a sand monitor, like multi-phase. There we also can have the cloud database center, so the operator just sitting in the control room to monitor everything. So the communication, even we can utilize the satellite and the application for the communication. This is just the interface for the communication and display the data. From here, we can understand what is the flow rate, what is the pressure, temperature of the wear, and even the sand content during drilling stage. And we can monitor all the information from the office. And here is another application case is we can utilize the multi-phase for the follow-back service. And the multi-phase the data acquisition, so we can utilize our smart RTU. So we can get on the Also, the unit we can design with the mobile facility, so we can move into different location. So during the fallback stage, we can keep the unit in there and get on the data. For here, you can see it's a 4-phase measurement system. We have the multi-phase flow meter. Also, we have the sand monitor. So all the equipment is provided by HIMO. So also we have the sand management system to achieve the 4-phase measurement. So initially, we will measure the sand content from the weir during fallback stage, and there we're using the sand management system to remove the solid. And the next step, there we can utilize the multi-phase to measure the oil water gas production. And the last case I would like to share that we can use this smart RTU for the weir testing management. The traditional way is that we have to use in the DCS, and the system, as you know, the cost is high, also is complicated. So we can utilize to control the flow meter, also control the MSV. But in our case, we offer this technology. We can utilize to control. You can see, even if it's a multi-location, multi-MSV, is remotely. Also, we can have the mast. We can have the slaver RTU. So there we can communicate with the platform remotely, even 30 kilometer. It depends on the communication facility availability. So we can save a lot of cost. Compared with the traditional way, there is more than 50% you can save the cost for the hardware for the data transfer and the display and analysis. Especially also we can combine our weir testing optimizer that follow model to the system. So we can optimize the test duration. So traditional way, just perform the weir testing and get the data. They are submit the data to the end user. There's no AI models which running in the combined to the system. Yeah, this is all the information I shared. Thanks everybody, and give this a great opportunity. If any question? Any question regarding our smart RTU system and for your application, there's any protection for the future? Thank you. Thank you very much. Yeah.
Thank you, Mr. Cha. Our next guest is Dr. Shang Yong, Vice President of Business Development at Travi Systems. She will be sharing the insight into sustainable water operations with oil and gas fields. Please come to the stage.
Hello. Good morning, everybody. My name is Shan. I will be talking about sustainable water operations in oil and gas fields with the focus on an emerging sort of membrane technology which has demonstrated to show effective and sustainable brine concentration, which is typically needed in oil fields. Quickly, Trevi is a forward osmosis company, and forward osmosis is the technology that I sort of will be focusing on. We are based in the US, and we have developed forward osmosis technology for sustainable brine concentration or for the treatment of the most challenging wastewaters. A photo that you see there, or the schematic that you see there, is the CAD design for our brine concentration plant in Oman, which I will talk about in a little bit. Produced water in Oman, I think you guys all know that water is the largest byproduct of oil and gas operations in Oman. In 2024, about 950,000 meters cubes per day of produced water was generated, and that's about 380 Olympic-sized swimming pools per day. There has been a plan to reduce, reuse, and relocate this wastewater. Currently in 2024, it was reported that 70% was used for enhanced oil recovery. 13% was still deep well injected. A decade ago, about 100% of the produced water was deep well injected, but that is an extremely energy intensive process. So you are spending a lot of energy to get oil, which is not the best. And 17% in 2024 was allocated to surface water management initiatives, which is the reuse part, which I will be focusing on. where we are enabling water reuse in the oil and gas fields. We all know that cleaning produced water for reuse is extremely challenging. There's a complex mix of salts, minerals, chemicals. The salinities are really high. So typical seawater is around 35,000 milligrams per liter. In the oil and gas produced water, you have it higher than 70,000, 80,000. So it's basically brine concentration at that point. And there's unidentifiable pollutants, numerous scaling compounds, and toxic substances. So reuse is not easy. Okay. So there are multiple treatments that can be used for treatment of produced water. Multiple steps I won't go through, but initially, typically there's always a pre-treatment process. You have to remove the large particles, aggregates, and then you go to the main treatment. So this is like a primary treatment where you actually remove sediment, salts, and various particles. Depending on the end use of the reused water, you typically need a polishing step to make it fit for use. And let's say you want, typically I wouldn't suggest we use produced water for consumption, but if you really, really wanted to, you would add many, many layers of protection prior to that, right? But typically, water reuse, you can use it for non-arable crops, you can use it for boiler feed water, yeah. So these are some available texts for produced water salinities, because what I'm going to talk about is a bit more is the salinity part of the water treatment. And typically membranes are the workhorses of any water treatment, right? You have always got a membrane which essentially removes all the contaminants. And this graph here sort of demonstrates specific electricity consumption, SEC, kilowatt hour per meter cube, versus TDS, total dissolved solids in the produced water. And this graph sort of shows that as you go higher up in total dissolved solids, as it gets more concentrated, specific energy actually goes up. And membranes, typically you start off with reverse osmosis membranes, you've got brackish seawater. There's a limit to how much these membranes can actually concentrate. So from brackish seawater RO, you go to ultra high pressure RO, and then you go to OARO. And OARO is also sort of an emerging technology that has been proven, which is called osmotically assisted reverse osmosis, to be able to enable brine concentration. And then you've got forward osmosis, which is technology that I'm going to talk about in the next few slides. But forward osmosis has the ability to do high brine concentration. And beyond that, at the end of the day, a membrane is still limited by scaling compounds. And so once you pass a certain TDS, it has to go into the evaporation crystallization phase, which is MVR and MED. So what is forward osmosis? Recap on what reverse osmosis is, which is the standard membrane technology used very, very widely. With reverse osmosis, what you're doing is you're actually forcing dirty water against a membrane in a really, really high pressure environment. And the membrane acts as a barrier to reject all the contaminants and salts. And as a result, clean water will be allowed through the membrane and the contaminants will remain on the other side of the membrane. So that's essentially forward osmosis. That essentially is reverse osmosis. What forward osmosis is we actually place a really concentrated solution on one side of the membrane. The whole environment is a very low pressure environment. And what happens is we actually, through the natural process of osmosis, pull water through the membrane. So the dirty particles are rejected by the forward osmosis membrane, they're left on one side, and clean water is pulled through the process via osmosis because of the high osmotic pressure of the draw solution. Think of it as if you go swimming, your fingers become wrinkled if you're in the seawater for too long. That's because water moves out of your cells, which is the skin, into the seawater, and as a result, that's osmosis. because of the water transport. How do we remove the water from the draw solution that's now, you've got clean water and you've got our draw solution? We actually apply a low-grade heat to the solution, and this causes the draw solution to detach itself from the fresh water. Fresh water remains on top, the draw solution remains below, and can be recycled, and you get out clean water. So why is forward osmosis suitable for produced water treatment? We can treat high salinities with forward osmosis in a membrane process. As a result, we can do brine concentration, which makes it suitable for the high salinities of produced water. We can use low-grade heat. So if you have waste heat in the oil fields, flare gas, solar power, we can use that to recover the draw solution. We also can deliver reusable water quality, as well as the low-pressure environment of forward osmosis makes the CAPEX and OPEX lower. So this is Trevi's forward osmosis plant in Oman. The intake feed is around 100,000 ppm. The brine feed is around 200 to 220 ppm. We are targeting 50% recovery. It is 140 meter cube per day, 1,000 barrel a day, MLD, minimum liquid discharge system, that runs 100% on solar power. So, so that's part of the sustainable aspect. Trevi's patented forward osmosis uses the pressure gradients, as I demonstrated previously, to get high concentrations. The treated water will be used for agriculture reuse. So this is a complicated flow diagram of the brine concentration plant, but you have to bear in mind, forward osmosis is a membrane treatment process, and so pre-treatments are still required. So it demonstrates the feed, 280 meter cubes going in. You've got the pre-treatment, typically a graphene oxide, a NF, and you've got a 3-stage FO membrane recovery. So that enables us to do more than 50% concentration, coming out with a brine more than 200,000 meter cubes per day. And then we have to separate the diluted draw solution and recover the polymer to be recycled. And that goes typically into a coalescer, and you've got polymeric heat exchangers. Finally, the product water will be polished with a NF, an RO, and a GAC, a granulated activated carbon. And as a result, the permeate water, TDS is less than 500 meter cubes per day, boron is less than 0.5 ppm, TOC less than 5 ppm. Some photos of the site. First, you have the polish. You have NF, brackish RO elements just for polishing and pre-treatment. We've got the thermal storage tank, which actually holds the hot water from the solar power meant to recycle the process. And on the last picture, you've got your forward osmosis membranes left and ceramic UF on the right. That being said, I conclude my presentation. I don't think we have time for questions, but I'm hanging around. You can come speak to me after this. Thank you.
Thank you so much, Doctor. Our next speaker is Mr. Amir. He's a business unit manager at Bukaka International. He will be introducing the fill optimizer applicants and its impact on operation excellency. Please come to the stage.
Thank you. Distinguished guests, thank you to be present here in speak of fill optimizer rod pump control system. So we are in Bukaka produced mainly with mechanical rod pump controller, but we already enhanced the system with the SCADA system, the automation system at the requirement for any customer for this. So Bukaka now currently have a capability to integrate some automation system since we have about 7,000 installation base in Indonesia and some is in India and around other countries outside Indonesia. So we are put the real-time monitoring operation attached to our system. Currently, we operated the system based on customer requirement for this system to be attached to the pumping unit. So this is the target of most of our customer. We are deal with the reliability focus, especially in surface and downhole equipment failure, and also we support the optimization effort of our customer. So the target is to increase production and reduce the lifting cost. This is the bottom line of every operator, every oil operator. So the production optimization objective, this is very common in every oil producer. So we take part of this. We take a part of this effort initiative by our mostly customer in Indonesia and in some customer outside Indonesia. So Bukaka is involved in starting in the digital initiative since 2008, and we starting to put in the capability of adding some monitoring system SCADA into our rod pump system. So this is the general specification. As you see this, we have a very common configurations required for the SCADA system by our customer. So we have a connectivity protocol, I/O, and also the system that can be required for the specific detail from customer. Now, in this session, we would like to introduce you the dual speed feature. We use the variable speed drive to control the pumping unit moving up and down. Since this is very important when we operated the system in the very heavy oil environment onto the sandy well, something like that. So, as you see here, we have three model of the how we operate the pump. First, maybe you see this yellow one on timer mode. So I think if you have facing the pump off situation, so you experience with the fluid ponding, and then you set the timer using the fixed timer. So starting maybe 2000, the pumping unit manufacturer joined with the rod pump controller manufacturer to have the pump off controller with the fixed idle time and also automatic idle times. So, but this one, the fixed idle time and automatic idle time is for non-sandy fluid production and light oil. Okay, so we have some experience in Indonesia during heavy oil. So we have thick oil. So this field is under steam flood, but the formation of the oil is very unconsolidated sand. So when the temperature increase, the viscosity decrease, the mobility also increase, but at the same time, the production of sand will be also increased. So by this condition, we cannot use the fixed idle time, because after the idle time period is finished and they sum up with the, start moving the rod upstroke, the well become pump stuck. So that's a problem. So that's why we keep moving the pumping unit using the variable speed drive. So there is two methods. We create the algorithm method. We use the load cell and position sensor to create dyno cards. And using the dyno card, we can manage speed of rod pumping system by detecting the pump fillets. Okay, so we use the live dyno card based on these two probe. And if the rod pump controller will learn optimal speed of the rod pumping system, or if the RPC detect the pump fillets less than the pump setting of the fillet, so it will be slowing down. And also if the dyno card showing the let's say 95% pump fillets. So the rod pump, the VSD will be instruct the pump to be speed up. So the second method, we have the dual speed model. So with the dual speed model, the pump fillets of 5 dynamometer card manage the pump unit, the speed as the upstroke speed and downstroke speed. So it will keep manage the speed based on the downhole pump condition. The delivery of the fluid is based on that. Okay, this is the example of that speed model. This is the single speed. This is the field optimizer model. Okay, so we have a two-speed upstroke and downstroke is differently speed. So this is the data that we send to the customer. We not provide this dashboard or composite screen, but we provide the data. This is how we send the information. This is the conventional RPOC. We go to the server, but we have the edge-based RPOC with the dyno pattern recognition. So all the information will be analyzed in the well level. So this is some customer analysis software. We not provide the software, but we can push all information to other means of software owned by customer. Okay, so this is the benefit of using the variable speed drive field optimizer. Thank you. If you have any question, please raise.
Thank you so much, Mr. Amir. Our next speaker is Mr. Taib Al-Maymani, who is an NEDA Decarbonization, Business Development, and ESG. Will be discussing next-gen sustainable leaders. Please come to the stage. عادي حتى
Greetings everyone. It is a privilege to be with you today at Opes. I'm honored to stand here to share our journey at Gulf Energy, and more importantly, to talk about how next generation leaders are actively shaping the future of ESG and decarbonization through practical technology-driven solutions. My name is Taib Al-Maymani, and I lead business development and decarbonization at Gulf Energy, focusing on our NIDA environmental and decarbonization application segment, also known as NIDA segment. But beyond the title, I'm proud to be a live case study of what it looks like when companies invest in people. Gulf Energy empowered me, trusted me, and equipped me with the tools and resources to take the lead in sustainability. That's how change happens, when talent is supported, not just hired. So, let's begin with what NIDA is. NIDA stands for Environmental and Decarbonization Application. It is our platform of the integrated technologies that turns environmental liabilities into value streams. The portfolio is structured around 4 subsegments. We have our 1, water and mineral recovery, where we treat produced water and extract useful minerals like sodium chloride and lithium. 2, we have our emission detection, where we apply real-time gas monitoring using artificial intelligence to detect and quantify greenhouse gases like methane. And 3, we have flare gas utilization, where we capture flared or standard gas and convert it into usable power or clean fuels. And 4, heat capture and renewable integration, where we convert waste heat into energy and explore geothermal potential. These are not just concepts, these are deployed technologies solving real problems today. Okay. Now, let's take a closer look into water. One of our technologies, it's called DIVAR, short for Dynamic Vapor Recovery. DIVAR is a thermal desalination process specifically designed to handle extremely high salinity water. In our GCC pilot in Mukhezna, we process produced water with total dissolved solids, or TDS, up to 200,000 parts per million. The system achieved more than 70% water recovery. The output, water had less than 200 parts per million TDS, which qualifies as a high quality freshwater. And most importantly, the system operates on a zero liquid discharge basis, meaning no wastewater is returned to the environment. We also recovered 99% pure sodium chloride from the concentrate stream, showing the potential for mineral extraction. DIVAR is not just about treating water, it's about unlocking a circular water economy. Now, let's move on to emissions. Methane is 84 more potent than carbon dioxide over a 20-year period. That's why detecting and addressing methane leaks is critical for climate impact. Our solution is called Cube, an AI-powered continuous emission monitoring platform. It uses metal oxide sensor to detect gases like methane, carbon dioxide, hydrogen sulfide, and volatile organic compounds. In a field deployment in Oman Mukhezna, Cube detected a leak pressure relief valve. Once fixed, emissions were reduced by over 50%. This is the value of real-time monitoring. Problems are caught before they become environmental liabilities. Cube is MIQ certified, meaning it meets the global standard for methane reporting. This technology is redefining emission management in upstream operations. Now, let's shift our focus into human capital. In 2023, Gulf Energy, in collaboration with Oman's Ministry of Labor and OPAL, launched a national workforce program. We enrolled 40 Omani graduates in a one-year on-the-job training initiative, and every one of them was hired into full-time roles. We have 17 held bachelor degrees, 16 had diplomas, and 7 had higher diplomas. They now work as engineers, operators, mechanists, accountants, and more. This is what meaningful sustainability looks like. Capacity building aligned with Oman Vision 2040 and national in-country value priorities. Now, let's talk about measurable impact. In 2023, In 2023, Gulf Energy Nasser recorded 950 tons of carbon dioxide offset, 100,459 cubic metric of water recycled, 12,123 metric tons of waste recycled, 183,812 training hours delivered, and a significant milestone in employment. 14.6% of employment of these roles were filled by women. This is not just data, it's evidence of intentional sustainability across environment, education, and equity. It's a signal that we are not only deploying technologies, but building the team who will carry it forward. So where do we go next? We start with a conversation. What's in your waste? What are your emissions? can flare gas be converted to power? Is your waste heat being utilized? Then we deploy small-scale pilots, modular, mobile, data-driven, and once we validate the performance, we scale. This model turns ESG from a compliance topic into an operational strategy. It makes sustainability profitable. It proves that oil field operations can reduce their footprint while increasing their efficiency. To close, I return to the personal. I'm here because someone invested in me, because a company created space for growth, leadership, and innovation. That's the invitation I extend to all of you today. Empower your people, Empower your people, pilot bold solution, and don't wait for change, drive it. Because the future of energy is not something we wait for. It's something that all of us create. Thank you.
Thank you, Ms. Tlaib. Our next speaker is Mr. Carlo. He's a manager director at Neumann Answer Italia. Will present integrated solutions for green hydrogen across its life cycle. Please come to the stage.
So, good morning, everyone. It's really a pleasure for me to be here today and have the opportunity to talk about integrated solution for green hydrogen production through the complete life cycle. My name is Carlo Terragni. I'm the managing director of Neumann Esser Italia, the branch company in Italy of Neumann Esser Group. And from Italy, we are responsible for sales, application, and operation in South Europe, North Africa, and Middle East. Please allow me just to introduce the company I'm representing. As I said, I'm from Neumann Esser, and we are a reliable partner for integrated solution across the hydrogen value chain. Neumann Esser Group is a family business, so we are owned by the family Peters, and with quite long history because we were founded in 1830, so we have almost 200 years of history. And when I'm talking about integrated solution for hydrogen production and the hydrogen value chain, I'm referring not only to compressor systems, but also to electrolyzer, hydrogen refueling station, tube trailer filling station, as well as also consulting and feasibility in the very early stage of the project. Neumann Esser has a global footprint because we have almost 28 operating companies worldwide. Our headquarters is in Germany, in Humbach-Pallenberg, and we have compressor manufacturing facilities in Germany. We are manufacturing electrolyzer in Germany as well as in Brazil. And of course, we are handling operation and business locally to be as close as possible to our customers. In terms of aftermarket, of course, we have a repair coordination center worldwide, and we have partnered with the local workshop. We are also investing a lot in Germany for increasing our production capability in terms of electrolyzer, and this is the new campus and the new production facilities we are going to open in our headquarters in Germany. Just few numbers. The company has a consolidated turnover close to 500 million euro. We are more than 1,700 employees worldwide, and we have more than 5,500 compressor running half of them in hydrogen application. And we have already more than 10 references in hydrogen production as electrolyzer. So let's come to the main topic of my speech today. So first of all, I have a very simple question. So why I'm here today to talk about hydrogen? First of all, because as we know, our energy system is based on molecules. They are easy to handle, easy to transport and to store. But we all know that when we are burning molecules, we produce, or fossil molecules, we are producing greenhouse gases. So we see that hydrogen is one of the few options to replace hydrocarbons with clean molecules. And so we see hydrogen as an enabler of decarbonization in industry, in transportation, and in the energy sector. So for us, green hydrogen boosts sustainability, while the investment in the infrastructure drive innovation and economic growth. I would like to focus on a few important points. The correct CapEx decision strategy, the interdependence of the hydrogen value chain components, integrated solution through digital tools, successful operation, and also the advantage and higher customer benefit generated by integrated solution. Let's start from the first topic, so the correct CapEx decision. We all know that renewable energy is very volatile. So we have fluctuation in the energy coming from wind and solar. And the hydrogen generation, okay, depending on the quantity and the available power, in most of the cases, a combination between the alkaline and the PEM electrolyzer for larger production, and the PEM electrolyzer for smaller production. I would like to present you a very simple case study. So let's take as an example the hydrogen production coming from a 200 megawatt electrolyzer. So we are talking about 40,000 normal cubic meter per hour hydrogen produced. Let's assume that we have to feed hydrogen into a pipeline, so with 80 bar pressure. And of course, we have hydrogen saturated with water. We have a suction temperature of 30 degrees Celsius, interstage and after cooling temperature 40 degrees, and we can allow 5 degree increased temperature on the water side. So if we start with, or if we produce hydrogen with the alkaline electrolyzer, actually we have hydrogen available at 1 bar atmospheric pressure. So this means that we need a huge compressor, reciprocating compressor, 8 cranks, as you see. So we need the biggest frame size available with 8 cranks and 5 compressor stages. First and second stage, they are not really loaded, actually, because we have very big cylinder, and you can see these are our owners. So you can really guess the dimension of the cylinder. So the first and second stage, they are not really loaded. And but we need such big cylinder because of the atmospheric suction pressure. So we have a power of 7.5 megawatts needed for the compression. And only the bare compressor, the weight is 240 tons. So we have really a huge, huge compressor. If we are producing hydrogen from a pressurized PEM electrolyzer with hydrogen available at 30 bar, and we always need to compress it to 80 bar for the injection into the pipeline, then you see we need just 2 stages of compressor instead of 5. We have 1.7 megawatt installed power, The compressor is very small, compact. The weight is only 20 tons. And and I forgot to mention before that with the atmospheric pressure, we are producing 1 ton per hour of water. In this case, we just have 10 kilograms of water condensated per hour. So you see that actually the way you are producing hydrogen has a strong impact on the compression downstream the production. And remember that every time you produce hydrogen, if you want to use it, to transport it, to store it, you need to compress the hydrogen. Just a comparison table. So again, the same case study with 40,000 normal cubic meter per hour with a different suction pressure. I have already presented 2 cases, 1 bar and 30 bar, but you see also intermediate pressure coming from alkaline pressurized electrolyzer. So you see that in any case, we always have, with 6 bar, we will have 4.5 megawatt installed power. With 16 bar, we will have 2.7 megawatt installed power. I also would like to mention the importance to have digital tools for the design and simulation of the integrated solution. This is, for example, the tool we are using to design and size the complete hydrogen refueling station. So when we are talking about hydrogen refueling station, typically we are talking about an electrolyzer to produce hydrogen, 1 or more compressor to increase the pressure from 30 or 20 bar up to 1,000 bar, because for the cars you need to store hydrogen in the tank at 700 bars, so you need to compress hydrogen at least 800 bar. Then we have storage, and then of course you have dispenser to refuel cars or EV vehicles like buses or like trucks. So we can simulate everything with these tools. So it's really important to have the support of digital tools. Last but not least is the support from digital tools and also the support of data collected from the plant in order to ensure a smooth operation of the complete plant. So in terms of availability and optimization production, in terms also of asset performance optimization as well as predictive maintenance. So with our digital tools, we can collect all the data, the information coming not only from the plant, but also from the user's profile. So we can say, okay, we know how many cars are coming to the hydrogen refueling station for refuelings, how many cars per hour, how quick they want to be recharged, and so on. And then, with an overall digital approach, we can optimize the full solution. Just allow me to show a few references. These are electrolyzer from Neumann and Esser currently running. The first one on the left side is 1.3 megawatt PEM electrolyzer producing green hydrogen in Fortaleza in Brazil. And we have also 1 megawatt electrolyzer system in south of Germany, in Bavaria. We are also executing an interesting integrated project. This is for Europe, where actually we are supplying a complete tube trailer filling station, where we are producing hydrogen with 10 megawatt PEM electrolyzer. We have 2 45 cubic meter low pressure buffer storage. We have 2 3-stage diaphragm compressor to compress the hydrogen up to 500 bar. And then, of course, we have the high pressure storage for the hydrogen and the trailer filling station. Another interesting project I would like to show you is this hydrogen production plant together with trailer filling station and hydrogen refueling station for heavy-duty vehicles, for buses. So in this case, we have a 2 megawatt electrolyzer. We have hydrogen refueling station up to 350 bar to refuel buses. We have hydrogen storage to store approximately 1,400 kilograms of hydrogen at 500 bar. And so we can supply, like in this project, everything as a turnkey solution, so the full integrated solution. Interesting project. This one is for a 20 megawatt project in Europe. This is in the steel industry application. So the client would like to decarbonize, so to move from hydrogen produced right now from steam reforming, so a gray hydrogen, to green hydrogen. So we will supply 4 modules of 5 megawatt each hydrogen production, so 20 megawatt in total, again with compression. The first phase is hydrogen production for the steam plant. The second phase, there will be an integration of the hydrogen production with the hydrogen refueling station for cars, for 700 bar fuel cars. Last but not least, this interesting project for sustainable aviation fuel production with 11 modules of 5 megawatt each, so 55 megawatt in total of hydrogen production. As I said, we are talking about a traditional refinery sector, but for the production of sustainable aviation fuel final product. And this plant is going to be in operation in 2026. So for me, it's time to wrap up my short presentation, again, on 3 main takeaways. So we strongly believe that hydrogen is one of the key components to support defossilization, decarbonization, and to achieve climate neutrality. Integrated approach, taking into account the interdependence of the different elements across the hydrogen value chain, is of key importance. I've just shown you how the integration between hydrogen generation and hydrogen compressor is important. And also we think that technology, as well as consulting, feasibility, and implementation from a single source, can generate competitive advantage and also bringing added value for our customer. So we think Neumann Esser is really a one-stop shop for integrated solution across the hydrogen value chain. So this is the end of my presentation today. Of course, if you have any question, I'm fully available for interaction and replies. Thank you so much.
Thank you, Mr. Carlo. Our next speaker is Mr. Pandi, who is a country manager at Nasser, Indonesia. He will be sharing a success story highlighting the implementation and benefits of CCUS. Please come to the stage.
Good morning, everyone. Very glad to be here this morning. I would like to share our project success story in Indonesia. My name is Pandey Susanta. I work for Nasser Gulf Energy here. So I will start my presentations with a map of Indonesia for those of you who have been to Indonesia or have not been to Indonesia. It's a nation with thousands of islands. We have a total of 17,000 islands. Here in the map you can see the big 5 of the islands. just to show how complex is the logistics when you try to do a CCUS projects. You can also see in the map the 15 priority projects from the governments for the CCS and CCUS of Indonesia. It's spread throughout the country, and I'm proud myself with the teams, we are involved closely with the governments to implement these projects. The first two projects is Project Sukawati, circled in red, and you can see project number 1. And then the second one is Project Jatibarang. Indonesia, we pledge to be carbon neutrals by 2060, probably a bit later compared to many other countries. But considering the complexities and the developments of the country, we also have an ambition to continuously growing the economy at a pace of 5% every year, for which we need energy. Currently, we consume 1.6 million barrel oil per day, where we only produce 600. So we are importing 1 million barrels every single day. Hence, we need to enhance our oil productions, our oil recovery, while trying to minimize the CO2 emissions. And that's why all these projects become top priorities. We also have a potential for CCS hub. About 600 gigatons of CO2 has been estimated can be stored in Indonesia, in saline aquifer as well as in brownfields. We also just established regulations, a presidential decree that regulates the CCS and CCUS. I guess now we are among a few countries that have the carbon exchange. So we trade carbons domestically since 2023. And then beginning of this year, we have started trading carbons internationally with some of our neighboring countries. So when we want to address the CCS and CCUS projects, obviously it's a very risky project, very expensive. Some of them goes to $1 billion projects. We need to understand the risk. We try to categorize the risk into 3 different categories. The first one is the subsurface risk. The second one is the surface risk. And of course, the economics and regulations is also a business risk. When we talk about the subsurface, we need to understand where can we store the CO2, the characteristics of it. And we need to do the simulations, reservoir simulations, static simulations, dynamic simulations. And then we also need to make sure we can inject into it so that we can store CO2. Then whether it is compatible, whatever is already in the reservoir fluid, it has to be compatible with CO2. And then the integrity of the seal or the cap rock itself, also of paramount importance. The risk at the surface, this includes the capturing of the CO2 itself from the emitters. This can be from a different industry, can also be from the gas field itself. The projects that we are working on is actually a gas field that has 30% CO2 contents, right? So we need to understand how to capture it. Then after we capture the CO2, most of the time, the source or the capturing place are far away from the storage or the sink place. So we need to transport it, whether it is with pipelines or some intermediate solutions, in which case we use what we call virtual pipelines. That has to be very efficient and sustainable. Now, probably unique to Indonesia, because many of these sites are in populated area, so we also have to consider the social responsibility to the peoples who live in that area. The third category is on the regulations. I think I have discussed this earlier. Fortunately, we do have the regulations already. Now, the economics part of it, it's a big question that the industry is trying to address with the technology and the demands of CO2 and the big global drive of emissions reductions. So we try to understand even more details into this risk and try to map the risk while mitigating the risk, right? So here you can see we try to first describe the risk itself. Obviously, at the beginning of the project is at the highest risk, represented by 100% or high, moderate, high risk here. And toward, the more you do it, the more information you get, the more confidence you get, and the risk become less. So we try to split into, as you can see, 6 different phases. So this is what we call the steps. Steps number 1, which is the study. This is trying to understand the subsurface itself. We use the technology, as we all know, the reservoir simulations. We started with the static models, the geomodelings, and then we also implement the dynamic models for the brownfields, a field that has been produced. So we try to understand the behavior of the storage. So probably we can allocate around $1 million, at least in this project that was the case. And then we can get a little bit more information on the reservoir itself through studies. And the other study that we can do is the lab studies, core floodings, MMP studies, to make sure that the compatibilities of reservoir fluid with the CO2s. With that, we can move to the next steps. And this is involving the actual CO2 injections. We call it hop and puff, where you inject CO2 to a single well and then soak the well for probably a week or so, and then put it back on productions and see how does the production change because of the CO2 injections. In our case, the initial indications was very encouraging, right? The oil produced more than before the CO2 injections. So it was allocated about $3 million, and we get those informations. We also calibrate the studies, the dynamic and static models, and we prove the compatibility of the CO2 with the incrementals of oil productions, and we have more confidence. So we move to the next step. The next step, which is the interwell. So in the map, you see the red font is what we are looking for, and then get calibrated and confirms on the next steps, whilst we are also trying to gain some more information, right? So in the interwells, we try to see the let's say sweep efficiencies and the interactions between the injector wells and the nearby wells. And here we can see the lateral expansions of the CO2 and whether we can see some vertical expansions of the CO2 inside the reservoir. I'll discuss more in details the type of technology that we implement on each step. And then the following one is the pilot steps, right? So it's like very small step at a time, and we gain more confidence. Hop and puff was 3 days injections, interwell 30 days injections. Pilots, we are planning to do 1 year injections. So it's tenfold. Before we embark into the full field, which can cost us about $500 million. But if you see the map itself, it illustrates that with the steps that has been taken, the risk has been mitigated and the confidence level increased before we really invest and put the big number of costs. At NESR, we provide the holistic approach. As I mentioned earlier, we study the subsurface, and then we also monitor the emissions, MMV. My colleagues earlier explains a bit more in details on our NEDA segments. And then we also have the capturing and transportation technology, and as well as the injections of CO2. Now, going a bit more into details to the project, this is the project number 1 I highlighted earlier on the first slide. This is located in East Java. It's a carbonate reservoir, and it has recovery factors up until today about 30%, and it still have huge potentials of productions increase. That's why it's been selected to be the project. And nearby to this field, there is another much larger gas field which produces 30% of CO2, which in the future expected to be the source of CO2 for the EOR in this field. So it's like killing two birds with one stone, trying to address the emissions problems from field M and then trying to increase the productions in the adjacent field, which is field S. And close to that area, there is also industrial area where they produce or emit a lot of CO2 that can be also utilized and captured and stored in this field. The biggest risk of this project is the safety, the HSE. Why? Because the locations is actually in the middle of town with population about 1 million people. And the field itself has very high H2S content, 2,500 ppm. So this can be very little, multiple catastrophic potentials. So it has to be addressed. So the technique and technology that has been deployed for this field is a closed systems with continuous monitoring, and it's a Okay, so to address that, we implement the closed systems, production systems, and then continuous monitorings with several sensors, right, to make sure there is no leak, and every activity has been done with this risk as a priority. Now, moving on to the operations challenges. The source of CO2 itself, although we do have adjacent field that produce a lot, but they have not yet been captured and liquefied. And the second challenge, there is no pipelines between that field to the sink field, the field S, right? So how can we get the CO2 for the hub and puff and interwell injections? We have to source the CO2 from a different industry. In this case was the petrochemicals industry. They already have some CO2 liquefations. So we get the CO2 from there and inject it to the injector wells to do all these steps that we have done. Going forward, we will build a pipelines between field J to field S to supply the CO2. Okay, just more details on the steps and phases that we have taken. So we have this one, the study is to understand the subsurface. So we did the static and dynamic modelings. And this is the second phase, which is the hub and puff. As you can see here, the actual photo from the jobs, the actual pumping chart. We monitor several parameters, not only the pressure, temperatures, which is very critical to always understand the phase of the CO2 itself. And with the equipment setup that we have, we successfully injected a total of 500 metric tons of CO2 in this stage. Now phase 3, which is the interwells, require much larger volumes. So instead of 500, we go for 2,600 ton, and we still does not have the pipelines installed yet. Hence, we have to use virtual pipelines. We deploy 50, total of 50 trucks that goes back and forth to make sure continuous supply of CO2s. So this is the solutions, right? I think some of them I have mentioned earlier, but our approach is to deploy fit-for-purpose solutions, and it was developed specifically for the projects with those challenges that I've mentioned earlier. The first one is to supply the CO2 continuously, as if we have pipeline. But since we don't have pipeline, so we use virtual pipeline. 20 of ISO tanks that goes back and forth in totals of 50,000 kilometer trip going back and forth. And then We have the equipment. As you can see, the actual photo is quite portable. It's based out of cryogenic pumps. And we have the equipment that change the phases, which is what we call INDA. This is the indirect automated electric heater to make sure that we are able to pump CO2, whether it is in liquid phase or in gas phase. And we can also switch. So the entire systems has been monitored with our in-house built technology called DARA. This is data acquisitions and real-time analyzer. We can analyze the data at real time and make some decisions on site. And also for the subsurface, we implement some of the technology, which is we adopt from different surfaces and try to implement it here to get the best data that we can get. For example, the tracer technology. As some of you may be familiar with water floodings or gas floodings, tracer technology has been around, but to have tracer that can trace CO2 is a challenge. But we successfully deployed this. With that information, we know which directions the CO2 is going when we do the interwell injections. And then we use that data to calibrate our models. We also monitor the bottom hole temperatures and pressure continuously. Ideally, we need probably to use a fiber optic technology, but since we are injecting through an existing well, which has been completed a few years back, so we don't have the luxury to install fiber optics, right? So we use the existing surfaces of wireline logging, and we continuously log for 30 days. So this is probably one of the longest logging job that's ever done, right? But with doing that, we also learn the temperature profile across the wells, because we have to log up and log down just to cool down the tools itself. At the same time, we are gathering data. Okay, just to summarize, this is my last slide. So the CCUS and CCS project is a risky project, and not only operationally, but also from HSE standpoint, as well as the business point of view. And with the step-by-step approach, we can mitigate those risks and gain more confidence along the way. That will increase the success ratio of your projects. Implementing the fit-for-purpose technology not only will reduce the cost, but will also speed up the project itself. With that, I thank you for listening, and if you have any questions, we can meet on the side. Thank you.
Thank you for that insightful presentation. Our next session is a panel discussion. It will be conducted in a few minutes. The subject is the bridging capital innovation, unlocking investment in Middle East. Our panelists are Dr. Khalil Al-Hashi, Senior Renewable Energy Advisor, and Mr. Rohel, CEO of Transcontinental Energy and Service. Our third is Dr. Anila, who is the partner of ESG, and Mr. Ishaq Al-Ma'wali, Head of Investment and Cooperation Advisory, and the moderator will be Mr. Mohammed Al-Sagri, who is the Head of Sharia Structuring. Please come to the stage.
Free sitting? All right. sit here?
Or maybe we start from here.
Do you need to be in the center or?
The moderator needs to be on the side, and you can take.
We can.
Okay,
So we can sit by the order. So we take. I think you're first, right? So you. Whatever we took.
Sit here.
Maybe we. I think we'll go that way. Better remove to that side. Yeah.
So we are more.
We are more center. Yes.
Bismillahirrahmanirrahim. Assalamu alaikum and a very good morning to all. We are going to proceed with the discussion today entitled Bridging Capital and Innovation, Unlocking Investment in Middle East Energy. I know the topic is quite mouthful. In short, is that we are going to talk and deep dive about where is the money. Wain fulus, yani. Now we have talking a lot. We have discussed a lot of agenda points, key takeaways, and this cannot happen unless access to funding is there for everyone, policymaker, industry player, consultant, as well as the financial industry. So joining me on stage, we have 4 learned speakers. On my extreme left is Mr. Ishaq Ma'wali. He is currently the head of proprietary investment and capital advisory at Bank Nizwa. Previously, he was the board member at Bank Nizwa as well as the general manager in one of the biggest pension fund in Oman. Welcome, Mr. Ishaq. Next to him is Mr. Rahul Patel. Quite a colorful background. Used to be an investment banker, fellow investment banker from Merrill Lynch. He is currently the principal and chief executive officer of TCES, an E&P company. Welcome, Mr. Rahul. Next to him is Dr. Elena Primikiri. She is a seasoned consultant in the aspect of ESG, SDG, green financing, green loan, and what have you from the Unicus. And last but not least, welcome, Mr. Elena. Ms. Elena. Last but not least, Dr. Khalil Al-Hanashi. He is currently the senior. Title is quite long. He is currently the senior energy renewal advisor with Petroleum Development of Oman. And as we know, PDO is the torchbearer of Oman's oil and gas industry. And therefore, he will share with us his aspect. I'll go to him first, basically with regards to PDO role in this aspect. So, and, last but not least, the moderator for today, I'm Muhammad Nur Anwar bin Sajari from Bank Nizwa, currently the head of structuring, overseeing the structuring for both carbon-based and non-carbon-based economy in Oman. All right, over to you, Dr. Khalil. PDO all this while has been branded as the oil and gas torchbearer flag company in Oman. It's very big, and everybody looking at PDO as a policy. What you do is going to set the industry further, be it from the industry player oil and gas, be it from the contractors and subcontractors, as well as the banking. Yeah. So we would like to see, as you know, right now, Oman has a very ambitious net zero carbon target in 2050. And then Oman also is progressively promoting its non-carbon based economy, including hydrogen. We would like to know, how do you see PDO is playing its role, and to which direction the company is balancing its future play? Can you share your thought with us? Thank you.
Thank you for the question and for the invite to be in this panel. I think if we rephrase the no carbon into adding the letter L and making it low carbon. So in essence, that is what PDO purpose, which is to build a sustainable and low carbon future to maximize value for Oman. So this is our about 2 years rebranded purpose. So the focus on low carbon is what we think will drive the prosperity of the country here. And then when we talk about low carbon, that entails some modifications or some adjustment to the way we do business today. And we normally start with our own energy consumption. So we produce oil and gas. Indeed, that will remain the core business of PDO. The way we produce oil and gas will change or is changing already in a way that it has to be done in a low carbon manner. And we start with our own energy consumption. So we consume quite a lot of energy as well. So more and more of our own energy is coming from renewable energy, for example. And I was just discussing with the panelists that the first utility scale solar farm in Oman was actually set built by BDO back in the days. Today we also have 2 wind farms in the contracting stage and another solar farm. So our own energy consumption will become greener. So we reduce the carbon intensity of our product. The other aspect that we really focus on is our operations and the efficiencies within our operations. We deal with methane, and methane is one of the sort of potent gas, or the climate impact of methane emissions is much, much higher than CO2. So in a future where we are climate cautious, we are all part of the solution. We're doing a lot of work to really manage our methane emission. And recently we have achieved the gold standard in methane management. This is an OGMP 2.0, which is an oil and gas industry standard that gives you different levels of adherence to the standard. We are a gold standard methane management company. That means we really focus on the efficiencies of our production, consuming greener energy, but also ensuring that we do not, we operate in very efficient manner, whether it is on emission detection or emission reduction, but also on efficiencies within our equipment. So in a nutshell, we're moving into being more CO2 footprint cautious while we stay in the core oil and gas business, because we believe in the future it's not only the price of the oil that will be differentiator, it also will be the carbon footprint will become a differentiator slowly in many commodities. And so we are ready for that future, which will be a low carbon future, and we are where we wanted to continue to be a key player in the energy sector in a low carbon and sustainable manner.
Thank you very much, Dr. Khalil. He touched upon a very important point on the solar just now, which is now an upcoming sector in Oman. I'll go back to you with regards to the how PDO basically manage, for example, your the industry waste. So this is perhaps, we know at the outset PDO has set the bar when basically the operator, the company who do the services, the contractor for PDO, they have a certain standard to meet as far as PDO is concerned. We would like to know also what happened to the industry waste, how PDO is dealing with this on the second round. Later I'll come back to you. Thank you very much, Dr. Khalil. Dr. Elina? All right. This is, of course, your specialty with regards to coming out with policy and to advise the companies out there with regards to the ESG, for example. Now, many companies these days feel that, I wanted to say they are perhaps confused with the spaghetti of words, ESG, SDG, green industry, green tech, what have you, sustainable financing. So all these are spaghetti of words, and sometimes they confuse. In fact, even external ratings also they are juggling. What aspect do they look at? So if they say, for example, a company wishes to proceed with this ESG agenda, can you share your thoughts? How a company, for example, from the mid-size to big one, how can they start? Where to start and what to be focusing on? Over to you, Dr. Elina.
Thank you so much, and thank you so much for the invitation to be in this panel. I appreciate it. How we start the journey for our companies that we collaborate is, first of all, we do this materiality assessment. We need to understand what is important. And this importance is mainly focused on the expectations from all stakeholders, be it the regulators, external stakeholders, so regulators, investors. You mentioned about the rating systems, you mentioned about the reporting frameworks which are mandatory. You mentioned on different things. So the expectations are different, be it from the clients, be it from suppliers, but also internal. Top management priorities, employees' expectations, as well as the sustainability teams who work internally. This step is the most important thing, and it has to happen every 2 years because the expectations change. The regulatory frameworks change. So companies need to build resilience around these changes and understand what are the risks and opportunities which are relevant for this specific business, for the specific industry, at this specific geography, and as well as this specific time of this specific year. So once you draw these, I would say, material topics, you identify what is relevant, what has priority in our organization, depending on the environmental, but also social and governance aspects. That's when you start the journey. Then you develop a robust framework. Now, we've seen a lot of organizations having the best plans in place, but if the governance is not there in place to ensure a seamless process of the implementation of this roadmap, then it won't work. So a robust framework would have a very solid vision, mission around this area. It will have a very good governance structure, and it will have specific policies and processes whereby the organization will be very well aware of. Of course, to establish that, you need to have trainings, you need to have internal awareness sessions, change management. A lot of times, that's for sure something we need to look into. The fourth step is to build up the roadmap. Now, the roadmap would have elements of climate risk assessment and scenario analysis, that you need to be aware of the risks that could affect your balance sheets at the end of the day. The second thing is you need to ensure what are the opportunities through a decarbonization strategy, right? Like what you mentioned before about the first solar energy plan. And to understand what are my targets, what are the important things that I need to achieve in that specific span of time, short term, medium term, long term, and build specific steps, initiatives that will feed that overall target. Now, the reason you need these structured approaches is that we've seen in the past organizations doing a lot of initiatives, but they were not contributing to the overall agenda of the company. So you need to be very focused on the things that organizations need to focus on the priorities they're having to ensure a smooth, I would say, journey. And the last thing is the reporting and building the transparency around the things you're doing. Now there, of course, there is a plethora of reporting frameworks, I agree with you, and the reporting and the rating agencies. My suggestion always is just follow what is relevant for the region. So I would go with, whatever the stock exchange mandates in terms of reporting framework, and be a little bit proactive in terms of what is coming. So for example, IFRS S1, S2 is something which has been established, and it seems that it's going to be also evolving in this region. So I would start my journey to understand where am I, what are the gaps that I have through this new reporting framework. So proactively, I can prepare myself for what is coming. So there I'm not overwhelmed with what is happening, and I just keep myself, in pace of what I need to report on and how.
Thank you very much, Dr. Elena. It is nice to hear, especially your practical suggestion to start with the materialistic assessment. And in fact, many companies are looking into this journey by having this materialistic assessment. That's one of the funny stories here. Not happening in Oman. In one of the jurisdiction, they start off the materialistic assessment to the extent that it gives them a nightmare because it requires them to change the entire business model. So I think I will deep dive into this. We have the time on the second round on how we can push forward from this journey materialistic assessment until the reporting, which is another, I think, stumbling block that we have to look at. Okay, over to Mr. Rahul Patel. Well, TCS, if I'm not mistaken, it is an E&P and a service company, yeah. And then you have a very colorful investment banker background, whereby access to funding, we say that it is based on the three principles: better, cheaper, faster. And then on this aspect, you did mention that you wanted to highlight about the access to private equity funds. And perhaps this also will change the business model of a certain company. Can you please elaborate on that point?
Sure. So when it comes to when it comes basically to looking at oil and gas service sector, specifically in the today's environment, the most important aspect when it comes to raising funds or access to capital is every service company needs to make an account and needs to make sure that there are favorable terms, there is flexibility available out there in the market, competitive interest rates, equity financing are aligned with their cash flow, which is a very, very important aspect because as a service company, you're carrying a lot of capex as well as a labor investments. So flexible debt structures are also another very, very, very important aspect when it comes to raising debt or raising capital. And it has to align with your capital structure, it has to align with your cash flows. Access to senior debt and mezzanine debt is very another important aspect which needs to be looked into while raising funding or raising capital. We also look for access to diversified pool of investors, which means private equity firms, ESG funds, banks, etc., other debt sources. The wish list, basically the wish list of funding is a combination of cheaper debt, longer debt, and with a lot of options of variables. Also, debt has to be structured in an oil and gas service company in a manner of allowances. Market conditions are not always same. Utilization rates are not always same. We are some days dealing with market conditions aligned to $100 oil versus $52 oil in less than 6 months or 8 months sometimes. So it is extremely important for a service sector to ensure that proper capex is available for you in the marketplaces. Shorter term fundings by NBFCs or capital companies is not really an option. Longer term healthy funding is a very, very, very important aspect of it.
Thank you, Mr. Rahul. Okay, I'll go further later on, especially you talk about the access to funding. Now, what do you think if, for example, a company would like to issue a certain instrument, be it debt or equity? What do you think? Because now we have changed sides, right? From the financial advisory to the one who runs the company, which is on the supply side. So from this angle, how you think you can merge these both worlds to make this company or this instrument a darling to the investor, be it ESG or those who look for the sustainable investment, both in terms of the capital protection as well as the gain on the yield? Over to you.
So in terms of raising funding when it comes to ESG investments, a proper roadmap for ESG, long-term ESG stewardship is required. A decarbonization investments in electrification of your fleets, your engines, your machines, whatever service sector you're sitting into. Just to give you example, we have almost 5,000, as a company, we have 5,000 diesel engines in the company. Our goal in next 4.5 years is to convert every single engine which is diesel oriented or hydraulic oriented into an electrification model. So a clear, robust strategy of energy transition, a roadmap, is required by all service companies moving in future to attract ESG investments and ESG funds. And there has to be a lot of transparencies when you come to ESG reporting. Just to give a basic example, when you get on a certain well location and you have an electric fleet, doesn't mean you earn the whole credit of ESG or a decarbonization. It has to start from the moment you are prepping your fleet, from the moment you're driving your fleet to any certain engines or any certain frac pumps or etc., whatever equipment you have. A proper, robust reporting from the start to finish is required. Transparency. Every ESG funds or any ESG commitments are going to look at the transparency of your reporting. Under-reporting, just value-based reporting is not an option. So to unlock a lot of ESG capital, transparency in reporting, a clear roadmap, decarbonization strategy, electrification strategy are the most important aspects of governance.
Thank you very much, Rahul. Well noted on that. Okay, moving on to Mr. Ishaq Ma'wali. We would like to draw from your experience running one of the biggest pension fund in Oman back then for a number of years. And then right now you are with Bank Nizwa, the one who will advise the company. So perhaps you can share with us from your perspective, if you're talking about the pension fund, sovereign wealth fund, or GRE in Oman, government-related entities, they have access to liquidity, number one. They have very deep liquidity as well, to the extent that they are very picky to which stocks or what companies they would like to invest. And then having known this, if we look at the ESG or SDG index, some companies are technically underperforming. And because this day money matters, and they said every fulus, every baisa count. So can you share with us, perhaps from this sovereign wealth fund or sovereign wealth fund as well as the pension funds in Oman, what actually in their mind when they actually thinking to invest or support a company who wishes to start the ESG journey? Thank you.
Thank you, Brother Muhammad. I think most of my colleagues, they have touched up on certain areas that will complement the full picture of ESG investment or sustainability. I will start, and I do agree with my colleague Rahul when it comes to the financing and the clearness of the roadmap. That is very critical, even from the investor point of view. If I would start with the previous experience, you mentioned the largest pension fund globally, and in particular Oman, they are mandated and they are requested not only by the local government, by the even international association, like the association, what you call the ISA, the International Association for Social Security Pension Funds globally. They are required to invest actually in sustainability and these kind of investment. There is certain KPI in this, and I would say that either the pension fund or the sovereign fund, they do share a very common important factor between them. One, they are indeed they are long-term investments, and the way they do it, the patience they have. In addition to that, their risk tolerance, so they can wait and they are patient for these companies to actually realize a profit. So when it comes, because of these two factors, they, as sovereign funds or a pension fund, they play a critical role in this catalyst in terms of the energy transition, investing in this. They are looking at not only as a KPI from the social perspective, but as well as in terms of performance of those companies. I think the time is still there. There is really a niche in this sector. Return is there. So when it comes to the sovereign fund, they are helping and supporting by allocating indeed the capital to these companies, by trying to supporting the blended structure finance and encouraging these kind of partnership. I think there we have examples here in Oman and globally where the sovereign fund of the country, they do partner with certain stakeholders within the country, and they fund them in order to help that. Investing in ESG stocks, that is very important as well in terms of adding to their support for this. There is a type of investors who are really upscaling this kind of companies. And in particular, I'm talking about private equity. When the private equity funds, they do invest in these kind of investments, I'm sure they are they are there to help and to add a value in certain areas in the specialty that they do have. So they do invest, let's say, 30% or 40% in the company, and they sit on the board of that company, and they specialize in certain areas like technology or transformation that will add a value. So any investor, if he see, as Rahul mentioned, if there is a roadmap, there is credibility, there is the company is very serious, cash flow is promising. So I think, Mr. Chairman, it will be promising for any investor to be in that investment. So to conclude, I think the three examples I get, either a normal investor like we in Bank Nazwa, or a private equity, or a sovereign fund, they read really that credibility, so they will invest in this. So there is a regulatory side of it, there is really a cost side of it, and I think that's really a promising investment, and we are here to help. Thank you so much.
Thank you very much, Mr. Ishaq. Time is not with us, unfortunately. Time is very limited. I wish I can open to the floor if there is any questions. Otherwise, we will ask perhaps one of the two panel to do the wrap up. 1, 2, 3, 4. Nothing. All right. Moving on to yes.
I want
Dr.
to
Alina.
add something to
Sure, please.
what you were saying. So we're, in addition to 100% agree, in addition to that, I would say that we are seeing also international banks having some financial instruments. So we're seeing the sustainability linked loans and green loans and social loans and green bonds and social bonds, which all kind of contribute into raising capital within the company. So once the plan is in place and there are specific roadmaps, as you mentioned, portions of it could be funded by banks, or you could raise a bond within the company, so that you could actually have access to capital to kind of facilitate a little bit the journey.
Thank you, Dr. Alina. You want to add?
Maybe I can add a little bit to it. So today's marketplace, we still see an option of not having a fully integrated ESG when it comes to unlocking capital. But 10 years down the road, 5 years down the road, I don't think that is an option. Investors, board of directors, young generation, Gen Zs coming in, they are going to demand this. So it is better that we put this policy framework when it comes to regulatory, when it comes to our financial discipline, and as well as our emissions discipline in place today. Today's in place will result in tomorrow's success for everybody. So from a service sector perspective, from an E&P perspective, it has become a very, very important aspect today to have departments, committees based for this, focused on this, focus groups on it, and which will lead to the financial success of any E&P or any service sector company, or any, matter of fact, any energy company in general. That's why. Thank you.
Thank you, Mr. Rahul. Before we conclude the session, perhaps I'll go back to Dr. Khalil Al-Hanashi on behalf of the panelists here. You know that, again, I'll go back to PDO as the case study, because PDO is sitting at the center of everything with regards to oil consumption, sustainable objectives with regards to oil and gas industry, waste management as far as the oil and gas industry is concerned, renewable energy and what have you. Just now you raised a very important point and very interesting point on lowering the carbon emission. Instead of too much focusing on making it a net zero carbon, you are being more practical to highlight that we should be focusing to lower the carbon emission, go to the renewable energy, and then making the process sustainable. So perhaps you can share with us within these 3 minutes, we call it sudden death if you play football, what is the key takeaway that you can share with us as far as the ESG is concerned? Thank you.
Right, thank you for the question. I think I will latch on the point raised by Dr. Elena here. You really need to understand your material topics. Like, what is it that makes difference for your business? When you look into the ESG technologies, innovation, you are overwhelmed by so many newcomers. And unless you first set your mind on at least 3 top material topics or impactful topics for your business. Once you create that understanding, you move to the next step on getting the right investment for those topics. And saying that we need to also be very cautious in a business world, that to prioritize what I call projects that are good for the climate but also good for the wallet. There are certain projects that have a double sort of impact. They are helping your sustainability sort of agenda, but also they are also profitable, or their MBV of those projects is good or promising. If you go to your board of directors and start listing all your sustainability wish list, you normally get sort of the look, we don't have all the money. So being very selective and having your material topic identified, then a list of projects prioritized in a way that it does not impact your financial flows. Because at the end of the day, if you go too sustainable, too fast, you probably break the wheels. If you go too slow, you probably miss the boat. But ability to calibrate your speed and scale, I always refer to the speed and scale, how big and how fast you move into those sustainable projects is very key in going forward. And I think that is my take on anybody who was in the strategizing or planning, because we in this region, we're still in that early phase of implementation. A lot of people still in the strategy and planning phase. Demonstrators, few projects were actually initiated. The vast majority of the business is still in the traditional sort of sector, slowly moving in, but then the business environment, as was highlighted, $100 oil to $50 oil in 6 weeks is very volatile. And our ability also to react with agility to what happens around us is very important. If the ESG rating becomes the top priority for the project you are doing, focus on that project, improve its ESG rating so you can get the financing flowing into it.
Thank you very much, Dr. Khalil. Time is of the essence. Unfortunately, this is a combination of, I would say, nearly 100 years of experience between the panelists, and we are being asked to compress all in within just a mere 40 minutes. And the topics are of importance, and I believe all of us have benefit a lot. And of course, you can always have the side discussion. I'm not sure whether that is free consultancy or fulus, as we're talking about. I mean, you can always access to the speakers right after the session. And on that note, on behalf of the organizer, I would like to thank Dr. Khalil, Dr. Elina, Mr. Rahul, and Mr. Ishaq for your succinct points shared with the audience. And inshallah khair, if all goes well, we are going to see you again next year in Opes 2026. With that note, thank you very much and see you at the top. Assalamu alaikum and good afternoon.
Thank you.
Thank you, Mr. Moderator.
Thank you.
Thank you all for that insightful discussion. Our next speaker is Ms. Huda Al-Hajri. She's an HSE Offsite Advisor at Oman LNG. She will be presenting Oman's LNG journey towards zero drops prevention. Please come to the stage.
Okay, فوق. كيف؟ بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Good morning, ladies and gentlemen. Welcome to this session. I am Huda Al-Hajri, and I am here to present to you the success story, Zero Drop Initiative at Oman LNG. And before I go to my session, I would like just to give you a short background. A drop object, or we can say drops, it's one of unestimated hazard in industries. A small bolt, or you can say a loose tool or a radio slipping from height can cause a high significant injury or also a fatality. From this perspective, we start our journey. Okay. So as we said that a drop object has caused serious injuries and also fatalities in oil and gas industry. And according to the statistic from IOGP, which is International Association of Oil and Gas Industry and Producers, from oil and gas producers, said that around 27 of all fatalities counted from drop object, and also 35% of high potential incident in oil and gas industry was reported in 2023 is resulted due to the drop object. At Oman LNG, we realized that the drop object was not just a hazard, it was a silent killer, especially during our turnaround and major maintenance. Why is that? Because we have a high number of people working in the same place and also a multiple of activity happening in the same area. So a drop object incident accounted for 50% of high potential incident in Oman LNG in 2021. And you can imagine if one of these drop objects that we have experienced fall on somebody. Luckily, alhamdulillah, no one got injured. But if you see a beam trolley weighted 150 kg dropped from height of 3 meters. What can happen to the person who will be in the ground level? Of course, we will have a fatality. So from that moment, we said enough is enough for drops. We start our journey. It was the change point for Oman LNG, and we are here to share with you this successful story. So initially, what we have done is that we conducted a workshop for gathering all the stakeholders to brainstorming on the causes that led to have such incident in our facilities. And from this, we can see that there is a number of causes has been identified, and also what kind of drops we experience and in which location to give more focus and to zoom in that areas. So we have 3 top causes. First one was improper skewing of the load. Can I have a mic? Improper securing load and ineffective. The second one was ineffective inspection regime in terms of the way we were carrying out the inspection. And the third cause was uncovered platform. This was the top major causes we have experienced from the past years. And what kind of drops we had? We had a beam trolley that fall from height and also some bolt nets during the shutdowns. And the most common identified object was the chain, which has repeated twice in our facilities. So when we decide to set the vision of stopping or eliminating the drops in our facility, we also initiated and conduct a workshop, as I stated earlier, to help to gather all the challenges and also to set the solution for this to reduce and eliminate the drops in our facilities. And then after that, we get the management support. After we get the management support, we establish a drop prevention plan. It was a smart plan that is all. We get a massive support from management to implement, and we were monitoring that in a yearly basis of the target that's set in our plan. Also, we have a training and awareness. We have trained and conduct a lot of awareness campaigns to all levels of the organization to let them to increase the awareness of what mean of drops and where we can found it, at how we can prevent it as well. And then also at the central stage of this initiative, we have appointed 40 drop champions. Their role was mainly to help us. They were trained, first of all, they were empowered, and also they were led this initiative and best practice in our facility to ensure that we have a stable and constant performance in all our sites. So now the question maybe will come to you, how we are ensuring that this initiative is going to be sustained. So the way we have sustained this performance is by integrating this practice into our annual corporate HSE and assurance plan. And also we have a regular site inspections, audit, and also a quarterly hazard hunts to spot proactively these drops before an incident happen. So also, it's not only that, we add the drop calculator as part of our permit to work process to ensure that we are addressing, we identify the potential drops and also addressing the risk of drops before it's happening at early stage. So we are mostly moving from reactive measures in reactive way to more proactive way. So the positive business impact that we have and the result that really was surprise even to us in terms of safety performance. Alhamdulillah, we have achieved 100% reduction in recordable incident from drops, and also we have successfully reached to zero high potential incident drop objects. And of course, if we have a reduction in terms of incident, we will have a cost saving. And the cost saving will be from the injury-related cost, like medical compensation and also lost work days. It's not only that, there is no disturbance now because there is no incident. So also we enhance operational efficiency, which also optimize the resources used. Also, Oman LNG become a leader in health and safety, health safety and environment as a best practice. And proudly, I would like to say that Oman LNG was awarded from OPAL in the best practice on drops. And also, it was a kind of culture change and shifting of the mindset of our employee and business partners. How is that people start being vigilant in terms of where is the drop, what is mean of a drop, and how we can eliminate it, and how we can stop having any drop object. Plus to that, everyone become accountable to his or her area. We're ensuring that their activities are carried out safely. And people, they start feel they are valuable and also protected because we are taking a proactive. Now we are more proactive in ensuring that they are not going to expose to any hazard drop object risk. So in terms of relevance, so drop object journey, zero drop object journey is highly relevant and adaptable by other companies. Why I'm saying that? Because if you can see, there is, as part of this journey, we have developed a comprehensive drop management guide where we set the structured framework to reduce the risk of drops. And also we have integrated into our safe system of work the drop calculators and also the job hazard analysis. And also the third one is by doing a daily inspection and also audit and the quarterly drop hunt hands. This one, all these three are readily to be made or readily to be implemented. So after following this successful story, we have a lot of business partners were interested to learn and also to implement this initiative in their facility or on their site. And also we have also an industrial peer also who contacted us to learn more, and it's become more far than only from a small preventing a drop to also a lesson learned to all industries. And the good thing here to be highlighted that we have used virtual reality to enhance the awareness and the training, and also simulate how working at height be for the person who haven't been worked on working at the high level. Plus also to understand what is the meaning of drop risk. Okay, ladies and gentlemen, drop object its journey is not, or drop object is not limited to oil and gas industry. It can be also existed in other industry where people are working at height, and also where there is also tools are handled. From our journey, we have understand and learned that the drop object incident are preventable, and by ensuring that the strong management or leadership, and also I can say that strong management and also the full team support, we will be able to move from a frequent incident, a drop incident, to zero drop incidents. I am here not just to present to you this story. However, I am here to share with you this successful story to be also implemented in your facility, because we believe that sharing is also part of our responsibility. Thank you, and you are welcome to learn more.
Thank you so much, Ms. Huda. Our next speaker is Mr. Hudayfa, AG, CTO, and Vice Chairman at Dolphin Group. He will be exploring the use of additive manufacturing in heat exchanger applicants. Please come to the stage.
Good. This is the presentation. Hello. Can you hear me? Not on this? Oh, okay. Thank you very much. No, I'd appreciate that. Good afternoon, and thank you for this opportunity to explain Dolphin's initiative regarding additive manufacturing, regarding heat exchangers and its applications. So Dolphin is primarily a heat and mass transfer solution provider. So it allows you to realize the best potential of your heat exchange systems and associated processes. Over the past few years, there's been a change in the level of fabrication methods available. So from the most exciting change has been effective metallic additive manufacturing. And we're at a stage where it is now technically and feasibly possible to consider fabricating solutions using 3D additive manufacturing. And in this presentation, I'll explain certain applications and how they could apply to requirements you have in your industry. So additive manufacturing is basically 3D printing, and it's called additive manufacturing because the source product that you have is typically a powder or a filament, which is used in order to construct a 3D construction of, it's a number of materials, but we'll primarily focus on the metallic. The traditional manufacturing methods of brazing and welding and certain forming has a restriction on the type of geometries you could use. So most of the people over here, if anyone's familiar with heat exchangers, you have shell and tube heat exchangers. So you use a tube in a shell, or you have an air-cooled heat exchangers, which are basically tubes with an enhanced surface for the fins. And you have plate heat exchangers, which primarily use plates formed into certain shapes, allowing for the heat transfer to occur. So the concept is to maintain separation of two fluids which have a delta T in order to heat or cool, in order to condense or evaporate, phase change or separate, in order for it to be refined into a intermediate or a last stage end product. Now, when we have additive manufacturing, we no longer are restricted to thinking in tubes or thinking in plates, and it does really open up a lot of potential geometries which could be used. So you have a far more complex internal geometry. Now, when you have a complex internal geometry, it allows you to increase the turbulence. So when you have fluids which are viscous, low Reynolds numbers, they will have a heat transfer coefficient far below the optimum heat transfer coefficients required, and it usually results in an extended surface area, which means larger exchangers and a higher material cost. The other major advantage is that it does remove the weak points. So when you have a fabrication process, you will have welding, or you will have gasketed or bolted joints, which is a possible weak point in the overall pressure integrity of the exchanger. And when you have a monolithic construction, it does eliminate these concerning points of contact, which might result in a leak. Furthermore, when you have 3D printing available, you no longer have an extended lead time for procurement, and you could exercise rapid prototyping. Typically, depending on the application, you might need a certain thickness of a component, you might need a certain length, certain dimension, but when you have a 3D printing alternative, the thickness, the length, the shape, the radiuses, everything is possible due to the ability of the same raw material to be used and printed into different shapes. So there are a couple of technologies which allow for metallic 3D printing. The most commonly used is the laser powder bed fusion. So it's basically a layer of the object being created. The fusion of the binding or the raw material is done using lasers, and it does have a high precision, although there are some restrictions on certain parameters. You have a newer development, which is electron beam melting. It is again a higher production capacity, and it's better suited for highly reactive materials which oxidize quickly, such as titanium. You have binder jetting and direct energy deposition. Direct energy deposition is primarily the most similar concept to welding. So it's pretty much using a GTAW welding process to accurately deposit material, allowing you to create a shape out of it. The one that, because all these technologies are developing rapidly, and the one we expect is going to be the most applicable will be the LPBF, laser powder bed fusion. There are challenges in this. There is a challenge on the surface roughness and the unsupported extent to which these components can be printed at. So everything once built, the forming temperature is high, the material strength is low, so you cannot build a very unsupported construction. So it does need that additional level of analysis. The other is surface roughness. In certain areas, the surface roughness is an advantage, but in many cases, it could be the cause of an enhanced pressure drop. Heat exchangers are primarily equipment that convert pressure drop into heat transfer. And how effectively it does it is from the heat transfer coefficient or the pressure drop coefficient that determines the effectiveness of a heat exchanger. The other challenge we have is the material limitation. So if you have a bimetallic component, which uses two different materials, it is challenging. Dissimilar metals are challenging to print within a single system. Most printers, once they're being used to, let's say, print titanium, it's not a matter of just changing the material and putting in copper, and so you're pretty much sticking to a single material. It can be a disadvantage because certain times, if there are two fluids, one of the fluids doesn't really require a corrosion-resistant material, while the other one does. And you may end up in a situation where you're using a high-value material for one of the circuits which doesn't necessarily need it. The other challenge we have is NDT. Right now, the traditional fabrication methods have clearly defined non-destructive evaluation methodologies. When you go into these complex geometries and shapes, getting a detailed analysis of the integrity of what has been printed is a challenge. As you can imagine, these complex things are very hard to radiograph or for UT. Then finally, the challenge is on certification. The materials being used, they are benchmarked to ASTM, and this allows us to define the physical properties at which it has to operate. But to get this converted into, let's say, ASME, which is the basic standard to which pressure vessels are constructed to, is a challenge, and this needs a change and a review in the engineering standards to allow for this. And the clients don't really have the necessary design guidelines, which will set out the guidelines to which an exchanger, especially 3D printed exchangers, should be fabricated. The materials used are sufficient. Right now, we can print almost every industrially viable material needed, and in many cases, it's ideal, such as titanium, because the entire chamber is put in an inert gas chamber, which allows zero risk of oxidation, reduces the requirement for purging, and so yeah, in materials, there's really no restraints at the moment with 3D printed. Now, looking at exactly what are the internals through to which this turbulent flow and this heat transfer is effective, there are a number of structures. They all broadly fall into a type of structure called a TPMS structure, which is a structure which is simulated using a formula, allowing for the greatest surface area within a certain volume. So you do end up with the most compact heat exchanger possible. And another thing is, when you have a tube, for example, and it has an FPI, or it has a thickness, the flow through each pass, or the flow along the travel path of the fluid, the properties change, the viscosity changes, the delta T between the two fluids change, but the tube is the same. So the surface through which the heat transfer occurs is the same because we're limited by the types of tubes we can get. But with this, the internal geometries will adapt and change depending on the state of the fluid within that surface area. Another advantage we would have is benchmarking. So we would be able to benchmark different internals, and it would allow us to get a much better idea, prototype it, and then get a real world test bench solution prior to putting it into the production. The industry applications. Again, Dolphin does all types of heat exchangers and all types of heat exchanger solutions. We don't believe this is going to replace traditional heat exchangers. It might replace a certain subsect of very specific, very intensive heat transfer coefficient applications, especially on platforms or with gases which are especially corrosive or erosive or extremely viscous. So wherever the weight, the volume is important, this is the technology where it is more applicable. So at the moment, the largest consumer and the application where 3D printed heat exchangers are in operation is the aerospace and defense. So most of the 5th generation aircrafts, the rockets, they all have 3D printed heat exchangers because, again, the cost of an additional kilo of anything that is being transported has a very large cost associated with it. So you need your exchanger as light as possible. Another area where this is highly effective is cryogenic applications, where you have extremely low temperature, operating temperatures, which does have implications on the traditional geometry. And the large delta T's have a certain stress concentration issue with our traditional geometries, and this could be mitigated with 3D printed. Electronic cooling, so most of you, if anybody builds computers here, the CPUs, the cores you have for the cooling on the CPU, nowadays they're all 3D printed. Automotive, again, this is high-end automotive, mainly in racing and performance vehicles, where you have 3D printed exchangers. Now, the process and energy industry could be the largest user of this type of heat exchangers. Nevertheless, the challenges I outlined earlier prevents the use of additive manufacturing in industry. And it's also due to the skill sets. Most of the people who are building these 3D printed exchangers come from an aerospace background, and they don't really understand all the requirements the process industry has and the concerns of the process industry. We're at the stage of case studies and simulations and benchmarking, and the analysis is done primarily using CFD, which is then put on a test bench and verified. In the future, we're looking at multi-material printing. We're looking at smart heat exchangers which have integrated sensors which manage the real-time monitoring of the fluids. We're looking at digital twin integration, so your exchangers will have a digital twin through which you will make a benchmark of the exchanger in service and how it should be operating virtually. And sustainable manufacturing, because you have typically zero wastage when you do 3D printing, unlike traditional fabrication where you have a lot of scrap. All right, thank you. And if anyone has a question, you could see me after. Is my time up? I have 5 minutes more. All right, does anybody have any questions? Okay, all right.
Thank you, Mr. Hudayfa. Please welcome our next two speakers, Mr. Ahmed Al-Bousaidi, Cybersecurity Specialist, and Mr. Yasser Al-Siabi, who is a cybersecurity consultant. They will both be discussing the navigating a cyber risk and renewable energy era. Please come to the stage.
Hello everyone, thank you for having us today. We're going to talk about renewable energy, renewed risks, and how we can navigate cyber risks in the renewable energy era. I'm Yasser Al-Siabi, a cybersecurity consultant at DreamLab Technologies.
And Ahmed Al-Bousaidi, I'm a cybersecurity specialist in DreamLab Oman.
So before we dive into the topic, let me tell you more about our company. We are a Swiss-based cybersecurity consultancy that started 28 years ago since its inception. And we have a presence across Europe, Latin America, the Middle East, New Zealand, and Australia. We have over 150 consultants who are specialized in all fields of cybersecurity. And we have a reputation of taking on challenging projects and creating custom solutions for our customers. So grid stability. The basic understanding of a grid being stable is the ability of the grid to supply power to homes and businesses even after any disruption. And in order to do that, we need to maintain a few things. We need to keep frequencies close to 50 hertz in Oman, and we need to keep voltages within safe limits. Too high or too low, it can cause damage to equipment, and it can trip grids offline. And we need to keep power flowing consistently over even after a disturbance. And most importantly, we need to recover quickly after any disturbance that can happen via generation trips, sudden demand spikes, and unforeseen weather conditions. So given this point, we introduce more equipment and more systems to help maintain these renewable sources. And one of them is battery storages. So attackers can spoof battery levels and make it seem like the battery levels are high, and in reality they're actually low. And we have grid forming inverters. They can manipulate the settings to make it trip offline. And also we have wide area monitoring, which can be also used for advanced forecasting, perhaps with AI. So all of these shiny upgrades in the power grid, it enables attackers to have a greater attack surface, meaning it will make grids more vulnerable to cyber attacks. A good example of that is where it went wrong. In 2015, an APT group targeted the Ukrainian power grid, which resulted in devastating results. More than 225,000 residents went offline for 6 hours. And 3 power companies were affected, and more than 30 substations went offline, resulting due to the attack. Now, a large misconception about these cyber attacks is that they take 1 day or 1 week or even 1 month. In reality, they're not as easy as it seems. A good example of that is this cyber attack, where they had 2 months to have initial access by phishing one of the employees, by sending them a malicious document that had malware in it. And then they took an additional 6 months for reconnaissance and gathering credentials to get more insight on the internal network. And they took an additional two months to analyze the system. And finally, they executed their attack. So if we recap the attack within the network, first of all, they started outside of the grid's network, from the internet. They targeted few of the employees and sent them malicious documents, which then, when they opened, it triggered their malware, which gave them access to the corporate network. Now, having access to the corporate network is not enough to cause damage to the grid, because it doesn't connect to SCADA systems or any sensitive systems. It's just the corporate. So what they did next is they harvested credentials, They stayed there for 6 months, as I mentioned. And one of the credentials they had was VPN credentials to the internal network, to the Industrial Control Systems network, which then they accessed the network legitimately, which will fly mostly under the radar because it's a VPN connection from one of the legitimate employees. So now they have access to the Industrial Control Systems DMZ, which allows them to control or interact with SCADA systems. So they spent a while there to craft their attack and have persistence in the network. And then finally, they executed the attack, which resulted in devastating results. So at this part, my colleague will talk about the business impact and how we can remediate against this and hopefully minimize cyber risks.
Thanks a lot, Yasser. Today I'm excited to deep dive into the business impact and remediation. First of all, as Yasser said, the initial entry point, the attackers send the emails to the employees. So it is targeted attack. Then the employees open that phishing, then trigger the malware. So we move to the next step. After enable the malware, the connection back to the attackers, then they infected that devices. The attackers doing some initial steps like the information gathering, harvest credentials, brief escalation, later movement. Then the attackers found that some specific thing is VPN access. So that VPN access is connected to the OT network, which is not supposed that. Then can the attackers access to the HMI, this client of SCADA, and can control of the breakers and so on that. After gained access, the attackers can change the HMI passwords because when the attackers change the password, can interrupt that full attack. Can the attackers make the custom firmware for the Ethernet to serial frameworks? And that's the essential phase, wiping out disks, all the workstations, and immediately destroy it. To avoid the client to reporting about the outage or something that, the attackers will immediately down the call center because that's so important phase. Then shut down the UBS fully because we cannot using the UBS again. Then that is important thing. The breakers will be down and black out all the Ukraine. Now we move to the important point in entire this presentation is business impact. The first business impact is service continuity. 230,000 customers will affected with that, and lasting 6 hours with 73 megawatt lasting. And second, operation technology damage. The malware will wipe all the workstation require at replacement the hardware of that devices. Third point, customer trust and brand. The call center was down, so the client cannot trust to the companies, and reputation will be damaged. The fourth point, insurance will be increased, and the investor will be constrained about that things. Regulatory exposure is the attention of the government is increased to the companies. And the last point is the cause, the wake-up call for the industry. We move now to the remediation. Remediation means that how to fix that issues. First of all, conduct regular security awareness training for all employees. The second point is regular fishing simulation. Can you contact with the MMSB because they know about how to simulate the phishing attack and so on that. After human level remediation, we go to the technology remediation. First of all, as you know, the IT network will be isolated and keep away from the OT network. So first of all, we need to segment the networks and deploying email security gateway because avoiding the received malicious email. And the third point, implemented MFA for all connections. MFA stands for multi-factor authentication. And remember, the VPN is access to the OT network without MFA, so that's so important to apply it. The fourth point is enable 24/7 SOC monitoring and alerting to detect any threat. Last point is conduct regularly vulnerability assessment and penetration testing to proactive any threats and so on that. In conclude, that's so important things, and as you know, the break grid is essential thing in society. So that's a shared responsibility from the government, utilities, vendors, and cybersecurity specialists. Shukran. If you want if you have any questions and want further information, we can visit to us in Swiss Pavilion in stand number 1312.
Thank you.
Thank you both, Ahmed Al-Busaidi and Yasser Al-Siabi. Our next speaker is Mr. Sailing, who is the product owner at Detection Technologies. He will be presenting dynamic package control. Please come to the stage.
Okay, mic check. All right. So I want to start this conversation off by talking about cruise control, right? You guys have probably all used cruise control before. You know, you set it 120, 140 on a long road, on a long journey, right? And it gives your leg a rest, allows you to rest a little bit, even save some gas, right? Because your throttles are modulating and everything. And that's great, right? Everybody's here has used cruise control until a slow car moves in front of you. Right? Now you have to hit the brakes, you cancel cruise control, right? Now you're driving manually until that car moves away, and now you can resume cruise control. Fine, right? Now what happens when that happens 20, 30, 40 times over, right? It starts to get pretty annoying. Now, adaptive cruise control was introduced to combat that, right? Now you can set your speed as fast as you're willing to safely drive, and you can trust that the car will automatically adjust its speed based on real-world conditions. If a slow car moves in front of you, the car will automatically slow down to match the car in front, and when the car moves away, the car will automatically speed up again. Now, I want you to think about what if you had adaptive cruise control for your compressors? A smarter system that senses and analyzes more so that it can automatically adjust to maintain your operating conditions and optimize how it's running for higher utilization and lower downtime, right? If we can trust cars to make these decisions on the road, shouldn't we trust the same intelligence from these million-dollar gas compression units? And so we've developed a technology that does just that, and it's called Dynamic Package Control, or SkidIQ Adapt. So a little bit about detection. For most of you, this will be kind of a new name. We're primarily operating in North America and the Asia Pacific. But we've been operating for 25 years, serving over 12,000 compressors to help them optimize and reduce downtime, making sure we're maximizing the utilization of these compression assets. Our customer base will be immediately recognizable to all of you here, I'm sure. And we have 10,000 active users on our platform today. Now, a name you'll be a little bit more familiar with is Waukesha, or INEO Waukesha. Well, 2 years ago, we formed a technology partnership with INEO Waukesha to develop or to address some of the common problems or the biggest problem that we're seeing in the industry today, right? Bringing Waukesha's world-class engine knowledge with detections, compressor monitoring, and adaptive optimization solutions to develop Skid IQ. Now, what are these challenges that we're hoping to solve here? Well, the truth is, compressor control and optimization hasn't really evolved at the same pace as the assets that they serve to protect and the sophisticated oil and gas operations that we see today. And so what we see because of that is the average compressor has more than $150,000 in value waiting to be unlocked every year. And there's a lot on this page, but I want to point your attention to two things. One is, well, there's, this laser pointer doesn't work. One is there's too many shutdowns, right? Hundreds of shutdowns per year per compressor. Now, we see that 35 to 40% of those shutdowns are totally avoidable. Shutdown means lost production, more operation costs to send personnel to site, and more importantly, added safety risk as well, right? Having to introduce your field employees to more time against these compression assets. The second issue that we see here is conservatism, right? A lot of people think, well, to avoid these shutdowns, I'll just run my compressors more conservatively. Well, that's like setting your cruise control to be slower than the speed limit, right? Sure, you might avoid hitting a car in front of you, but most of the time, you're going to be going slower than what you can actually go. In fact, we see average utilization of your compressors, your natural gas compressors, is only at about 80%. And your engine's even less, only leveraging about 60% of your engine's availability. Now think about, for your production, what it means if we were able to increase utilization or gas throughput by 1 or 2%, right? Okay, so to further build my point, this picture illustrates your typical set points. Now, you might have fixed set points on the high side and high shutdown, and you have low set points and low shutdown on the low side. Now, these are typically fixed pressure set points, which means they are built as a singular set point value used to protect your worst case operating scenario. Now, what that means is, number one, they're static. And number two, because you're protecting for worst case scenario, you're operating in a very, very narrow band, right? And rarely are these set points really optimized for how your compressor is actually behaving 90, 95% of the time. So this is where the opportunity comes in. Imagine if we're able to widen that compressor operating range, right? We're no longer relying on static pressure set points or fixed pressure set points, but instead to be able to monitor analytics about the compressor to enact real-time assessment of how your compressor is running and where the opportunities are, right? We'd be able to enact control, shutdown, and alarming based on the actual real-time risk of that compressor and the performance of that compressor. And what that means on the top end is you have the opportunity to improve throughput when there's more gas available, and you have the opportunity to reduce power consumption and improve well deliverability when gas is less in demand. Now again, there's a lot on this page, but really what I want to focus on is to achieve these real-time analytics and adaptive control, SkidIQ Adapt is built off a seamless integration between your compressor and your engine controller with hardware running on the edge that analyzes multiple times a second and senses and controls based on real-world conditions. And of course, to ensure safety, we've also introduced a web and on-prem interface that humans can step in at any time. All right, so how do we increase the window of operation then while ensuring that our assets are even more protected than ever before? Well, it starts with the IOs and the inputs that we take in from your compressor skid, right? We take in things in your compressor like your pressures, your temperatures, and your engine parameters as well, like your speed, fuel pressure, IMAT, etc. We bring them into our compressor controller system, run that through what we call the digital twin, which again will analyze over 15 or 20 different compressor health metrics to identify whether or not it should enact control and where there's opportunity for improvement. So while traditional controllers control only based on pressures, again, this new technology that we're talking about here introduces, again, over 15 additional process variables used to control the skid to develop maximum production and efficiency. Now, based on that, we can control your valve actuation as well as RPM to rectify any detrimental conditions, and is capable of shutdowns should any parameter be exceeded, even after control mechanisms and where safety might be compromised. All right. So, in conclusion, what we're talking about here is not just a new way to control your compressors, but what we're talking about is a fundamental shift in the mindset to embrace technology and growth in this space, right? Introducing a new way to run your compressors more efficiently and reducing shutdown. You know, this week, a big focus is on sustainability, right? A lot of companies have mentioned a carbon neutrality or a net zero initiative within the next 20 years. Addressing compressor shutdowns is going to be a big reason how we're going to be able to achieve this within the next 20 years, right? When a compressor shuts down, you're venting gas, you're flaring gas, and so be able to reduce your shutdown frequency by 30, 40% drastically reduces your carbon output from your oil and gas operations, right? In general, reducing your unscheduled shutdown and increasing your utilization to achieve $150,000 a year on average per compressor in value delivered. Now, SkidIQ Adapt is built off of our core products, which is Analysis and Embase. Embase, delivering control and monitoring solutions for your compressor, and Analysis, which is our compressor optimization and preventative maintenance failure avoidance software. Now, if you guys have any questions or are in the compressor space, we'd love to chat with you a little bit more to learn how you're managing this transition to automation and embracing more technology in this space as well. So, thank you very much.
Thank you, Mr. Sailingni. Our next speaker is Dr. Santan Krishna, Chief Operating Officer in Aqua Petrol Chemicals. He will be presenting enhanced oil recovery involving techniques and strategies. Please come to the stage.
Thank you. Very good afternoon, everyone. Today it is a great privilege to be in Opes 2025, representing Aqua Petrochemicals, a division of National Intelligent Company. I am Dr. Santana Krishnan, having about 40 plus years of experience in research and development. Today, this be a knowledge sharing session, which will be talking about enhanced oil recovery, innovative, specifically on evolving techniques and procedures and strategies. First, let us understand what is enhanced oil recovery. Methods used to increase the amount of crude oil extracted from an oil field or an oil reservoir. Typically implemented when primary and secondary recovery methods become ineffective or we are not able to make it out. Why this EOR is important? Enhanced oil recovery is important. Maximizes oil protection from mature reservoirs. I repeat, from mature reservoirs. Ensures economic sustainability in the oil and gas industry. Aligns with global energy security needs. I'm not going to talk about the primary recovery or the secondary recovery. Mostly I'll be concentrating on tertiary recovery, which is called as enhanced oil recovery. And specifically, though we have several processes called as thermal, gas injection, chemical and others, I'll be concentrating on chemical enhancing oil recovery. Under this chemical, we have three categories called alkali, polymer, and then surfactant. When you talk about primary, generally the recovery will be maximum of 30% of crude. In secondary recovery, in between 30 to 40, maximum you can go to 50, whereas enhanced oil recovery, where you can go up to 80% of the oil in place, original oil in place recovery. See the global techniques, what we are adapting. Conventional methods, they are going for thermal EOR 40%, gas injection is 30%, and 20% is on chemical EOR, and microbial is only 5%. Nanotechnology is the evolving technology. That is what we are going to discuss about it. It is about only 5%. This is conventional. EOR techniques we call steam injections, are conventional injections where heavy oil reservoir has been used. CO2 injection, light to medium oil reservoirs. Polymer flooding reservoirs with high water cut. We'll be talking about in detail about it. Microbial EOR for mature reservoirs and nanotechnology for various reservoirs oils, which is the evolving technology now. When we talk about evolving technologies and process, chemical EOR we call as smart polymers. Smart polymers is nothing but a stimuli responsive polymers, which will give a key features combining with nanopolymer blends, responsive gels, and encapsulated surfactants. A polymer will open its structure, and you can see the surfactants has been encapsulated, and it will be released as and when required. Similarly, designer surfactants. Designer surfactants are those surfactants, it is a tailor-made. Depending upon the reservoir conditions, this will be made, which have the key features of low adsorption, high performance surfactants, and switchable solvents for adaptability. Microbial EOR, engineered, because microbial EOR, though it's naturally available, depending upon the reservoir conditions, we may be able to develop a strain, particular strain, and then we will be able to do the microbial enhanced oil recovery, which will produce a biosurfactants, reduces interfacial tension, IFT, and tailored to reservoir for TDS and temperature. Depending upon the TDS and temperature, we can tailor make the microbial strains. CO2 and gas-based, of course, it is being known. So CCUS, which is called carbon capture, utilization and storage, reuse for industrial CO2 for miscible flooding, as well as for environmental benefits. Lean and enriched gas injection is a conventional one. When we talk about low salinity and then engineered water flooding means we are making a stimuli. We are creating an polymer or a water flooding according to the reservoir conditions. That is why we call it as engineered water flooding. And it alters wettability, increases displacement efficiency. Thermal EOR, again, it's a conventional one, so I don't want to go in detail, but solar assisted steam, solvent steam hybrids, digital EOR, yes, this is predominantly is coming in. We are incorporating the artificial intelligence with machine learning and for performance prediction, real-time analysis, and digital twins. This is like a stimulated one. So stimulate reservoir behavior in an open space, and we can analyze, we can collect data, we can interpret, and then we may be able to design the requirement of polymers or the enhanced oily recovery chemicals that has been required for the reservoirs. A hybrid of EOR. See, not only one chemical has been utilized for getting the efficiency, it requires more chemical, a combination of hybrid called as polymer or alkali or a surfactant. It has to be a hybrid. So combination of chemical plus gas or bio, ASPN, alkali, surfactant, nanoparticles, and polymer, which gives synergic effects. When one fails, polymer has got also a limitation. Surfactant also has its limitations. Similarly, alkali conditions also have limitations. But when we are combining and making it as a synergic product, a combo product, it has a better efficiency. Green and sustainable polymers, everyone is working on it for the environmental sustainability. So biodegradable polymers, surfactants, and with environment regulations. So smart polymers I was talking about, as I told, I'm going to concentrate on the only chemical enhanced oil recovery. The first part is on the polymers. So smart polymers, also known as stimuli responsive polymers, are advanced materials to undergo reversible physical or chemical changes in response to external stimuli. What are all the external stimuli that we are going to? Stimuli are temperature, pH, salinity, electrical or magnetic field, specific molecule, whatever it may be. Response, what is the response in correlation to temperature? Change in solubility, shape or viscosity. When we compare with pH, swelling or shrinking, so that it will plug the porous, light, structural changes or degradation, electric or magnetic field, movement or alignment, specific molecules, binding or releasing molecules, salinity, altered conformation or gelation. A specific molecule that has been identified is poly-N-isopropyl acrylamide, we call as PIN-PAM. That has been widely used, changes the solubility near 32 degree. Useful in temperature sensitive flooding applications. This is an evolving technique. How that chemically over polymer flooding, this method involves the injection of polymer with water to mitigate the mobility of water relative to oil. Normally when polymer is used, it will increase the swifting efficiency rather than the mobility. Inherent viscoelastic characteristic of polymers. Viscoelastic characteristic of polymers, there are two different functionality. One is viscosity and then elasticity. This is again an evolving technology. Viscoelastic characteristic of polymer allow to recover oil from narrow and confined spaces with the reservoir through the application of pulling and stripping mechanism. When you see the other photos, I think you will be able to understand. This is us, pulling and ejecting. The polymers works, how it goes into the water. When the polymer is being applied, it increases the viscosity of the injection water, and then it increases the swift rather than the mobility. Most commonly used polymers, HPAM, it's a conventional one, that is partially hydrolyzed polyacrylamide, less cost effective, and then resistant to bacterial infection. Xanthan, zwitterion ionic polymers. There are two different terminology we call as amphoteric polymers and deuterionic polymers. So deuterion means they will have two charges. So sulfonated polymers, polyacrylates, polyethylene oxide, cellulose derivatives. So selection of polymers depends upon the reservoir condition, the interactions between the fluids and the rocks. We need to understand the characteristics of the rocks. The rocks may be a sedimental rocks, it may be a carbonate, it can be an intact carbonate, it may be a shell. So this is a structure, of course you might be knowing it. This is how the extraction takes place on application of after polymer injection, oil protection, and a number of wells and protections. Commonly used polymers in enhanced oil recovery right from HPAM, HAPAM. HAPAM is nothing but hydrophobic, introducing an hydrophobic in partially hydrolyzed acrylamide, xanthan gum, valent gum, guar gum, cellulose, the list goes. What are biopolymers? It's a definition. Biopolymers are natural polymers produced by living organisms or derived from renewable biological sources, unlike synthetic polymers. Synthetic polymers we need to carry out with the monomers. We'll be doing the polymerization reactions with a chain initiation, with an initiator, free radical mechanism we'll be doing it. Synthetic polymers are non-biodegradable and The biopolymers are biodegradable. That's why many industries are concentrating and evolving technologies comes because of these biopolymers. Biopolymers are often biodegradable, eco-friendly, can be used in various applications, including medical, food, agriculture, and evolving oil field chemicals. List of biopolymers. Polysaccharides, we have a range: cellulose, starch, alginate, chitosan, xanthan gum, proteins, gelatin, collagen, casein, soya proteins, nucleic acid, DNA and RNA, polyacetic acid. So biopolymers in oil and gas, specifically in UOR, enhanced oil recovery application, xanthan gum used as a viscosifier in drilling, and guar gum for hydraulic fracturing fluids, starch derivatives for fluid loss control, and chitosan used in water treatment. Specifically, it is not applicable, but the produced water can be treated with this type of polymer called chitosan. Then surfactants. A chemical part, the evolving technology we have spoken about called the smart polymers. Similarly, when we are talking about the surfactants, we call as designer surfactants. What is designer surfactants? Are custom-made or tailor-engineered surfactants with specific chemical structures. I repeat, surfactants are custom-made or tailor-engineered surfactants with specific chemical structure for reservoir conditions such as high temperature, high salinity, and specific oil compositions. So we can tailor-make these surfactants. Surfactants of different types. You can say non-ionic, cationic, amphoteric. We can say zwitterionic. All these categories are available. It can be tailor-made. Enhanced oil recovery, the evolving techniques is to get all the oil sources that is available in the reservoir. So we need to understand what type of reservoir, what type of the rocks are available, what type of porosity, what is the permeability limit. Understanding all these things, we need to tailor-make the surfactants or the polymers. That is why it has been given a name as smart polymers or as stimuli response polymers. Similarly, for these surfactants, it is called as a designer surfactants. Mechanism, it reduces, increases interfacial reductions, wettability, microemulsion formation. That is very important. Microemulsion formation increases the mobility. And phase behavior optimization, compatibility, low absorptions. So these are all the mechanism in which we can able to design the surfactant based on the characteristics of the reservoirs. Surfactant flooding, of course, everybody knowing about this. Flooding means what? There are all category. Natural surfactants can be derived from coconut oil, sesame, rapeseed oil, almond seeds, palm trees, cationic, surfactant, anionic, non-ionic, amphoteric, and is one more called as Gemini surfactants. Gemini surfactants is recently evolving in a bigger way, where there will have two heads. Normally, surfactants will have two heads. One is hydrophilic and lipophilic. Hydrophilic means it's loving of water. Lipophilic means loving of oil. So they will have two heads of hydrophilic, two heads of lipophilic, which is called as Gemini surfactants, which is evolving in many industries. They started using these Gemini surfactants. And viscoelastic surfactants, which have a dual property of viscosity, reduces, and then enhancing the mobility and the sweeping efficiency. This is called as viscoelastic surfactants. Lot many charges. Cationic, what is that? What is the example? When you ask about what is cationic surfactants, we have cetyl trimethyl ammonium bromide, dodecyl trimethyl ammonium bromide, where it is being used. Anionic surfactants, which has a negative charge. Non-ionic surfactant, no charge. Amphoteric has got positive and negative charges. Gemini surfactants, dual head, dual tail, and viscoelastic surfactants varies. And cetyl trimethyl ammonium bromide plus sodium salicylate, which is the best surfactant, which is having a viscoelastic property. Surfactant flooding, of course, you might be knowing, alters phase dynamics, create microemulsions. That is more important because when you want to have more mobility of oil in water, we need to have the microemulsions where water and crude oil meet. Significant reduction in interfacial tension, less than 0.001. So Gemini surfactants and zwitterionic surfactants specifically have a better interfacial reduction of tension. IFT, it has a better IFT. So corrosion of mechanisms involved, comparison of mechanism involved in different chemical UOR techniques. Polymer flooding, which have a mobility control. Surfactant flooding, surfactant and polymer, when you hybrid it, combine together, that is what I told in the beginning. as an evolving technique, encapsulated surfactant on the polymer. Encapsulated surfactant in the polymer flooding, which also reduces IFT and increases the mobility of oil in water. Alkaline surfactant polymer, 3 again. It's a hybrid. Alkaline, surfactant, and polymer. Surfactant and polymer absorption, reduction, of course. Adsorption, reduction. There are 2 different terms absolutely used. Absorption and adsorption. Adsorption is sticking fast. Absorption goes inside, but we can bring it back again. So it's an adsorption. It will stick. Polymer and surfactant, adsorption, reduction. So that oil will not get permanently stuck up. It will try to come out. So adsorption. It will reduces the adsorption. In situ surfactant generation. In situ surfactant generation, so that through microorganisms also, we can develop surfactant. This is called biosurfactant. We can understand the reservoir conditions, and we can select the strains. That strains will be able to generate a surfactant called as biosurfactant. That surfactant may be able to reduce the IFT. That is called as in situ surfactant generation, ultra low IFT, mobility control, and nano surfactant and polymer flooding, aluminum oxide or silicon oxide. Now they are using as nanoparticles, and which has been predominantly being used in this enhanced oil recovery. Surfactant and polymer absorption reduction, IFT reduction, polymer viscosity enhancement, and then mobility control and wettability alterations. These all can be able to make when we have a product which has been able to give enhanced oil recovery in the reservoirs. See, this is a combination of polymer and surfactant. The red one, which is like a thread-like things, are all surfactants. The black ones are all oil. The remaining brown colors are sands. Please have a look into it, and you yourself can understand how the mobility and sweep and reduction in oil viscosity happens because of this, and the carryover you can see. Surfactants play a role in reducing interfacial tension and facilitating the separation from oil and rock, which you can see it. Concurrently, polymers elevate the viscosity of the solution, elevates the viscosity of the injected solution, enhancing both the sweep efficiency and conformity of the injected fluid. The collaborative impact of this mechanism fosters capillary desaturations, facilitating a more effective displacement in oil within the reservoir. So I always suggest, don't go for a single. When you want to apply for any enhanced, are we going for an enhanced oil recovery? Let us not stick with a single component. If we really want to enhance the recovery of oil in a better way, let us concentrate on bringing in a hybrid type of. It may be an alkali, it may be a surfactant, it may be a polymer. Have a combination. Even we can go for a microbial, but it depends on the reservoir conditions. Then the final one is alkaline flooding. The alkaline solution works to neutralize. Many cases it is not required, in some cases it is also required, because when we go below the reservoir, we do not know what is the condition, what is the pH. If we do not know that and we are going to apply the polymer into it, polymer will get degraded because of the pH conditions. So first we need to neutralize it. So alkaline flooding is a must. Alkaline solution works to neutralize acidic components in the reservoir rock. It is especially useful in reservoirs where acidity is a key challenge. This technique is always used in combination with polymer and surfactant. When you are going to use polymer, it will have an impact if the reservoir is in acidic conditions. So we need to neutralize it. So when we are going to use polymer and surfactant, certainly we need to look into the reservoir characteristics, and based on that we have to select the alkaline nature. The alkaline, we have ammonia, sodium hydroxide, potassium hydroxide, sodium carbonate, many inorganic salts. Nanotechnology, emerging technology which is going in a bigger way. Nanotechnology increases the oil mobility and recovery efficiency. Microbial UR uses bacteria to break down and reduces viscosity because it generates biosurfactants. And then electromagnetic heating uses radio waves to heat oil in reservoirs, which is common. And process, I told about evolving strategies, evolving methods, chemical methods. There are process, thermal enhanced oil recovery, toe-to-heel air injection, steam-assisted gravity drainage. Of course, it's a conventional. Thermally assisted gas oil gravity drainage, it's again conventional. High-pressure air injections, again, a conventional. Recent advantages in a numerical simulations using the stars, steam, thermal and advanced process reservoir simulator, a software by a computer that is called a CMG, introduce an innovative approach to enhance the oil recovery in low permeability fault block reservoirs. I repeat, in a low permeability fault block reservoirs using the in situ production of CO2. In situ means carbon dioxide can be generated there itself and it can be used. That is called as huff and puff technique. Of course, it has been widely used. Nothing but huff and puff is injection, soaking and production. That is what is called as huff and puff technique. The huff and puff technique is a cyclic enhanced oil recovery method, also known as cyclic steam stimulations. That is what huff and puff. Future trends in our integration of AI and data analytics. Yes, now AI is occupying a wider area and it is providing innumerable of data. So many historical data are available. Through the data available, we may be able to identify what type of methods that we need to go for it. And then through the data, we may be able to integrate the data and we'll be able to generate the reports. Through the reports, we can come to a conclusions what type of enhanced oil recovery methods has to be used. Conclusions: the collaborative efforts between industry and academia in unraveling the complexity of reservoir behavior and fluid rock interactions with allow for the tailoring of, I repeat, complexities of reservoir behavior and fluid rock interactions will allow for the tailoring of UOR strategies. This is very important. So only we understand the complexity of reservoirs behavior and fluid rock interactions, we'll be able to develop the enhanced, the strategies or the process or the evolving techniques for the enhanced oil recovery. This tailoring not only optimizes recovery, but also minimize the environmental footprint, aligning with the growing commitment to sustainable practices in the energy sector. Thank you very much. Any questions? If there is no questions, I make a leave. Thank you, gentlemen and ladies. Thank you.
Thank you so much, Doctor. Our next speaker is Mr. Monam from Sinems Energy. He will be presenting on advancing CUC technologies. Please come to the stage.
Oh, yeah, this one. Like this. Yeah. So, hello, good afternoon. My name is Monam Tirish. I'm responsible for sales in the Middle East, based in Dubai. Happy to be here today to welcome you through the short presentation, 15 minutes. I would kindly ask you to pay attention and then maybe later on ask questions and meet us at the booth. So today the topic is about decarbonization through carbon capture and storage. And then we'll explain a little bit the mechanism of this technology, why is it needed, what's happening in the world, what's happening in the Middle East, the role of Siemens Energy, what are we offering, how can we support our customers through this journey. So let me start a little bit explaining who is Siemens Energy and what we do. So we have a mission, which is energizing society. How we do this is by providing affordable, sustainable electricity. And then to achieve this, we develop cutting-edge products and solutions and forge partnerships. And the whole Siemens Energy, we have four pillars or four business units. The first one is where I come from, actually it's called gas services. It revolves around gas turbines and steam turbines. It goes from 3 megawatt to up to 600 megawatts. And then we have Siemens Gamesa. Basically, they are in the wind turbine business, offshore and onshore. And then we have the grid technologies. Their main mission is to make sure we transport the electricity, namely transmission and distribution. We have synchronous condensers, which we need to secure the inertia in a grid by achieving grid stability. And then, of course, the HVDC cables, substation. This is more or less what grid technology they're doing. And then the last one is called transformation of industry. So basically, the focus here is on the industrial sectors. We optimize the efficiency of industrial processes by providing small steam turbines, but also providing all kinds of compressors. And I will come to this later on. It's very important for the carbon capture and storage topic. So Siemens Energy, all in all, we are 100,000 people. So 1/4 of it, actually, that's the gas services, where we sell our gas turbines. We achieve, all in all, 9 billion euro as a sector. Siemens Energy is more or less 40+ billion euro revenues. So 1/4 of it, more or less, that's the gas turbine business. What is important here, beside these KPIs, is the commitment to R&D. So we spend approximately 1 billion euro every year in R&D. And I will come to this later on, including the decarbonization. So the decarbonization philosophy of Siemens is based on 2 pillars. The first one is hydrogen, so how to be able to burn hydrogen in gas turbines. The second one is how to capture the CO2, so reduce the carbon footprint. So the gas service sector, in terms of gas turbine portfolio, we categorize them in 2 different categories, namely anything beyond 100 megawatt, we call it central, and anything below 100 megawatt, we call it distributed, namely small gas turbines, which are basically used in industrial sector. And then above 100 megawatt, that's the utility scale. Yeah? Across all the gas turbine portfolio, we are developing new ways of qualifying our gas turbines to operate on various fuels. Green fuels, hydrogen. Again, this is the first pillar. The second one is how to reduce the CO2 emissions, or how to capture it. So this is more or less just the overview of all our activities. For example, the second pillar of decarbonization, which is now in orange, this is the decarbonization via carbon capture and storage. So again, this is the portfolio. If you look at the hydrogen capabilities, this is all driven by a so-called EU taxonomy. Means that, for example, in Europe, they are designing.
Good afternoon. The panel session on utilizing technology for safety, environment, and well-being will begin shortly at Opes Grand Ballroom.
Thank you. So the certain policies are driving what we are doing here in terms of R&D. Namely, in Europe, for example, there's a so-called EU taxonomy, which is forcing all the players in the energy sector to decarbonize via stipulating certain conditions, how much CO2 should be emitted, the hydrogen level, for example. By 2030, EU is asking everyone, including Siemens, to be 100% hydrogen ready. It means all the gas turbines which we are producing, they should be able to operate on hydrogen 100% by 2030. Of course, in return, we tell them it's feasible, and we are doing it. Actually, one of our gas turbines reaches already today 75%, and in 2 years 100%. That's the SGT 800, which we have also in Duqm here in Oman, and we have in Saudi and in various parts of the Middle East. The other pillar is carbon capture, because only hydrogen is not enough, because the challenge of hydrogen is you have to provide the hydrogen quantity. Yeah? So that's why we say, okay, let's try to find another way of decarbonization, and then what's the value add of Siemens there, and what's happening first in the world. So maybe in 1 or 2 minutes to explain the concept of carbon capture and storage. So if you look at the power plant, gas-fired power plant, there is a lot of, so the flue gas or the exhaust, it contains 3 to 5% CO2. If you look at the coal power plant, it's 10 to 15% CO2. The idea is to capture this CO2 and then later on to utilize it either to manufacture synthetic fuels, other chemical products, or to store it, long-term storage. So this is basically the carbon capture and storage, yeah? And utilization and storage. Without going into the details, I will cover them at a later stage. So for the CO2 capture, let me start with the easiest one to explain. Namely, it's called the DAC, the direct air capture, which is a very promising technology to capture CO2 from the atmosphere. So if you think about the air we breathe, so it's a majority nitrogen and then oxygen, and there is a little bit of CO2 as well, yeah? It's around 400 to 420 ppm, particle per million. The idea is to capture this CO2, which we call it legacy CO2. It's in the air. So for this, there's a technology which everybody is developing, including Siemens. So for example, Siemens Energy, we are having an R&D program with Saudi Aramco, where we do R&D in Abu Dhabi, R&D in Dammam, Dhahran actually, in Saudi, and R&D in the US. It's a pilot project where we are co-investing to bring this technology to a mature level. It's still in the beginning. It's very promising. And I ask you maybe later on to have a side chat, because we also are introducing the people to go and visit Saudi Aramco and to look at this technology. That's the easiest one. So the most mature technology available these days is called post-combustion CO2 capture, which means that the fuel has been combusted, and then all the exhaust, it has still remaining carbon elements in terms of CO2, and now the technology is how to capture it. The existing technology right now is to use a liquid. It's a solvent, basically, and then the easiest way to remember the solvent is called amine. It's not an Arabic name, amine, by the way. It's just amine. Monoethanol amine, MEA, not Middle East Africa. Yeah? So I'm just... So this liquid captures the CO2, and this liquid or solvent, is produced by many companies. The Shell of the situation, or Aramco, and then... so it's an existing product, it's commercially available. So this solvent is mixed with the flue gas to capture the CO2. So the 3 to 5% CO2, which we said in the flue gas, it's captured by this solvent. And it's becoming a CO2-rich amine. And now to separate the CO2 from this liquid, we need to heat it up. It means we need to inject heat. Where do we get the heat? We get it from the power plant, basically from the steam cycle. How to get it there? This is what Siemens does. Siemens Energy, they optimize the way how to extract the heat from the steam cycle and to bring it to this solvent, to this liquid, to make this increase of temperature up to 120 degrees to separate the CO2. So, again, to recap, somebody else provides the liquid, somebody else designs the place where to do this mixture, and we as Siemens, we design the way how to extract in a very efficient way the heat. So this is our contribution to the carbon capture. So once this heat is introduced, then you separate the CO2. So then in those modes, we capture the CO2. Unfortunately, the CO2 is still gas. It's not good. So you have to make it liquid to be able to store it or transport it. How to make it liquid? You have to compress it. So the compression phase comes into play. This is again where Siemens Energy adds value, because we provide all kinds of compressors. We have the centrifugal compressors, we have the reciprocating compressors. So depending on the final application of the CO2, namely which pressure you need to achieve. For example, if you would like to transport the CO2 as a liquid in a pipeline over long distances, you need high pressure, 150 to 200 bars. For this, you have to design a special compressor to handle this. This is where we come into play. We do it. We don't build the pipeline, but we build everything around the compressing system. If you would like to inject the CO2, for example, previous panel discussion, or I think presentation was about the enhanced oil recovery. So we inject CO2 to improve the oil recovery. This CO2 needs to be at a certain pressure. Again, this is what we design. If you would like to do a long-term storage in the saline aquifer or in the depleted gas and oil wells, so you have to inject at 80 to 100 bar. This is where Siemens does the whole engineering around it. And then this is something which we are offering in the region and outside the region. So in the CC, carbon capture and storage, just to recap, we provide heat from the steam power plant, from the steam cycle. We engineer everything around it. And then the challenge of this, the heat is something you extract from the power plant. It means it's lost, which impacts negatively the gas power plant. For example, in the Middle East, if you look at all the countries here, the carbonization is, Saudi Arabia is about carbon capture and storage. Everything else around Saudi Arabia is about hydrogen. And there is a reason for this. So in Saudi Arabia, for example, when they capture the carbon, they give it to Aramco. They have a lot of application with it. But again, they are not implementing yet. So they do so-called a carbon capture provision. So whenever there is a power plant project where Siemens acts as a component supplier, sometimes as an EPC, we build the power plant, we will make sure that we will design the connections to the future carbon capture plant from today. So this is something which we do. The problem is about the carbon capture, again, it's very expensive. So just to give you an idea, if you build a gas power plant, let's say $1 billion, who has an idea how much a carbon capture plant would cost? It's 100 to 150%. So if your combined cycle power plant costs $1 billion, the carbon capture plant is minimum 1 billion to maybe 1.5 billion. So it's, in terms of capex, very expensive. That's one thing. The second thing is the whole process is a very energy intense process. It means it steals energy from your gas power plant to be able to capture the CO2. It means whoever is building a case of power plant selling electricity to the grid, all of a sudden his power plant is not efficient. It loses 10 to 15% of output. So very bad for the tariff, or the investor will compensate this by burning more fuel, which is also bad. So OPEX-wise is bad. And this is where the R&D activities come into play. So our role today is how to, again, design a very efficient compressors. So at least, because the compressor, at the end of the day, it needs a gas turbine or to drive it. So the efficiency is very important. So this is something which we do. And then again, we design the integration of the heat in a way that you extract less heat to help you extract the CO2. So this is more or less what we are doing. To move on, again, why we are doing this? We are, again, we are called Siemens Energy, so we are in the energy sector. And then if you realize here, 73% of the CO2 emissions is coming from the energy sector. So we have a mandate, a role where we have to step in and do something about it. I will skip this. Maybe just to give you, explain a little bit the driver behind this. As I explained earlier, that if you take a coal power plant, again, as I said, 10 to 15% of the flue gas contains CO2. By just replacing it with a gas-fired power plant, you save already 59% of the carbon emission, CO2 emission. So that's why the trend go for gas. However, gas is for a transition. Transition may be 15, 20, 30 years, nobody knows. So coal is bad, unless it's very strategic. Yeah? Now, the moment you have a gas plant, if you replace the gas turbine by HL, this is the latest, most advanced gas turbine we have. In a combined cycle operation, it has more than 64% efficiency. So it's amazing. By just taking, if you have an E-class or an F-class, whatever technology, gas-fired power plant, replaced by the most advanced, then you save further 9% in terms of CO2 emission. Because more efficient means less CO2. And then now, this is where the EU taxonomy comes into play. If you go the hydrogen way, by burning 50% hydrogen in a gas turbine, the rest is gas, then of course you save the CO2 emission because less carbon atoms in your fuel. However, the problem is hydrogen is very expensive. That's why in Europe, for example, they want to get it from North Africa. Here in the Middle East, plenty of space, plenty of solar, wind resources, especially in Oman. So hydrogen, yes, it's going to be green hydrogen to be exported as green ammonia. That's one scenario, but the other scenario could be also 30% hydrogen, 50% hydrogen. The challenge is just make it available and at an affordable cost. And then in Europe, they say by 2030 it should be 100% hydrogen. Technically, it's possible. We are able, as I said, today 75% is achievable. In 2 years, we will achieve it before 2030. However, there is the other stream, namely the carbon capture. So if you go for the carbon capture, which makes sense in Europe because the CO2 has a price there. It goes from 80 to 120 something euro per ton of CO2 emission. In the Middle East and Arab world, it's not happening yet. It might happen one day, but in Europe, if you save one ton, at least in Germany, CO2, that's 80 euro. Imagine now 1 million, 2 million tons, which you capture, you save. That's a lot of money. There's also a stock market for this. That's why they are driving it. It makes sense. There is a business case behind it. At the end of the day, it's all about money. And then, of course, they are pushing the limits. They say today, the technology, the post-combustion CO2 capture technology is available, is commercially available at utility scale where you can capture 95%. However, it's expensive, as I said. So just to give you an idea about what are we talking about here in terms of quantity of CO2. For example, if you look at, unfortunately, this, I don't know, yeah. So the gas plant, as of today, if it is not that efficient, around 300 grams per kilowatt hour of CO2. So again, by only putting the HL technology, very efficient gas turbine of Siemens, it goes down to 310 grams. By the way, this is part, whoever develops projects, this is very, very critical because every gram, it means money. And then, if you go to the 95% capture, so from the 340 or 310 gram, it goes down to 20 gram. And then you can times now how many hours you are operating, and then it ends up having tons, millions of tons, plus millions of dollars as well, yeah? So again, to recap, this slide might look complex, but actually it's easy. I will explain it. So here, unfortunately, the pointer doesn't work there. So this part, this is a gas-fired power plant. So you recognize a gas turbine, steam turbine, heat recovery steam generator. This is the usual stuff which everybody knows. This is the footprint of Siemens. So we build this. And now the magic happens when you connect it to this square, which is a bit light blue. So the carbon capture plant, we don't build it. Somebody else does it. However, in general, we forge strong partnerships with various players in the market to be able to optimize what they do in terms of integration. So we find there are a lot of compressors, for example. In this blue square, a lot of compressors. They are energy-intense compressors. So this is where we have support them with the engineering to optimize it. Of course, the integration, as I said, in terms of heat. We offer also the DCS for this. So INC, this is something which we can offer to optimize the whole process. Something else which we offer as well is advisory. So we do consultancy. Okay, 30 seconds? This is the last slide anyway. Most probably this is a very important one. To decide for a carbon capture, yes or no, versus hydrogen, there's a lot of variables, namely the price of the hydrogen, price of carbon, CO2 you capture, price of the plant which you are planning to build, and the operating hours. Are you operating 1,000 hours or 5,000, 6,000 hours? So all of this, you end up having sweet spots which way to go. This is where it seems, again, energy comes into play and supports in terms of advisory and consultancy. Thank you very much for the attention, and then I'm available for side talk and discussions if you want.
Thank you, Mr. Monam, for that technical and insightful session. Up next, we have Mr. Mohammad Salman, Business Development Manager at Seven Seas Petroleum. He'll be speaking about dynamic process simulation in optimizing operations.
Can you hear me? Okay, good. Excellent. Good afternoon. Thank you for giving me the opportunity to talk about the process simulation. The process simulation has many use cases and many applications. And one of the important applications is the operator training. And the reason why we look at this application as important because we actually have some challenges with respect to equipping the operators with the right knowledge and expertise to manage the hazardous processes that we are having today in the industry. Statistics shows that 50% of the experience in the process industry are leaving the door. So we are basically having a leakage of knowledge in the industry. So there are a lot of staff that they are retiring and they are leaving the industry, and we're talking about 50% of the skilled workers are leaving with around 10,000 of the baby boomers retiring every day, and those are the experienced individuals that used to run the plants in an efficient way. So what we do, we basically go and staff the processes with the new generation, and the new generation is also needs some tools to understand the process and develop the experience. But also there's a challenge with the new generation, and not picking up on certain generation, but generally, for example, the millennials are having very short intention to stay in the job, and they have 3 to 5 years to just leave and go somewhere else. So you also have a few staffed with the new operators or new staff. Those staff are not staying for a long time, and it's very important that we motivate them to stay in and get the experience and give them the tools to make sure that they do the job in a good way. So there is a challenge now. If you look at the time that we spend to get the operators trained, is we're talking about 6 to 7 years of training. So this is really long time to get an operator to get from being a newcomer to a fully competent operator. So there is very long years that you have to spend to get the operator into the knowledge that he needs to do his job in an efficient and competent way. So what do we do? What is the way forward, and how can we solve this issue? Usually when there is a knowledge issue within the organization, what do? We put our staff into training, right? I mean, if I need to have some kind of a certain knowledge, I can go and read a book. I can go and ask someone who has more experience than me, right? I can watch someone doing the job and learn by watching, right? But the best way to do is to learn by doing. And we always say that especially for the fresh graduates who are coming from the university and joining the industry, we're telling them that I will put you in a course. I will give you training, a classroom training where you will spend maybe 3-4 days. I'll send you into that course to learn more. But 70% of your knowledge is going to come from the on-job training. You need to do things by yourself because this is where you will learn. But the challenge we have in the process industry, you really cannot put an operator in on-job training on running a process. Because first, the process in most of the time, it is in a steady state. There is nothing much to learn because there is some kind of other scenarios that's related to the process that the operator needs to learn, but he will not have the opportunity, he or she will not have the opportunity to learn those cases in a real running process because these cases might not come up, right? So we are basically stuck here with a limited options. So what do? We need to create a safe environment where the operator can have a training on virtual environment to do this training in a safe way and to practice the different process scenarios and do the things by doing without actually doing it on hazardous process. So the applications that we are usually looking at is having a digital twin of the process. So you're going to have a digital replica of the process, and that replica will provide the safe environment for the operator to learn. But also you can get more from that. So what do? When you invest in this kind of technologies, you are basically going to shorten the training time required to get the operator from less experienced to competent. Usually we said in the first introduction, we said that it will take 6 to 7 years to train an operator. Now with the tools that you can invest in to make the digital twin available for the operator to do the training, you can shorten this 6 to 7 years into a matter of months. So the operator will have quickly acquired the skills required to do the process, to control the process and to operate the process. There is also an applicational requirement to do this kind of investment to make sure that the existing operator are also developing their knowledge. So it's not about the newcomers only that are coming to the process industry, but also to the existing operators to understand further the process, to basically maybe you have some kind of hazard study, and the hazard study has basically identified some scenarios that needs to be practiced by the operator. For example, for those who are dealing with the safety domain, there is a what if analysis and what if scenario. This one what if analysis, you cannot really practice those scenarios in the process as it's running. So you need to have it somewhere, and the best way really to do it is in digital twin. There is also requirements to do continuous learning. For example, now currently we are talking about introducing new fuel. Let's say that you are introducing a new fuel like hydrogen. You are introducing into the process, right? And hydrogen has a different kind of characteristics and safety requirements and some operational requirements that needs to be practiced by the operator. And the best way really to do that continuous learning by doing the digital twin and have the replica of the process available for the operator to do this testing. So how do we help at Emerson? We basically help our customers to deploy a reliable digital twin for their processes. And to do that, you basically need to make sure that this solution is providing an end-to-end and integrated solution together to make sure that the OTS is reliable and dependable. So you can depend on it to make sure that the operator is doing what he needs to do with respect to the knowledge and the training. So one component is important. Three main components we're talking about here is that we are basically replicating the control system, and the control system sits on the process. So we have to also replicate the process. So we get component like Delta V Mimic or Asventic software to replicate the process and build the process models. And then there is also one component that is usually get missed out when we talk about the operator training. It's the operator in the field. So when we talk about the operator training, we always focus on the operator who are sitting on the control in the control room at the control board. But there are operators also in the field, and those operators are the most, I would say, vulnerable individuals in the setup for the process, because they are in the field, they are basically exposed to hazardous events. They are more exposed to hazardous material than the operator in the room. So they also need to practice the activities that they need to do in the field. And the best way really to provide them with the opportunity to do the training without before they go in the field is basically to give them some sort of immersive virtual reality. And this is what we provide, the 3D. The operator can wear the virtual reality goggle, and he start, moving around with as if he's walking in the field, closing the valves, opening the valves, doing some kind of maintenance activities related to the equipment and assets. So if all this happening in a safe environment, and most importantly, if you have field operators and panel operators or control room operators, you will be able to establish that kind of collaboration between these two operators to make sure that process is going to run in a safe and efficient way. So what is the most important thing with respect to the solution when you look at an integrated operator training system? You need to provide facilities for different individuals, because there are different stakeholders. When it comes to the OTS, operator training system, there are different stakeholders that we need to make sure that the solution is basically providing them with the tools they need to make sure that they get the most out of this solution. First is the panel operator, so we have to provide the tool for the panel operators to do the actions on the process, and the field operator, as I mentioned, and most importantly, the instructor. Now, the instructor here plays a big role, because the instructor has to basically to monitor the operator's actions. He has to correct the operator actions. The instructor also has to introduce a certain scenario on the process, and then the operator has to follow certain standard operating procedure to make sure that the operator is practicing what needs to be done on the actual process. And also there is a requirement for the engineer as well, because the engineer will need that kind of tools. Why? Because sometimes you might need to change the control strategy, and sometimes you might need to change the process design. And the best way to do that is to do it with the simulator, and that's why you need to have another facility for the engineer to utilize this technology to the benefits of the function that they are performing. So here I will not go through the details, but as you can see that we have number of software components that we can put together, and those software components, when they are integrated together, they provided all these functionalities to different personals that comes to the when it comes to the OTS. So what is the process impact? What is the impact? What is the operational impact by getting the this investment of the operator training simulator in place? There are some key impacts that we can think about and we can basically recognize it quickly. For example, if you have a process which is managed by experienced operator, your startup becomes faster. Because if you get a less experienced operator, the process will take longer to start up. So usually we're talking about 2.2 days of improved startup. So you're gonna be starting the process faster by 2.2 days. You will have less unplanned shutdown. So usually when there is a less experienced operator, you will have more frequent process shutdown. There is loss of production. There is safety issues because shutdown can create safety issues. And also if you have what you call a planned shutdown. So let's say that you have scheduled the equipment for maintenance and now the equipment needs to go on maintenance. Usually with the experienced operator, the time period for the planned shutdown is usually shorter. So when you do that, you are basically going to have some kind of direct operational impacts on as a result of your investment on the operator training simulator. There is one last point I want to mention before I conclude, that the benefits that I have mentioned here is also extended to the safety, because safety, as we know, that you can't measure the safety because there is a statement which say if you think safety is expensive, try an accident. So it's always safety, consequences for safety are always basically unimaginable. It can go beyond what we can imagine. So it's important that this investment also provides the training to the operator, so that safety operation of the plants is basically achieved and attained. I think that's all. That's what I want to share with you in this short talk, and thank you very much for your attention. If there is any question, I will be happy to take it. Otherwise, we move to the next one. Thank you very much. Appreciate it.
Thank you, Mr. Salman. Up next, we have Mr. Jules Youssef, Managing Director at Great Place to Work, and he will share insights on shaping a great place to work in the oil and gas sector, drawing from Oman's experiences.
Hello, everyone. So do you know anything about Great Place to Work? Have you ever heard of it before? Just raise your hand. Okay. So what we do, we help companies shape a good culture. And if we focus on oil and gas, where it's the highest paying industry, in the GCC specifically, it's important as well to keep an eye on the culture, because payment or income is not enough to be happy at work, and this is where we step in. So our mission is to help each company to become a great place to work for all without exception. We survey the employees, we listen to their experience, we assess different areas of the culture, and then we look into it by demographic, where we see by department, by gender, by seniority, and so on. We work with 21,000 customers across the globe, including 200 oil and gas companies, where we help them not only assess the culture, but also benchmark to each other. So these are some of the companies that we work with in the GCC. This is particularly in Oman. So the survey focuses on 5 main focus areas. We check the credibility of the management team. We check the respect, fairness, trust, and camaraderie. And we tackle those 5 focus areas across 59 statements and 2 open-ended questions. The survey is available in 70 languages, so everyone understands the survey, the questions before responding. Now, after closing the survey, if the client score above 65%, they are certified as a great place to work. If they score above 80, they will join the best workplaces lists as follow. So we celebrate in each industry, including oil and gas, including best workplaces in the Middle East and Asia, globally, best workplaces for women, even though I only see 2 female in the audience. And we do best workplaces in Oman. Now I'm going to hand it over to Mona. Mona will take you through more details, more data about Oman specifically, and how we focus more on the employees in Oman.
Thank you, Jules. So I just wanted to share with you some data points. It's very important to understand, to take away one key insight from today's discussion, okay? These are the charts that we have from Russell 1000. What we're trying to do is we're trying to measure what average workplaces like compared to great workplaces. In oil and gas, although you actually have healthy, high-paying salaries, are you actually retaining your employees or not? Are you an attractive market or not? It's very important to understand that. So looking at here, you can see it's higher by 3.5 times more than the average workplaces. We believe that greatness starts with leaders. You as leaders in an organization, you can shape the experience which drives the culture of the organization, hence the performance and the profitability. How do you do that? You start by actually the fundamentals of trust of an organization. You actually look at the agility and effort, and therefore you go straight into the revenue. And companies that focus on this has 8.5 times more revenue in employee per revenue, sorry. How do you do this? Start by the leaders, working on the fundamentals in terms of learning skills, what kind of inspirations, what kind of environment they're actually creating. Move that on into actually shaping the experience, and therefore you shape the culture which drives the performance. How do you trust in your leaders? This is the most important relationship you can consider. Do you actually tell people what to do, or do you actually inspire them by listening to them and creating that workforce where people feel actually involved? These are the kinds of skill sets that a leader would actually have. If you take a look at them and try to pinpoint on one of them that you can actually resonate with, what would you say that you can have as part of your company that you can actually expose more? I just want to give you a sample of our data charts. When you have leadership behavior actually intact and you're aware of their performance, you can see the retention rate happening in parallel. So therefore, if you have 10 companies that we've done as an assessment of, you can see in red, these are the leadership behavior, and then you can see how it impacts if the 2 statements would say, I would want to work here for a long time, or I would strongly recommend and endorse my company to family and friends. So there's a direct correlation between leadership's behavior and people who want to retain themselves in the organization. This is a very good example. One of the most important drivers that we felt in Great Place to Work is recognition. You can actually recognize people by 37%. This is a lot more higher than the idea of pay or promotion. So people might invest a lot of time in terms of training. However, in terms of recognition, you have it as high as 37%. Now looking at promotions, when people do get recognized, they do believe promotions are fair. And promotions increase by 2.6 times. What are the trends in the Middle East? What are the trends of the statements that we see that are very strong? We realize that people's sense of pride in the organization give you the high percentages of the 80s, so 83 to 89. The bottom statements lie more towards recognition, promotions, and favoritism. And that's down in the 70%. And this is an example of the statements that we have compared to the average GCC companies compared to the certified companies. And you can see, for example, things like promotions, there's a difference of 41% to 76%. In terms of retention, you can look also into the industries and see the gap there. And actually, 53% of population in GCC are openly quitting. They're actually looking for jobs elsewhere. So how to actually retain these employees is critical. The way for retention for us are these three main purposes: pride and fun. And if you actually focus on investing in those, you can see the exponential growth of 2.5 times. So this is what it takes to be a great workplace. Thank you. And if you have any questions, please reach out to myself or Jules on the side. Thank you.
Thank you both. Our next speaker is Mr. Marco, Vice President MENA, Bill Finger, and Mr. Siddharth Malik, Executive Leader in Energy Transition, for a side chat on strategies for decarbonization oil and gas operation. Please come both to the stage.
Shall we drag these up a bit?
I think so. Good afternoon, ladies and gentlemen. Thank you for being here. And Marco, welcome. Good to see you.
Same here. Thanks.
And just so that we have an understanding of what Bill Finger is all about, could you just help us and the audience gain an appreciation for that, please?
Yeah. All right. So good afternoon, everybody. And indeed, thank you for being here for this chat about decarbonization of the oil and gas industry. My name is Marco van der Linden. I'm the Vice President for Engineering for Bill Finger in the Middle East. For those of you that don't know Bill Finger that well, Bill Finger is an industrial service provider for the industrial facilities that are here in the Middle East and also in other parts of the world. It's a company that is headquartered in Germany. We have about 3,000 people overall in the Middle East. Half of them are engineers and designers. Obviously in the Middle East, very involved in the oil and gas, petrochemical and energy related industries. So that's what we're going to talk about a little bit today, sit with and see how the subject can be addressed for decarbonization of the oil industry.
Sure, no, thank you. Of course, oil and gas industry represents almost 15% of the global emissions, which translates to more than 5 billion tons per year, right? So I think the problem statement is very well defined. Specifically, what are the other key drivers for large oil and gas company to actually go down the decarbonization path? Because I'm sure it's more capital, it's beyond the core competency, and it's this fundamental shift and a change to way of doing business.
Yeah, so indeed some key drivers are generally what government regulations and policies are in place. Most countries, or I would say all countries nowadays, they have plans, whether they're called Vision 2030, 2040, 2050, and they always contain a component of becoming more sustainable. So that would be one of the key drivers. Another one would be that there are several technologies that we are currently, employing as an industry. You heard about the green hydrogen, the solar, the decarbonization, the carbon capture. So these technologies will also drive that we are now able to actually, pay more attention to decarbonization. There's also diversification needs that countries have, very dependent on oil and gas and carbon producing industries for their economies. But, the world nowadays expects more sustainable solutions to be supplied to the market. So these are just some of the key drivers that actually, make us go in that direction.
I think the last bit is quite interesting, that there is such a huge drive right now to diversify conventional oil and gas-pegged economies, right? I'm sure we're seeing the oil prices right now, and I think it also provides a nice hedge to such sort of shocks to the economy, right?
Yeah.
You talked about technology. Of course, there's solar, wind energy storage, CCU. I would draw upon your expertise from the sector. Are there any specific technologies that have already been deployed in the oil and gas sector that you can help us learn a bit more about?
Yeah, so, if you look at carbon capture, some people will define it as we capture and get rid of it, but sometimes it's also reused or utilized. Yeah. So we know that there are some industries that really produce a lot of CO2. So steel manufacturing is one of it, steel production, cement is another one. So there are projects that we have also been involved in that capture this carbon and, for instance, re-inject it in wells to be increasing pressure. So you basically put it back in the ground. So capture and get rid of it, in a way, yes. Of course, the carbon is still there, but it's now in the ground. So that would be one technology. The green hydrogen that is getting more and more spoken about in this area here in the Middle East, with quite a bit of abundance on possibilities to make it green. So by using renewable sources, solar, wind, and then produce the hydrogen is another technology that we are actually already using. That will, of course, minimize the carbon production.
Interesting. So just today I was having a conversation with how the subsurface understanding of these oil and gas well fields can actually directly help and translate into things like geothermal or even storage of hydrogen CO2. So I think it's interesting that here's a cusp of oil and gas sector and renewable sector coming together to solve a common problem.
Yeah.
Right? I imagine most of these technologies are not available everywhere, so I'm sure there's a lot of need for international collaboration. How do you, as a company who specializes in the oil and gas services side, look at the value of these international collaborations to solve these problems?
Yeah, so we are generally indeed aware as an overall overarching company to see where the needs are. So a lot of the companies are having a main focus or their core business, whether it is extracting oil or producing one or the other product, but never look at the whole value chain. So this is where we come in by looking at what is actually available in the market and see how these can be combined together to actually make the value chain as carbon, neutral or minimizing as possible. So that goes from the very start of the value chain till the very end to the products.
Right. And I'm sure Bill Finger, I'm aware, is one of the finest engineering talents in the world, with a large 30,000 base of very smart engineers and practitioners. But I'm sure it's still challenging, right? I mean, oil and gas sector has been around for a very long time. There are traditional ways of doing things. And the decarbonization interventions require a new way of thinking, new kind of capital, and maybe little reconfiguration of the skills of manpowers as well. Any outright challenges that you've seen have prevented these things to really take off?
Yeah, there are a number of challenges. Typically, this region has indeed been very oil and gas focused. So the infrastructure is also still very much that, and therefore not yet that developed to capture carbon or use it in some other way. So that's a challenge. The oil and gas industry is generally also very conservative. So, there's a lot of people that know for decades how certain things were done, while the newer energies or the energy transition, the sustainability drive requires new skills. So, this is skills that you get from, other parts, from people being educated here, but also somewhere else. Also, the diversification need that countries have will require that, you need to develop these skills to be able to offer that to the world. Financial institutions also now more and more demand that companies show that they are on a sustainable path if their investment dollars are ending up in the portfolio of these companies. So in Europe, for instance, the taxonomy is already with the ESG drive in scopes 1, 2, and 3, demanding that more or less by law. Here we're not that far yet, but companies have recognized that this is something that they actually need to do to be a player in the worldwide stage of energy transition as a whole.
Sure. And I'm sure while there are these challenges, there's also a lot of learning from the oil and gas industry as well. I know CO2 has also typically been, CO2 flooding is also very well understood in EOR, enhanced oil recovery, and other practices.
Yeah.
So does the learning curve get shortened because these practices already exist in EOR, maybe not for energy transition, but just as a matter of practice?
Yes, and let's not forget that we're getting more and more advanced in using the data that we have, we as an industry, and that's a lot because there's a lot of automation systems that record every minute all kind of things, pressures, emissions, etc., and actually use this data indeed to increase what we learn and how we actually converge into a less carbon producing facility. So this actually indeed will help us and shorten that learning curve that you were talking about.
Well, I think you've touched holy grail, right, which is data.
Yeah.
Right. Let's do a little deep dive into that. How have you seen data, and with all the advent of tremendous processing power coming in through AI and whatnot, actually helping this transition? Is there enough valuable information in form of data that comes out of oil and gas operations that can help in setting decarbonization strategies in place? Or is that data largely confined to just asset management for the oil and gas part itself?
Yeah, typically, and from history, it was indeed more for asset management, but nowadays more and more it's being used to see where processes or sub-processes can be optimized. So we measure more and more things,
right?
And this data will actually help us. So you do see in the industry that sub-processes in a value chain, whether that's extracting oil or producing steel or producing something else, actually gets studied and optimized. And then, of course, the whole chain actually benefits from that you have less carbon. So, I would say there are now companies that really specialize in this. There's a few here on the stage today that actually can help companies to, manage their carbon footprint better than they have in the past.
That's great to know. Any examples of successful decarbonization projects that have happened in the region or in your experience?
Yes, there are some. The one I think I mentioned earlier is the carbon capture from Emirates Steel, which is a steel producing plant in Abu Dhabi. We were involved in that as a company. It was about 10 years ago, maybe not as much as that, and then re-injected. So that takes out about 1 million ton of CO2 on a yearly basis. Wow. So that's quite a bit. Probably most of you have also heard of what's happening in Saudi Arabia. They have a lot of ambitious plans. NEOM being one of them. That is bound to be a very sustainable project with a lot of generation. And if you hear the numbers in terms of solar panel capacity or hydrogen or even wind capacity, they're staggering. They're like small country-sized facilities that they do there. So that's an example too. Another one from Abu Dhabi is Mazda City, which aims to be a completely carbon neutral, zero waste facility where people live and work. And here on home turf in Oman, the Dhofar wind farm is also one of these that is very successful in actually producing energy from renewable sources.
No, you're right. Some of these numbers on solar and wind are daunting.
Yeah.
Right? So it's quite amazing. What about access to capital, right? I mean, you need a lot of capital for these decarbonization interventions in conventional oil and gas, where capital flows are very well organized, right? Where do you believe there's a dearth of capital for such interventions, or there's enough capital available for such innovative projects in such century-old industries?
Yeah. I mean, capital is there, but it generally comes with demands that it is indeed flowing to where, the higher goal of building sustainable future is met. So this ESG drive, environmental, sustainable and governance is very important in that. You will have read in the past that bigger oil majors, Shell in Europe, BP, they're sort of scaling down on some of their sustainability projects because the investors or the shareholders, they do want to see returns on their investments. So that is still a little bit of a struggle because it is expensive to be sustainable still. However, it's developing in the right direction because if you compare, for instance, solar panel costs or solar generated energy 10 years ago with now, it has dropped by multiple factors. And, people claim that right now solar competes with just gas-generated energy. So it does come down, so the capital intensity decreases, but it's still a challenge. And it's a balance between getting the return on your investments while trying to get to that sustainable future.
I hear you. I think the idea of capital for decarbonization, but still delivering a typical return is a tough one to solve, right?
Yes, it is.
And we've seen that in the renewable energy sector as well. Of course, what we see with renewable energy, it's very de-risked now. So the capital for solar and wind development is fairly available. The risk-adjusted returns have to be there in terms of offtake risk and other things. But that's great. It seems like looks like there's some long-term benefits of doing decarbonization in oil and gas, right?
Yeah, I understand, Sid. I mean, you're also involved in this, looking at, possibilities and opportunities to, see how you can contribute with, the companies that you work for in supporting that sustainability drive. So maybe you can also elaborate a little bit on how you believe that works that could also be of benefit to the audience.
Sure. I believe energy transition, particularly in the context of Oman, I think is a phenomenal historic opportunity, right? If I may talk very country specific. Oman has typically been a gas-based generation, right, which is dominating. But now we're seeing green shoots where new policies, new regulations are coming in. And last year, almost 4% of energy was actually generated by renewable energy, right? So it's a small number, but I think the arrow is in the right direction. With some phenomenal forward-looking policies, regulations that are coming on. I wouldn't be surprised if Oman, of all places in the GCC, emerges as the bedrock of sustainable manufacturing simply because of the abundance of renewable energy, right? I mean, all the ingredients are in place. There is ample solar energy potential. There's a large wind potential that has been matched as well. There's a long coastline. So in terms of export and import of green molecules, that creates and just opens up phenomenal possibilities. And land, which is the fourth interesting bit. I mean, if you look at Europe, for instance, there may be possibilities, but there's not enough land to develop these projects. So in that sense, Oman is very uniquely placed. And I'm sure the way they're going about industrial decarbonization, by implementing innovative technologies on the demand side, be it steel, cement, oil and gas refineries, and other forms of manufacturing, combined with the renewable energy supply side, solar, wind. Quite recently, there was some discussion around developing pumped hydro, which is a great balancing for the grid, right? And long duration energy storage, which is the holy grail for renewables. So I think Oman is really pushing the pedal on making this like the green cluster hub of the country, of the region, sorry. And I'm quite excited about that.
Yeah. Yeah, I mean, we all know that this region has typically been a big energy exporter to other parts of the world. And I do believe that they have realized that they want to maintain that position, but that it might not be in the carbon producing industries like typical oil and gas, that the other countries that this is where this is going to now will be looking for other energy generators like hydrogen. So that could still be sustainably harvested here and then exported. So I do agree with you that we have all the ingredients that could make this work. Yeah.
Yes, and just last point from my side, you're right. Export potential, you're right, because it's been conventionally an export economy. But at the same time, the potential that exists for converting the conventional manufacturing to sustainable manufacturing and then exporting the sustainably manufactured goods opens up a different dimension of economic growth. Because if you look at how regions are moving today, we're seeing global alignment of supply chains. Data centers are scouting for geographies where there's development of and availability of clean energy, right? Typical cement steel plants are being located where there is ample renewable energy availability. So we see this dynamic balancing and relocation of supply chains, which I think is a phenomenal opportunity in itself, in addition to the export potential of the energy molecule. So,
yeah, I agree, and I also believe that society nowadays demands this. If you look a little bit further ahead, 10 years or so, people walking around here will not probably deal with you, whatever you do, data centers, manufacture something, unless you can be known as someone that does this responsibly and sustainably. So that's also indeed for the local consumption market. And let's not forget, we're not the biggest region in the world, but we are still a big region to satisfy in that respect. So,
I agree, and I think you've said the word, right? It's responsibly and sustainably.
Yeah.
I think those are the key takeaways from the discussion as well, right? So I think plenty of opportunities. Any closing points that you have on your mind that you'd like to share with us?
No, I think we are on the right track here. There is a lot of drive, a lot of support by the governments as well. They do invest. They do rely on the private sector to invest as well. But I think we have all the ingredients here, and there's a lot of skills that are being developed here. So I'm really looking forward to this future becoming more greener and more sustainable. So
I couldn't agree anymore, and we are so glad to be part of becoming that future, right?
Indeed.
Future in the making.
Yeah.
So thank you. Thank you, Marco. Thank you for your time.
Thank you, Sid. And let's work on this together, yes?
And let's make it happen, right?
All right.
Thank you. Ladies and gentlemen, thank you for your participation.
Thank you.
Yeah. Thank you. Kelvin.
Thanks, Sid.
Thank you.
Good.
Pleasure.
Yeah,
Thank you.
Same here.
Yeah. I'm going to get my coffee. Oops. They need to turn these things off. Excuse me. Can you help us with this, please?
Okay. Thank you so much, both. Please welcome our next guest, Mr. Luca Pataza, Commercial Manager at Al Pataza Group. He will be introducing the ARPT and its applicants in his session. Please come to the stage.
Yep. Okay. Okay, thank you. Hello, welcome to everyone. I'm Luca Albizzati from Alex Sistemi, Italy. We are an Italian company that is specialized in engineering, manufacturing, integration of modular solution for oil and gas and power generation. And today we are here to present a product of Eudosia Sistemi. The product is named ERPT. ERPT system is a power generation system based on a very simple closed Rankine cycle, where you have 4 working parts: the burner that we burn gas, a boiler that creates the vapor, a turbo alternator, and a condenser to make the vapor back to liquid. So what we did is we analyzed the needs and requests of our customer. We saw that on the market there are several power solutions that look to the very high power demand, so 100 kilowatt, megawatt, but there are only few solutions for the small utilities, and that's why we developed this system. This system can provide power from 1 up to 10 kilowatt and is used for emergency utilities or along the pipeline for the control pump station, emergency valves, everything that required small power demand. The system is a new system based on a very small footprint. So dimension required for the plot plan are very small, and it's a super reliable system. The system is based, as I was saying before, by a burner where you can connect even directly the gas, spilling it from the pipeline. And you have to consider that this gas in most of the plant is a gas that is not used, so it's a gas destined to be burned out in the system. So the main fuel of this system is also to recover part of the gas that eventually you burn out. Then there is as I was saying, the boiler. The boiler is where we put the fluid. The fluid is a particular organic fluid. Is not the normal water, and this fluid can change its state to vapor starting from 65 degrees. So this means that also the power required by the burner is small amount, and the efficiency of the system is very important. The third part, that is the main part, is the turbo alternator. Sorry. Okay. The turbo alternator consisted in a shaft that is mounted on bearings, and this shaft has a very special design. This system has been engineered in order to have no maintenance at all. And this shaft that rotate inside the turbo alternator is mounted on bearings that works in fluctuation on the organic fluid inside. So the shaft run up to 15,000 RPM, so it's a very high speed rotation, and this high speed can provide microfilms of a fluid between the shaft and the bearings. So the shaft is, we can say, fluctuating inside the bearing. So this has no aging of the parts because the shaft is not in touch with the bearing itself, and you don't need to do any lubrication of the system. In addition, we have the condenser. The condenser obviously is the part that make the vapor go back to liquid state, and then this will go in the boiler again to restart the action. What is important on this system is that everything is made, as I was saying, for no maintenance. The cycle itself is a completely closed organic Rankine cycle, so you don't need, once you activated for the first time the system, to do any maintenance or to change the liquid, to change the fluid, anything. And you don't have any aging of the parts, and the system is very reliable. So these are some specifications. As you can see, the footprint, as I was saying, is very compact. So it's just a dimension of a 10-feet shelters. And it's important to say that this system is environmental friendly. Why? Seems something strange that you have a turbine, you burn gas, and it's environmental friendly. But the main part, as I was saying before, is that the gas we are using is the same gas that eventually we have to burn out in a plant. The emission of the system are very low. We are talking about 7.8 cubic meter emission per hour in the functioning. The consuming of gas of the system itself is very small. And this system do not require any backup because, for example, for other application, if you put a diesel generator, obviously you need to do refilling of the fuel. You have a high emission in the air, and it's also something that required gasoline. Instead, also comparing it to solar system, it's a very compact solution. You don't need to have a backup of batteries because in solar system, in main application, especially on the control valve station, you have to provide backup of batteries for 2 days, no sun and others. This system can work 24 hours, 7 days by 7. And comparing also to solar system and diesel generator, as I said before, the maintenance is almost zero. Solar system, especially in these areas where you install them in desert, you need to do cleaning of the panels to remove the sand in order to guarantee the performance of the system. This one do not require any maintenance at all. So this system is a very innovative solution. We already supply several of these in a remote application, especially in Arctic application and offshore on platform. And now we are here to present this product and starting to install them in desert pipeline. So also, as I was saying, regarding the space, this system is very compact. So you don't need to have a huge plot plan even along the pipeline to install all the solar panel. And this system will provide the power on the same output of a solar system. So this system will provide 24, 48 DC at 50 or 60 Hertz. So another important aspect is the unit, central unit, the shelter, where we install the control of the turbine. This one is a 10-feet shelter, as I was saying, with all the control panel inside. But for application where it is required to have electrical cabinets to feed, to control pumps or valves, this shelter can be enlarged. And we did several projects where this module arrived even up to 12 meters, 15 meters. We just connect the ERPT system to the front part, and the rest can be used as a local equipment room for cabinet installation. What it's important also to say is that this system, even if we have a burner and a live flame inside, is certified EX. So we have a complete certification for installation in hazardous area, especially in offshore, but also in onshore inside the refinery or plants. And we developed this certification with the Bureau Veritas. So what we can say at the end, we have a system here that can provide from 1 to 10 kilowatt, as I was saying, for feeding RTU, telecom, pumps, control cabinet. And it's very reliable, is cost effective because no maintenance, so you have no cost for maintaining the system. No aging. We have systems that are installed from over 15 years and are still working properly without any substitution of the main parts. And small plot plan, reduced compact dimension. And what is very, very important is that this system do not need any backup for it. No batteries, no diesel generator backup, anything. It's just a system, reliable, that can be installed in all the most harsh environmental conditions around the world. So if you want any additional information, we are here at stand 4422, and we are more than available to explain more in detail the system. Thank you.
Thank you, Mr. Luca. Our next speaker is Mr. Bilal, BIM Head and Digital Formation Lead. He will be discussing building robotic digital twin strategy. Please come to the stage.
Assalamu alaikum warahmatullah. Hello everyone. First of all, thank you so much for, I would like to thank the organizers for this invitation. I'm so delighted to be here and share some of the interesting topics related to what we call digital twin. And today's topic, actually, I will go through what we call the easy way to create a digital twin. I will share with you a very interesting case study, and I will share with you also some stuff or our integrated integrated solution in Bureau Veritas company. So allow me to introduce myself. My name is Bilal. I'm the digital transformation lead in Bureau Veritas Middle East. I'm handling everything related to digital engineering, digital transformation, programming also, and I am an architect in background with more than 15 years of experience, and I have masters from UK, from Barcelona University. So as I've mentioned, I will go through what we call small or brief about Bureau Veritas. I'm sure that you have an idea who is Bureau Veritas. Then I will jump through the easy way, or what is digital twin from our perspective. since our core business is testing, inspection, and certification. And I will show you a very interesting case study about our integrated solution, and we'll jump to the Q&A. So BV, or Bureau Veritas, as you know, is a global leader in inspection, testing, and certification. And we have also what we call the digital services, but it's not similar or aligned, or let's say it's not our core business. But when it comes to the certification and testing, and specifically the inspection, we are using everything, or what we call digitalization, later on what we call building information modeling, as a tool to enable, to make our deliverables, let's say, digitalized, and make our clients, the life of our clients easy to get access, or create what we call a single source of truth in order to get all these reports easily in the future. So yeah, BV, it's one of the it's a global leader, as I've mentioned, in certification and testing and in inspection. We are existing in around the world, and in the Middle East we have what we call, we are existing in Africa, and specifically Middle East. And when we jump to Oman, we are here since 25 years back, with more than 400 engineers and staff, with 12 offices, including labs and project base and labs. So what's Bureau Veritas data acquisition or digital twin process? So usually, or the key in order to get what we call a successful digital twin, or to enable your digital twin or your digitalization, let's say, or digital transformation journey, is to get clear process, workflow, and you have to understand the client requirements. It's not about the complexity of the digital twin or the result itself. It's about how you are going to achieve the client requirements with the easy way, with straightforward steps, clear milestones, and so on. So one of the, as I've mentioned, one of the tools, or let's say the first step in order to enable or to create what we call a digital twin, or a digital replica, or a digital copy, a digital model, if you allow me to say, is to choose the right equipment, choose the right technology. Again, it's not about the technology itself. It's about how you are going to use the technology. What's your process? What's your methodology to capture the data? It's not about how much or how far, or it's not about the quantity of the data you are going to capture. It's about the quality itself. So in BV, we have a lot of technologies, a lot of solutions, depends on the client, or the client requirements, depends on the project type, either it's oil and gas industry, energy, or building and infrastructure. So we go straight forward, or based on this, project type, client requirements, we build our plan and we choose the right, let's say, technology to go with, or to create what we call the digital twin. So yes, as a BV or Bureau Veritas, we have the experience in all type of projects: oil and gas, heritage buildings, building and infrastructure, energy, power and utility, and so on. So what's the application, or what kind of, or what's the benefits, or why should I create, why should I go, why should I enable, or as a client I ask from BV or any other company to create what we call digital twin? There is a lot of, let's say, reasons. One of them is to go through what we call the predictive maintenance. It's for real-time monitoring, and to go with the scenario simulation. And by the way, the simulation is very, very important, because if you have a digital copy of your asset, so all kind of simulation, you can do it with less, risks, if you allow me to say, and you can test it a lot of time, multiple times, in order to get an effective result. And of course, the sustainability, and it's very important. By using the right equipment, the right approach, you will reach what we call a sustainable, or an approach for a sustainable solution for your asset, or for your oil and gas asset. Yeah. What are digital twins? I will explain it with let's say, with very, very basic way, or very easy way, straightforward. So imagine with me, you have like a building asset, refinery, or whatever. So when you take your laser scanner, or you take your drone to the site and capture the data, it's like, once you finish your data acquisition, you will create something called a digital replica. It's like a digital copy of your asset, a digital copy of your car, a digital copy of your whatever you have. Since we start injecting the informations, parameters, and getting live data from this digital replica or digital model, that time we can call it digital twin, because you feel like you are injecting live in this, or it becomes like a live model. So you will get an instant notification, real-time monitoring, and so on. So it's straightforward, but it has to be done. It has to be built on, let's say, we have to follow a structured process in order to create, as I've mentioned, a successful digital twin, and at the same time effective digital twin. It's all about informations. What kind of informations you need? We always start with what we call consulting or investigating, or we do what we call the assessment. First of all is we need to understand the client requirements. And this is very important. Some clients, they don't know, or they don't have clear idea about what is a digital twin, and sometimes they ask for well-detailed, let's say, a digital model. And actually, when we go through this, this direction, we'll face something which we call it an over modeling or over BIM. And it's not about representing screws in your model. It's about what kind of informations we need to enable your digital, let's say, digitalization or digital transformation journey. Then we jump to what we call the data acquisition, using, as I've mentioned, the drones. Then from the drones we create, or from the digital replica, we create the digital models, which called, if you are familiar with this term, building information modeling. Once we create the digital or building information modeling, and I will show you after a few slides one of the examples, that time you can start injecting the informations, of course, in alignment with your client, in order to get his journey, or in order to deliver an efficient, again, a digital model. Machines, as you know, since the first industrial revolution, have always served us, but except when they fail. So it's all about the machine, or what kind of machines you want to get the informations, what kind of informations, or what type of informations you need, or data you need it from your machines or equipments. So once these machines face, failures, if you don't have a plan, or let's say predictive plan, in order to avoid all these losses, you will face, as I've mentioned, the losses which will cost you time and money and resources. There is a lot of causes for failure. So allow me to mention, like, one of them, it's the misalignment, looseness, harm, fault, and so on. Again, when we have a digital twin, we as an experts in digital engineering or transformation, we need to create what we call we have to raise the awareness for our clients. Means like we have to show him what's the best way to save money, to save time, where he should place, or where he should enable the digital twin journey, what kind of equipments he need to follow, need to place sensors, and based on that, we can jump or we can get the right information on the right time. I will show you some examples, or this is one of the Bureau Veritas approach. This is what we call the integrated, solution, and one of the tools is digital twin or building information modeling. As I've mentioned earlier, that our core business is the certification, testing, and inspection. So in BV, we are using the digital twin as a tool. So instead of, just an example, for instance, instead of delivering the reports sort of PDF, Word file, Excels, this kind of stuff, we integrate all these informations inside the digital twin model. Means that the client, when he receives the reports, let's say the results, wherever this, and for instance, I've prepared this, case study for you for the tank inspection, let's say for thickness reading and DTs or all kind of, inspection, which you have in BV as services. Instead of going through the PDFs or wasting his time through this traditional way of reading, let's say, the data or the reports, he can simply navigate through the 3D model. And this 3D model, it's not paid one, it's open solution for the client, because some clients, sometimes they are not be able to pay, or they reject, let's say, for some reason, to pay the yearly, let's say, subscription for the software. The good point here is every time, as a BV, when we go to do the inspection, every 6 months, 3 months, 1 year, 2 years, this model, it will be updated automatically using what we call AI and machine learning. Means that this model itself, or the digital twin, and this is, by the way, another perspective or the use of digital twin, is this digital twin or 3D model or graphical representation or geometrical representation of your asset, it will be responsive over time. So imagine with me if we apply something related to climate change, sustainability, other, let's say, for asbestos, just for instance, and we put all this information inside the digital model. Means that we are trying to create an easy way for the client to access the data, to share it with all the stakeholders, and it will be a single source of truth for the client itself. Then there is hundreds of solutions in the market. If you want to jump a little, step further is, for example, if you want to go with a virtual, or if you want to communicate these results with the stakeholders or the responsible parties at least, you can jump a step further and go through what we call a virtual environment, or what we call the VR. So instead of navigating through the model through your laptop, iPhone, iPad, whatever, you can go inside this virtual environment and communicate, discuss, share information, share the report, which will be integrated and merged with your digital twin solution. Another point which is very, very important is in the tank inspection, as you see with in this example, what we did our thickness reading inspection. We got the result as an Excel with color coding, based on the color coding, let's say, like red, yellow, green, blue, whatever. And we took this, Excel sheet, and we transferred this one, we converted to a digital model, and this digital model has been merged with our BIM model, which has been done using what we call the laser scanners, the drones, and this kind of stuff. It's not about merging both data together. It's how we make this, model live and making it responsive. Of course, we've worked on an AI solution where every time you go to the site, every time you change, you customize, or whatever you do in your model, or as a BV, since I'm doing my inspection daily, every time I put or I finish my report, all what I have to do, of course, after a lot of training, and just for instance, I will give you 2 examples. We have something called PSP-Net50, which is a pyramid parsing network, which is one of the subsidiaries of machine learning, and the other one, which called You Only Look Once. It's one of the solutions for machine learning and artificial intelligence, one of the solutions to create your machine learning and AI model, to train your model. Once we train our model a lot of time, multiple times, as an inspector, when I go to the site, of course, there will be like some scripts, some programming language integration. All what I have to do is to take a picture of the asset itself, and based on the history of my inspections, it will generate for me the report, the results, the action plan, and so on. Again, I will show you another case study. This is one of the refineries which we've created. Our client requested to go with or to create a digital twin. As you see here, the point cloud data is overlaid with the digital model or the BIM model. So it has to be done through steps, which is the data acquisition, whatever the equipment is or the technology. So in this project, we've used the laser scanner, which is the Trimble X9. Then this is the BIM model. So till now, we cannot call it digital twin because we didn't place any sensors, we didn't inject any data, we don't have any data. All what we have is a graphical representation, and we can call it a digital copy, or you can call it an information model because there will be like basic informations. This is how it looks like. It doesn't need to be well detailed. No need to go through that much of the. All what I need is at least the shape of your equipment. Then we'll jump to the second stage, which is inserting parameters, informations, the type of the equipment, the manufacturer, etc., etc. This is how it looks like once we inject or insert the informations. Here we call it information model. Okay, it can be shared. We can do what we call quantities takeoff. We can extract, let's say, the data like the number of steel plates, number of pipes. We can even generate from here PNIDs and isometrics. And once we place the sensors, depends on the type of the sensors. Again, choosing the right sensors, it's very important. Why? You have to think about the integration and how fast the data, if there is any problem or the reaction of the sensors, it depends, because sometimes the reaction, or if you have like problem in the vibration or the temperature, sometimes it takes 5-10 seconds, sometimes 1 second. So we have to choose the right, let's say, the sensor technology. Also you have to think about the integration with this, sensor provider. Again, you have to think also about the number of the way how we are going to present the live data which come in from your model. This is one of the dashboards, and it's for the same project. And as you see, you can design your system based on the sensors you are using. And you can get, let's say, deep analysis about the equipment, the status of the equipment. And again, it's not about the quantity of the informations or the quantity of the data you are going to capture. It's about the quality. So make sure or to capture, to get only what has been required. No need to go with over, let's say, requirements, because it will be waste of time, waste of resources, and so on. Again, that's why in BV we've integrated, or we've used digital twins and building information modeling as a tool to minimize, to save time, and create a better solution for our clients. Thank you so much. Any questions? Okay, good.
Dear guests, we'll be having a break for 10 minutes. Our next speaker will be Mr. Clarence, who is a area sale manager at Arco, and he will be sharing insights from hybrid energy trials. Please come to the stage.
Ooh. Welcome. Can everyone hear me? Right. It's been a good 3 days, not long to go now. I'll try and keep this as brief and interesting as possible. As mentioned, my name is Clarence Hiles. I'm the area sales manager for Greco here in Oman. And today we'll be talking a little bit about Greco's hybrid energy solutions and how we can assist the oil and gas industry and its stakeholders with decarbonizing beam pump operations. Okay. So just a summary of the key points we'll be covering today. We'll be covering the challenges of conventional temporary power delivery to beam pumps, as well as the risks and challenges that these present, and then covering how the right type of hybrid energy solution, specifically a flywheel energy storage system, can optimize beam pump power delivery. We'll then be going on to the interesting part, which is I'll tell you a bit more about quite an extensive trial that we carried out with quite a prominent producer here in Oman, and how this is now going for further expansion within country. Right. So Greco have been delivering and operating temporary power on producing facilities within Oman for well over 25 years. Currently, we are delivering temporary power for several hundred producing sites in country. Now, diesel generators are typically used for the temporary powering of beam pumps. Now, this is either whilst it awaits conversion to overhead line, typically 3 to 6 months, or in some cases, a producing facility or beam pump can be under temporary power for several years. Now, diesel generators is an effective, fast and low capex method to deploy power to a producing well and get it in production quite quickly. But that does not mean it comes without challenge. Now, one of the typical challenges of powering a beam pump is the size of the generator required to power that well. And now, what do I mean with that? Now, if you refer to the graph on the right, what this represents is a typical load curve of a beam pump. You see quite a large load spike where the pump's lifting, but then also a phase where it's actually pushing power back to the generator. Now, what does this mean? This means that we're having to oversize the generator quite significantly against the average load of that beam pump. This leads to certain challenges. One is excessive fuel consumption. That leads to excessive emissions, CO2 emissions and other associated emissions, as well as long-term reliability issues. What does that mean for the producer? That means more deferment, as well as an increase in risk, particularly around HSE. Now, our stakeholders came to us and asked us, what can we do to not only reduce fuel consumption and emissions from producing sites, but how can we do so in a commercially and scalable manner? So Greco have been delivering hybrid energy solutions globally for well over a decade, particularly in North America, Europe, and Asia. Now, you may ask, what is a hybrid energy system? A hybrid energy system is a combination of thermal, storage, or renewable energy systems. So any one of those three things in combination form what is known as a hybrid energy solution. Conventional thinking led us towards utilizing battery energy storage systems. However, commercially, this didn't quite stack up. This led us then to looking at flywheel energy storage systems. Now, a flywheel energy storage system can inject and absorb large amounts of energy in very high frequencies for millions and millions of frequencies in a row. We then went to the market and partnered with a technology company called Dumeray, who specifically developed these flywheel energy storage systems, and they are based in the UK. Again, so what does this mean? What does this flywheel energy storage system and diesel generator hybrid system mean? It means that we can size the generator to the actual average load on the beam pump as opposed to the peak at the top. So we can significantly reduce the size of the generator installed at the well site. Now, how does it do that? The flywheel system will inject energy when the pump is under load, represented by the green portion in the graph, but also absorb energy when the pump is giving power back to the generator, effectively leveling the load. This enables effective downsizing of the generators installed at the well site. Now, what does this mean as far as impact to the end user? It means reduced fuel consumption, it means reduced emissions, better reliability, meaning lower long-term deferment, as well as an improvement in risk, particularly around HSE. On the bottom right here, you can see an actual model of real-life data of how the flywheel energy storage hybrid system levels the load. The blue curve at the top, I appreciate the graph's a bit vague, but the blue curve at the top is the actual pump load. The orange curve at the bottom is what the flywheel is doing. It's injecting energy when the pump's under load, it's accepting energy when the pump's giving power back to the generator. What that results in is the yellow curve at the top, which is an effective leveling on the load on the generator, enabling us to downsize it, enabling us to take that sizing at the top and bring it right down to the average. Now, on to the exciting part. In partnership with Dumeray and the producer, we developed quite a comprehensive trial strategy to assess how effective these hybrid solutions would be in meeting the aims of reducing fuel consumption, reducing emissions, being commercially viable, and improving reliability. We conducted these trials in H2 of 2024, and prior to this, Dumeray constructed a special testing chamber in the UK to simulate the environment in which these trials would be taking place. There was quite a high emphasis on making sure that not only can we effectively downsize the generator, but that we can then deliver power reliably over the long term on site. The trials were conducted in several locations here in Oman, and effective downsizing of the generator was achieved at every single location. What you can see in this picture here is one of the hybrid energy systems installed at site. In the background, you can see the beam pump, and in the foreground, you can see the smaller generator with a flywheel installed, operating and delivering effective power to the beam pump. In the background, you can see the much larger generator that's conventionally used. Now, what were the impacts and results of the trial? So as mentioned before, effective downsizing was achieved at all trial locations. Fuel consumption was reduced between a range of 16 to 24%, and the associated emission reduction ranged between 34 and 85 tons of CO2 eliminated per annum. There was also additional benefits with power factor and harmonic improvement, and the flywheel energy system achieved all reliability metrics set out prior to the trial. As you can see on the top right here, the red curve is the actual load on the pump, and the green curve is the effective load leveling enabled by the flywheel energy system. So quite drastic improvement. The graph at the bottom right is just a test case on fuel consumption. The orange curve at the top was the fuel consumption using the conventional power delivery, with the yellow curve at the bottom being the fuel reduction achieved using the flywheel energy and diesel generator hybrid system. Well, what's next now with these trials? Well, clearly they were quite successful. It's quite exciting because not only did they enable effective downsizing of the generators, but they reduced fuel consumption, they reduced emissions. Commercially, there was no impact to the end user. And then there's all the external benefits of better reliability, less deferment, a decrease in risk. But there's much more we can achieve from this. So there's further fuel reductions that will be achieved once we align the generator sizes more effectively to the flywheel energy storage systems. During the trial, we utilized what we have in country, but this can be significantly improved further afield. And I'm glad to say that now, on the back of these trials, we're now quite significantly expanding the delivery of these flywheel energy storage hybrid systems within the particular producing field. Thank you very much. I hope you found this little success story of ours interesting. If you have any questions, please ask them now or visit us at stand 5450. Thank you.
Thank you, Mr. Clarence. Our next two speakers will be Mr. Stephens, who is the Stimulation Domain Champion, and Umar, who is the Petrophysics Domain Champion, both at SLB. They will both be explaining the integrated protection workflow. Thank you.
Ladies and gentlemen, good afternoon. With the fact that the current price of oil is fluctuation, every single company have their own methodology how to maximize the NPV as well as maintain the NPV of the project. There are a lot of ways to do it. In one side, a reduction of the cost is a must, but also in the other side, improve the production is also possible. Therefore, today, we would like to show you several examples of our integrated production enhancement project that we have in a specific methodology and specific workflow. My name is Stefanus Dwi Kurniadi, and my colleagues Omur would like to show you through the journey as well as the example of those workflow. Before we going further, based on my experience, when we talk about the production enhancement, there is always one thing that we need to start with, which is a new mindset. A new mindset because this is something that we need to understand and applies for the well that already in mature state, as well as for the new well that currently we develop. Based on our experience, the success factor including 4 different factors. The first one is integration. Multidisciplinary effect, integration between client and service company, as well as integration between different disciplines in the company as well. The second one is be selective, especially for the old well. Not all of the well will be the candidate. The third one, acquire some new data, because the condition of the reservoir always change. The current condition is not the same as the previous condition when the first log performed in this well. And the last one is always calibrate and recalibrate. Not stop into the result, but close the loop on the understanding. With this new mindset, then we will be able to perform integrated production enhancement project.
And when we look at this graph, is our industry is really relies on the intervention and the stimulation to meet the oil and gas demands by the mature field contribution. You can easily see from the slide that the late life, mid life, and early life percentage-wise the worldwide production of hydrocarbon, which is projected to 2030, mature assets will be contributes nearly 80% of the oil production and the hydrocarbon production. Okay, so this is the one of the message that we convey. And other thing is the industry challenges. What are the industry challenges in the mature fields and the new well stimulation? I will touch base on the mature fields. So if you look at the top 4 causes, is mainly the top 3 is basically the whole condition, like a corrosion, wax, scale deposits, sand debris, and casing tabular leaks of failures. And the 4th one is the water, increasing the water production.
Now, for the new well stimulation, the biggest problem is pretty much the frac job is not work as it is.
Yeah.
For example, in the North America, 1 out of 3 stages is not producing. Internationally, 1 out of 5 stages may not produce as expected. And when we take a look on the survey, the majority of the problem coming in the first as understanding the reservoir. Non-understanding the reservoir, not knowing the geomechanic system, not knowing the depositional system may have impact on the production based on the result of the frac job. And the rest of the problem is pretty much on the operational side.
Yeah.
Human error, equipment availability, poor frac design, and all that stuff.
So that's why we create the approach. We call it a new mindset, because we know that this production enhanced project is not the new thing, but what we can put as on it in a new thing, new mindset. So what we believe strongly, we have to be in the same team with the client. So we are really trusting on the collaboration, working together with our clients on our specific fields. It could be small size, it could be big size, it could be well base, it could be multiple wells. The idea is to decide which problems we're gonna solve and in which field and how we're gonna do it. Once we decide this one, we have a digital capacities and it helps us to make a candidate wells to select it by this digital environment, algorithms, AI, and everything. Okay, so then the third strong part of our company is we are working more than 170 countries worldwide, and we have a lot of the expertise around the world working in the similar fields, different cases, different problems. So we call domain experts from every segment. We ready to bring to clients and discuss and be a part of the same team. And finally, as a Schlumberger SLB, we have a broad portfolio of the differentiated technology in every segment, like coil tubing, wireline, slick line, surface and the well testing, stimulation, and the power intervention. And this is one of the case study has been done in the Kuwait, and it's published already, so you can track you can download and read the paper. And then this is the West Kuwait Mishraf field. The job has been raised by we were doing the stimulation, but what happened after the couple of treatment, what we got some success, but with a mixed results. Okay, so then it was an open hole production, lateral wells, and basically there was an acid fracking. Okay, so then we come up with the investigation and the data, and we find the reason in the laterals wells there is a lot of leak, the teeth zones. Okay, how we did it? We just measure a single temperature, pressure, the log every wells, every laterals to detect all this. And then, as Stefanos mentioned, to fill the gap, we need another type of logging, like a fracture detection or the saturation profiling in the matrix. Okay, so after we did all this data needed, and we put all together all the previous examples and the new data, we integrated integrated the treatment, what we did before, and we just get a massive increase of oil production in the final, and we really lower the water production from the well. I can tell you, I cannot give you the numbers, but I can tell you the production is increased 3 times more than the previous one.
For the new well, we have workflow what we call intelligent stimulation, because in the new well, we have a time to prepare and put the strategy on how to improve the production that we would like to achieve with the stimulation. In this specific case, we will show you on the fracturing and stimulation case, right? It's all started with the reservoir-centric approach, where those reservoir-centric approach can be extended to the drilling, completion, and production phase. We usually start with the drill to frac, planning your drilling onto the stimulation, planning your drilling into the frac. What is the objective? The objective is to prepare your well, to prepare your lateral landing, if it is horizontal, for the fracturing job that you would like to do. The second one is basically frac to produce. You already able to place the well as preparation for frac, and then you would like to be able to frac it to produce the hydrocarbon. Now, in this case, majority, and related to horizontal, is to enhance the production, to enhance the productivity from each cluster, and select the zone of interest itself. The last one is basically in the frac optimization. In another word, is basically produce to recover. You produce to recover hydrocarbon from the wellbore. Meaning that in this case, there is a sequence of strategy that we need to deliver to the field, especially changing from the vertical, going to the horizontal, and in the end of the day, going to the well pad drilling, in the case of unconventional. It's similar to the acidizing. In acidizing, the main objective is to increase the reservoir contact. In the end of the day, the more reservoir contact, the more production potentially will come from the well. Now, in the end of the day, once all of this one able to achieve, the pad or field development plan will be the main case. To enable all of those strategy, a measurement will be needed, which is including the acoustic and geomechanic, understanding your geomechanic of the field, petrophysics, understanding your rock profile, understanding exactly where the hydrocarbon will flow, or understanding where the hydrocarbon will be stored. Geology and geophysics, is there any geologic attribute that will be impact your stimulation, that will be impact your fracturing? And in the end, laboratory, to confirm the understanding from the measurement with the actual measurement. For example, we have 3 examples. The first one is tight gas. In tight gas, we know, without hydraulic fracturing, we will not produce above economical limit. However, placement in tight gas is quite difficult in some cases. In this case, it's a case of Oman. We have the first couple well, we're not able to place a job properly, and the remaining of the well, we enabling by measurement, analysis, and deeper analysis, the production tell itself. Initially, the production is not that great, and then after that one, the production improved significantly. The second case is basically offshore. In this offshore case, in the initial phase, when they drill the horizontal well, there is no understanding whether the fractures will be contribute to the screen out, whether the fracture will be contribute to the production. With the more and more horizontal well being developed, they enable understanding of, okay, this fracture can be handled, we can frac on that one, and we will not screen out on that one. Therefore, the production increased also significantly. And the last one of the example is the unconventional, which is pretty much in North America. As I mentioned, only 60% of the cluster produced and the remaining is not produced. In this case, usually the unconventional is geometric. They place the perforation every 50 feet, 20 feet, or 30 feet, right? In our case, we also encourage the client to put measurement along the lateral to enable us to select the best scenario of the cluster with honoring as well on the geometric placement. So all of this example is included in an intelligent stimulation workflow. Thank you very much for your attention, and we open for question and answer if there is any time.
Yeah.
Thank you.
2 minutes. We have 2 minutes. If you have any questions, please. I think nobody has it. Yeah.
Okay.
Okay.
Thank you very much.
Thank you very much.
Thank you very much, both. Our next speaker is Mr. Ali Mohammed Al-Wardi. He's a head of research and development at Oman Energy Association, OPL. His topic will be on building further ready workforce, the Oman Clean Energy and Labor Outlook, OPL.
كيف يشتغلوا؟ Assalamu alaikum, good afternoon. Thanks for your attendance. I'll move a bit from the technology side to human factor. In the coming 15 minutes, I'll share with you some insights on the work that we did last year by OBAL. So this is about future-ready workforce in the green market or green industries. I was privileged last year to lead this consultancy work, which was commissioned by OBAL and delivered by Majan Council, with some objectives in mind. At that time, as you know, there's a lot of projects and plans and strategies happening in the country in terms of renewable energy, green industries, and so forth. So this is a proactive move from OBAL to really look into the human capital requirements in the future and competencies, training, and so forth. The first thing that we focused on, one of the main objectives, was the current and future industry trends. So what sort of industries might happen in Oman in the coming decades? And into that, we looked purely into renewable energy, solar, wind, hydrogen, and some related industries within those compounds, considering or focusing mainly on economic and commercial opportunities of these industries. From there, we looked into some of the green jobs, if you wish to call them, that will be generated from these investments of these industries in the future. And within that, we looked into identifying the types, the numbers, quantifying those numbers of the jobs, the skill gap required for those jobs to upskill them or reskill them in terms of finding the right opportunities in the future. And at the end of the day, we developed some sort of a policy or roadmap how to implement this outcome, something to be used by decision makers, investors, academia, and so forth. So that's those three main pillars of the work that we did last year. We involved a lot of stakeholders, a lot of entities into this work: government, private sectors, international, local companies, academic institutions, and so forth. It was really intensive work at that time, because the point was really to have to include the local context in the outcomes and the results of this work. So it's more related, more applicable at the end of the day. The expected outcomes from this work, about 7 items. The first one was the foresight exercise. Foresight exercise is really building the future scenarios. What could be the future scenarios for Oman, considering the local factors, international factors, some influencing these decisions and these investments in the future. And then it was also important to really benchmark and grab some learnings, best practices from global investments and global industries. Into this, we looked into Germany, PV manufacturing industry. We looked into the Netherlands, wind manufacturing industry. We looked into Morocco, EVs industry and battery. We looked into Saudi Arabia also, establishing the new factories for the electric vehicles. So a lot of learnings out of that. Then we looked into sectorial screening of 30 sectors combined together. And we filter them, we go in depth into these sectors to identify the best out of them in terms of investment potential. So out of that, we get into 12 out of these 30 sectors. We analyze them further. We looked into the potential job creations, potential investment on those sectors. And we also looked into the local ecosystem in terms of education system and the job seekers, to really get an idea of how it looks like. Is it ready? What sort of gaps there are existing already. Occupational mapping, that's a database we developed for the main jobs that will be generated here. This will be online tool, it will be open for public mainly inside Oman. And then finally the roadmap. Sorry. So these are the 4 scenarios that we thought of from the foresight exercise. What is really important because we need to understand how the future might change. What potential investments, potential hinders, potential challenges could be. So the baseline for us is a constant current. That's the first scenario where things might stay stable as much as possible. The alternative scenario for us is the shifting wind, where things might shift, but still in the positive side. The worst case scenario, looking into this, was the raging storm, which is completely changing the plans. International conflicts and international priorities might change. Rising tide is the best scenario for us, where the innovation and technology and the need for the industry, for the energy, clean energy, is really boosting. So those are the 4 scenarios that we looked at. It is important for us as well for our analysis. So here, if you see on the left side, these are the 30 sectors. We group them. First group is energy development and services. Then it's something under manufacturing. The last group is about final products, or clean products, in fact, as an outcome of them. The ones in yellow are the ones that we analyzed using those factors, the 7 factors top there, where we focused more on, where we derived the workforce requirement in the future. The ones in yellow, they are more feasible in terms of the local investment opportunities. And for each one of them, there's a lot of text in the report explaining all these elements of analysis. But we thought to present it graphically to make it easy to compare and make a quick decision on it. So this is a graphic representations. The one on the left is a solar panel manufacturing. The one on the right is wind turbine manufacturing. If you see, you can compare it to. We have the low scores in the middle. Then the middle circle is in the mid values where the scores are, and the best are the outside values. The more shades on the shape is the better scoring from the analysis. So this gives you a quick comparison between the different sectors for decision making in terms of investment, of course. Moving forward, all of these 30 sectors, when we compare them, we saw there's some similarities in them. So we try to group them and we cluster them. We call it clustering those 30 sectors. This is for someone to make a decision on feasibility of the investment of these sectors. For example, the key opportunities, these are the low risk, low hanging fruit to go for. There are some other groups that need a bit of careful planning and some balancing between the socio-economic benefits, some trade-offs. So this is some sort of an analysis and summarizes all these 30 sectors in a meaningful grouping together under the same factors. Remember the 4 scenarios that I showed you earlier? This is an outcome of those 4 scenarios in terms of manpower projections over the coming decades up to 2040. The one on the left, solar energy development, this is within Oman, by the way, it's not a global thing. The employment opportunities ranges, in fact, from around 2,000 up to maybe 9,000 or 10,000 jobs for the solar. It depends on how things might change in the future, and this is what's important, why we have the 4 scenarios. The wind on the right side is similar cases, ranges, between 1,000 to up to 5,000 or 6. The hydrogen industry, variation also from maybe less than 5,000 up to 24,000 of employment opportunities possibility in the future. And then we looked into something else, which is the skill gaps. This is something to do with the solar industry. We looked into the skill gaps in different stages of the project, looking into considering the local market, of course. I will show you example, the ones in the yellow, for example, commissioning and connection. If you see, there's low availability of people in the market at the moment, but it's in high demand. Urbanization potential is low. So this is one extra analysis that we did. And another example is for the operation and maintenance, the quality assurance and the control. This gives us a better indicator of high possibility of employment. This is for the hydrogen. This is the synergy of hydrogen requirement within the existing industries in Oman. Where does it match and where the gaps are? The one on the left is a membrane. There's a low in terms of synergy and skills in the market. But if you look into the heat exchangers, we already have that know-how and we have the facilities in place. So that could be a low risk. This is quickly, I think this is the last slide. This is the academic analysis, the academic system. I want you guys to focus on the brownish colors, which are the gaps in our education system, meeting the project requirements on the right side. So if you see, for example, construction and installation of BVs, we are lacking technicians from a diploma level. So that's not available at the moment. This is one of the outcomes. If you go to the wind, it's a similar thing. It's a diploma holding technicians that will be required for operation and maintenance, and maybe sometimes they will be needed for the construction phase. This is the last one. This is the occupational map that we developed. Every white dot represents a job role, and every job role has a description and competencies. So this gives us an indication of how many jobs, at what stage, and what their description, what skill gaps, or what the skill competencies that comes with it. And that's it from my end. Thank you very much. If you have questions, or I don't think, do we have time for questions? One question? 3? Okay, 3 minutes. Any questions, guys? No? Okay, I think you can connect with me if you need after the presentation. Thank you very much.
Thank you, Mr. Ali. Our next speaker is Dr. Ram Langham. He's a faculty of IT, Majani University. He will be speaking on the topic of building Oman's talent for sustainable energy future. Please come to the stage.
Thank you very much for introducing me. Good evening, ladies and gentlemen. It's our pleasure to be here. I am Dr. Ram from Majani University College. I will be presenting about the building Omani talent. This is much related to what Opal was presenting to you now. So national vision, we are very much familiar about the national vision of Oman. So it is about the sustainability and net zero emission by 2050. We are planning to move towards that target. Yeah, of course, the priorities are there and the plans are there. Government initiatives are there, and then we need a workforce development on this sector, which we are doing it again. So the digital transformation and automation is the main area where we want to focus now for the sustainable energy development. So in that, the catalyst for sustainability is the digital transformation, which can reduce the emissions and energy production. Now the digital transformation, digital twins is the buzzword along with the AI. When you talk about these things, how do you promote and the local talents? That is how we are coming in. So if you look at the global statistical information, the recent one, it is talking about the 9% steady growth in the sustainable energy development and the industrial automation market. So you can see from the 2022, it is 213, and then it goes into 2032 about 493 billion US dollars. It's a good steady growth. You can see the graph. There is no cutting here or going down. It's a steady growth is maintained. So how are we going to participate in this global growth of 9%? So again, another survey also talking about this same. It is not only about one survey, one study. It is talking about many different studies. I took the two top ones. So in that case, the global market is looking in the industrial automation sector is more focused into the control systems and automation. In the control system, it is talking about the DCS, PLC, and the SCADA systems. So these skills, are we really having it in Oman? What is the status of Oman in this current scenario? If you talk about Oman, industrial automation is also growing slowly and steadily, but still it needs significant investment in technology and staff training. So more jobs in this sector are taken by the expatriates. This is the reality. So how are we going to contribute in this domain? So Omanization trend, there is a challenge here about the professional level skills development. There are in many other factors. There is a steady growth is there. Even this year, there is an improvement in 1.3% about the Omanization target. However, the challenges are there still in the industrial, technical jobs and professional jobs. So we are coming from academia. How we can see from academic perspective of this, how we can contribute as a higher education institute. As a higher education institute, we have to focus on blending the vocational education with the industry-driven curricula in the higher education. We cannot have a separate academic program which is completely different from an vocational program. That is a different gap. That gap has to be merged to make the graduates work in the industry ready. Dual education system is a part which we are trying to invest. Make the internships as an compulsory component. It's no more optional. The students should get, with the cooperation of the companies, we need to get internships for our students so that we can reduce the training period which is required after the graduation. What we see from the statistics, and I have a good, our team is having a rich experience in this Oman market. We go to the training centers, we go to the Ministry of Energy, their trainings, it's a long trainings, vocational trainings are there. But the students don't get any academic degree. That is why we came up, we are with this plan of internships inside the program. The internships will make the students ready for the industry. So, Majan University College, we are offering a unique program which is called BSc Honors Computing Oil and Gas. This program is not available in any other college in Oman, even in the region I can say. This program is merging the information technology with operational technology OT. The students are getting the skills in industry-driven curricular skills in the digital transformation, business process management, and the industrial automation technologies like DCS, SCADA, PLC, and field devices. They should be able to handle the automation pyramid, if you are familiar with that, from the field devices to the ERP systems. The industrial automation lab, we are having a state-of-the-art lab is there also. So that labs are providing students the variety of skills which they need. And this is a glimpse of our lab, which we are using this. We can see a variety of PLCs there. We customize these PLCs to make sure that it is fit for the students to use it without any compromise in the safety measures. Plus, there is a conveyor belt in the corner, the right corner there, you can see a small miniature conveyor belt, and here you can see a tank in the front, water tank to flow the water from one tank to another tank. The students will simulate and also use the real-time experience in this lab. Besides academic training, we also provide, besides academic courses, we also provide training through our sister concern, Majan Training Institute. So we focus more on the Omanization target, how a HCI can provide talented professional skills through its academic program, which is ready for the industry. That is our target. Thank you very much for the presentation timing. Any questions? I'm ready to take, guys. So if you want to contact me, please scan my contact details so I can be in touch with you guys. Thank you very much.
Thank you, Doctor. Our next speaker is Mr. Nabras Riyami. He's a People and Culture Manager at Opel. He will be discussing HR Policy Development Best Standards Opel. Please come to the stage.
Assalamu alaikum wa rahmatullah. Good afternoon. My name is Nabras Riyami, People and Culture Manager from Opel. I'd like to start today's session with a question. What does a broken policy sound like? Maybe it sounds like a frustrated employee, maybe it's the echo of a labor complaint that's currently ongoing, or maybe it is just an opportunity that was missed. Today, we will explore why governance and HR policies are not just documents, they are living systems within organizations. And more importantly, I will explore how we can move from structures to making real impact across Oman's energy sector. You might be surprised why this topic today. We're all aware that majority of oil and gas companies have very solid HR policies in place that are well structured. So where's the problem? Why discuss this? As we move from operators to service companies, and from service companies to contractors and subcontractors, policies start to weaken. Not only weaken, some of them don't have policies altogether. In 2024, there was recorded over 33,000 labor complaints with the Ministry of Labor. That's a reduction of around 45% from 2023. It is an improvement. However, this is an indication of where we are. Many complaints are related to abrupt layoffs, bad HR practices, or contractual violations, especially in smaller organizations. And of course, as Opel representatives, we have to end up being in these sessions trying to figure out these disputes. And then this tells us there's a massive opportunity for improvement within the sector itself. I'd like you to think of an organization as three pillars, a three-pillared stool. You have one of the pillars is an operating model, how the company is structured and how it operates, a governance framework of how decisions are made, and then policies of how, what are the rules and expectations as we move forward. A strong governance is required for organizations to sustain and flourish within their respective industry. To put it simply, let's put it this way. If you have a structure or operating model without any policies, it just creates confusion. Yeah? If you have a policy without governance, it creates chaos. And a governance without its people is meaningless. The best organizations are not those with the most documents or the biggest in size. It's those that have a governance model that actually works within the organization and is molded as time progresses. Our goal, finally, is not to only establish policies or write them down. It is to embed a governance idea within these organizations. So now we talked about governance, we move on to the actual pillar of policies. A truth that is often missed is that not all policies are created equal. If they were created equal, okay, this would emerge in a few problems, and two main problems to be specific. Too many policies would end up confusing your employees, get them overwhelmed. Too many policies that are all created equal would also dilute the focus of leadership within your organizations. Hence, segmentation is required. Let's explain what segmentation is, and then we'll explain why we need this segmentation. So starting with a two-layered approach, grouping policies based on the strategic priority, whether it's a governing policy or an employee-related policy. And then the second layer is based on audience relevance, so public policies versus private policies. Now, why is segmentation important? Think of yourself walking into a library with a lot of books, and all of them are just dumped on the ground in a pile. So how are you supposed to reach what book you're actually looking for, the information you actually require at the moment? So that's the equivalent of not having any segmentations of policies or classifications. Next, we go to the problem of the structure of your policies. Have you ever been in an organization where you read a policy and you're confused? You're like, what does this policy actually serve? It's been written in 1997. Everyone that wrote it either retired or has moved on to another place, and it's not really relevant to us. The fact is, a poorly written policy for an organization is a lot more detrimental to an organization's health than not having a policy at all. You're just better off not having anything if you're not going to write it properly. As you can see on the screen, there are 8 dimensions for an effective or a clear policy. Each single one of them is as important as the other. However, language is equally important. In normal practice, policies are written in a legal language. It's quite intimidating to read. It's not used as, not written as a tool for usage of employees. What you'd like to do is actually embed inclusive and empowering language from indicating entitled to, responsible for, required to. Okay, empowering your employees. You want your policies to be drafted in a way that are clear, but also is friendly for your end users. You want them to refer to your policies as tools to get through their business. A funny story about this, about policies, clarity, and availability. I met an industry professional who is a senior leader of 17 years. And we were talking about HR policies within their organization, because naturally they have a lot of problems. And his comment to me was, you know, I've been working in this company for 17 years. It's an international company. And he's already at C-suite. And he's like, I've never seen our HR policy. So that made me wonder, if you as a senior leader didn't see it, what about the rest of the employees? Is that possibly a problem? This is where policy management systems actually come into place. So a policy management system enables organizations to not only showcase but communicate what policies they have. What are the rights of the employees? How do we operate? What do we do? And interesting information, companies with policy management systems get around 87 to 99% attestation from their legal bodies within their countries. But still, 38% of companies don't have policy management systems. And you find in the EU study of 2024, a lot of these companies actually spend a lot of time and effort raising awareness for their employees that they have policies and how to read these policies. Their time is actually split between raising awareness and dealing with policy violations. So accessibility is no longer an option, especially in the day and age that we live in right now, and the availability of technology. So publishing your policy management system is, I would say, the final nail in the coffin. But it's not the finish line. You're trying to enable your governance of your organization. And that means employees can find your policies, understand them clearly, and trust them to be fair. Achieving this demands intentional communication, accessible platforms, and a leadership mindset that treats policies as living tools. So one of the areas that you look at when it comes to policies is the review cycle. Typically, a policy should last 2 to 3 years. A stable policy should last anywhere between 4 and 5. Going back to the challenge of having a policy that doesn't make sense at all, these type of policies were never reviewed. They're written, drafted, applied, and a lot of the times you find practices that actually oppose what was developed and puts the company in a very difficult situation, which ends up leading to labor complaints and disputes with your employees. As leaders across Oman's energy sector, we must move from passive policy distribution to active engagement with our people within the sector. Finally, I want to thank you for joining me today. Opal is on a journey to bridge the gap between industry and regulations. But we have, as a sector, a role to play when it comes to distributing policies and rights of employees. We can really make a dent on the number of labor complaints that come up, but it's also a tool for you to sustain your business and flourish as well. If there are any questions, I'm ready to answer. Thank you very much.
Thank you, Mr. Nabraz. Our next speaker is Kevin Parks, Head of Business Development at Agrico. We'll be talking about Oman Fairly emissions. Please come to the stage.
Hi there, everyone. Good afternoon. I'm Kevin.
time's just coming up to 4:10, so we'll come back to that later on in the discussion. And a big thank you for your time. Well done for sticking it out. We are on the last lap of Opes 25. There's been around 70 speakers up here, and it's been a privilege to learn their diverse perspectives and innovative solutions over the last couple of days. And I'm going to discuss with you about how Oman is leading the way in the region to achieve a World Bank mandate of zero routine flaring. Before that, a little bit about me and why I'm talking to you. I've been in the industry for around 20 years, growing through engineering, project delivery, and operational roles around the globe. I've been fortunate to be allowed to lead and influence material areas of growth in the business, and a really large facet of that has been in flare-to-power solutions. That includes over 250 MVA of projects across Oman, Egypt, Kurdistan, and the UAE, among others. I'm hoping some of that experience can be shared here today. So what are we going to cover? We're going to cover how Oman is shaping the future. What do we know about the brutal reality of facing this ambition? And we're going to navigate some of the material factors that we're going to face. So let's talk about ambition. What makes Oman a leader in the race to 2030? It is its commitment to change. So Oman recognises that 30% of the country's GDP is driven by oil and gas, and it's acting with the right authority to continue that industry responsibly. Along with the esteemed Omani government, several national oil majors have signed up as endorsers of the World Bank Zero Routine Flaring by 2030. But what's really exciting is the statements released in the sector that is pulling that ambition even closer, potentially 2027. So all of that's excellent, but we have a long way to go. And what is it we can do to stem flare and help meet our goals? Let's cover the basics. The options are gas to power. So we convert flare gas into electricity for local or grid use. We can wheel the power back into the grid, or we can build power purchase agreements with off-takers. We could take the route of gas capture and utilisation. So that's capturing the gas to relocate in the form of LNG or CNG. We can use it for petrochemical processing, or there's a growing carbon capture and storage applications that are starting to emerge in the industry. And then finally, there's reinjection. So re-injecting gas into the reservoir to maintain pressure or for future extraction. What I want us to focus on is what do we know, and that's flare to power. So let's take a look at a quick example. The great news is we're on the path to success. It's been a long, technically challenging journey, and it's been the first of its kind. I'd like to acknowledge the courage and leadership of CCED in being the first to break ground on this and setting the bar on how to make progress on these types of projects in Oman. The data from 2024 is showing us why it's worth the effort. Not only do we benefit from using the waste energy, it's the displacement of off-grid energy sources that really doubles the benefits of the project. You can see a 33% absolute reduction in CO2 and a 3 million Omani Riyal reduction in cost of energy. These are statistics that speak for themselves. We have intangibles around supporting longer-term strategies in country, the in-country value, and innovating technology and stimulus to support applications evolving from the same. Well, that's a lot of words. What do I mean? I mean investment in local talent and building momentum to pioneer more of the same. Pulling that thread a little bit further, our experience tells us that there were material risks to navigate even with the success the project carried. Early planning on this is non-negotiable. I'm going to lean into our experience in Kurdistan, which has seen us retrospectively be able to claim carbon credits for our flare-to-power project. That's generated over £1 million a year. But more importantly, it gives the project full credibility and recognition of its impact in reducing emissions. But this takes time, and it can be 6 months to 1 year in process. So playing that early in the project feasibility is now essential. Further to that, the clock's ticking on mandatory decarbonisation, and that window is getting much shorter to leverage this opportunity. We're going to continue to walk through planning, and this won't come to a surprise, but understanding complex regulations and how to best position the type of project you're developing against them is possibly the most tricky stage. There are currently some areas that require further consideration as we innovate solutions. An example being the classification of associated flare gas. Baseline standards are built off natural gas and point towards permanent infrastructure standards. We're navigating volatiles, nomadic and stranded sources of gas, and we're learning to shape and design both solutions and standards in parallel. It's going to take developers, users and ministry bodies to collaborate for an orderly transition on the same. Let's continue moving through execution. Global supply chains in raw materials for special CapEx accessories are in high demand, and this is compounded by bottlenecks in global shipping routes. The general impact industry-wide is causing a cost premium and a multiple factor of up to 1.5 on schedule. In simple terms, it means the usual 12-month delivery could take up to 18 months. So all of this is mission critical, and the margins for error are tight commercially. Ultimately, I believe we all understand in this room that there's a balance between the race to zero and in parallel with sustainable outcomes and returns of these projects. How do we bundle all of that knowledge and summarise? Well, 5 years is racing towards us really quickly. Risks in demand, working capital and time-consuming regulation are real hurdles that affect us here and now. But the benefits are clear, and we have a proven economical and environmental return demonstratable here in Oman. So what should we take away from this, and how does it all align with the bigger picture? Reducing routine flaring is a solvable challenge. With targeted infrastructure investment, regulatory alignment and innovation, governments can turn flaring from a liability into a national asset, boosting energy access, lowering emissions and attracting long-term investment. And hey, before you all run away, for those who were paying attention, at the start of the talk I did mention the time. While you were listening to me, Oman emitted 165 tonnes of flare gas. So let's put that into perspective. That's equivalent to 92 Olympic-sized swimming pools in volume of emissions. What are we waiting for? Well, nothing. We're now on a trodden path, and we just need to keep going. So let's make 2030 a reality. Thank you for listening. Any questions? You can visit a Greco at 5:40 if you think of one later. Thanks.
Thank you so much, Mr. Kevin. Our next speaker is Mr. Roma, Head Investor Relation at Rothschild. His session will be about urban development and sustainable projects in big cities. Please come to the stage.
Thank you. No, it's not the first. Thank you. Okay. Hello, everyone. First of all, I'd like to thank the Oman Sustainability Week organization for having us. And secondly, I also would like to thank the Swiss Embassy for all the work that has been put together and to give us the opportunity to introduce you today to what we are doing at Edmond Rothschild. So, and I would like also to thank you, the last guys being here. I mean, obviously we are finishing the event. So basically, as you may know, the Rothschild family has been around for now more than 250 years. And basically they've been super active around two things: private banking, and they have also, across the different generations, the 7th generation, they have been extremely active investing into the real economy, investing looking for profit and impact. So as you know, globally today, we are living in a world which is facing with 3 different crises. The first one is the climate change crisis, obviously, and the second one is the biodiversity loss. The third one is the pollution. The good news is that basically there is one root cause of these different crises, which is the use of land, the use of space that we have currently. And actually, with a more balanced approach, with a more reasonable, with a more planned approach, you can definitely have better results and solve the situation. So what we have put together with our partner Jinko is that basically we have focused on the market opportunity that we have. The market opportunity is fourfold. Number one, the big issue today is the urban sprawl, the urban expansion that we can face today in the different cities. The solution is to actually bring more compact cities going forward. And thirdly, to do so, actually, you can develop the land that has been previously depolluted. And this is how you can actually rebuild the city upon the city. Obviously, we are in EU, we are doing a lot of these activities in Europe, where actually regulation is absolutely key to respect in order to make sure you can create some value. Again, what we want to do is to invest in order to offer some profitable opportunities to our clients, but also to generate some impact. So basically what we are offering to our investors are return, and what we are looking for also is a positive impact for the local economies, for the social environment. This is what we are looking for. So if we dig into the urban expansion that we are facing today, and if you have just one figure to bear in mind, it's that by 2050, so roughly within 25 years, 66% of the world population, 2/3 of the population globally, will live in a city. So it bypasses some issue because as of today, the urban expansion is going on, and actually we are eating more and more arable land, nature, and the balance is losing its equilibrium. So the rising need for a more compact city, basically, it has been estimated that 45% of the urban greenhouse gas emission could be saved if we had more compact cities. There are 2 ways to find opportunities into this business in Europe. The first one is actually to focus on polluted land. We have found that actually we have 2.5 million polluted plots across Europe, super well situated, great situation, where actually you have a lot of work to do and it's great opportunities. The second one is actually offices buildings. In Europe, I see that in Oman, you don't really have this issue, but actually in Europe, 50% of the office buildings are actually 30 years old. So they are almost vacant, fully vacant, and actually they are totally obsolete. So there is a lot of work to do and a lot of opportunity for us. So what about the value creation? How we actually do it? Basically, now we have built, over the last 15 years, we have built an investment process that we respect, that we develop, and that we actually go step by step in order to make sure that we can replicate the value creation we have done in the past. The first one is the sourcing. As of today, we have a great network in order to make sure that we can source these different opportunities across Europe. Then we are doing our due diligence, deal structuring, urban planning, remediation, and development at exit. Actually, if you have something to bear in mind, there are two critical phases into this kind of process. The first one is the acquisition and the remediation. Basically, you want to buy this land super cheap, and then you want to remediate the land, to depollute the land. And secondly, you want to do the urban development. So basically, you want to obtain the permit to construct thanks to the local authorities, thanks to the relationship you have built with the local authorities, and then you want to redevelop the whole neighborhood. So this is a full cycle project. The good thing is now we have in-house all the different expertise, so we are able to actually integrate each and every phases and to make sure we can parallelize and to optimize this process. Here are all the different opportunities that we have currently. As of today, after 15 years, we have already done 30 projects, 30 projects, across Europe. And so actually, we know that we are able to do that. And as of today, we are currently raising new funds in order to replicate the same thing across 23 different projects that we have already identified. This is how we do remediation. So basically, when it comes to depollute a land, you want to depollute chemicals, heavy metals, this kind of stuff, asbestos. And actually, we do it in two phases: due diligence phase, and then actually the actual remediation phase. And on the remediation phase, you have two types of options. Either way, you do it off-site. It's not really clean, because basically you take the land and then you throw it away. This is basically what is off-site recycling. And there is another option which is much more profitable, much more interesting, which is called on-site, where basically you will work on-site in order to depollute the land. And this is what we want to achieve. Urban planning, actually, once it's depolluted, it's great, but now you have to develop the neighborhood. Okay, will I do a park? Will I do public transportation, residence units, offices, nursery, different services? Urban planning phase. We do that now in close contact, and we can construct it with the different local authorities that we know in France, in Belgium, in Switzerland, in Italy, the Netherlands, Spain, Portugal. Here, just to finish this presentation, just to introduce you to two types of examples of what we've actually achieved. In Villeurbanne, in France, close to Lyon, in the southeast of France, we have found a place which used to be a car manufacturing plant. Heavily polluted, heavy metals, and so on and so forth, chemicals all across the board. It was 55,000 meters square, fully polluted. What we have done is that today it's a 20,000 square meters park with a nursery, with residences, with offices, and we have invested 8.1 million euros in order to remediate this place. Second example, here in Montreuil, super close to Paris, we took over a full building office. It was infested with asbestos. So basically we have destroyed only the interior of the building, and we've kept the superstructure in order to make sure that we have the best impact as possible. And it was only 40% occupancy. The local population didn't have any access, And actually, we have rebuilt the whole building, and now you can have hospitality, flex offices, and also residence units into it. So this is what we do over the last 15 years in terms of urban development and sustainable urban development. Do you have any questions? All good? All set? Thank you very much.
Thank you so much, Mr. Roma. Our next speaker is Ms. Marwa Hussein. She's a Chief Growth Officer at Aroma. Her topic is mitigating methane emissions and reducing fairly strategies for a sustainable energy future in the Middle East. Please come to the upstairs.
Shukran. Hi guys, can you hear me? Are you guys still awake? I know it's the last minute, right? And everybody's going home, everybody's ready. Okay, so I'm presenting methane and flare reduction technologies, basically, right? So you've been hearing about methane emissions and flare for the past 3 days. There was actually an excellent session between PDO, Petronas, and BP, where we've heard them talking about OGMP, we've heard them talking about flare emissions and the way forward. So flaring and methane emissions is a really very high level and a very important topic today. I work in a company called Aramon. Aramon have been measuring emissions for the past 10 years through mobile devices. And my presentation today is basically to give you an idea on the lessons we've learned through the time of measuring emissions. So right now, I think 3 or 4 years ago, OGMP was established, and there have been really stern regulations related to flare and methane emissions. So there is the OGMP, which is a global initiative to reduce methane emissions. It basically requires from all operators to measure methane from a ground level, which they call level 4, and then from a site level using mobile devices, which they call level 5. And then they provide reconciliation between the level 4 and the level 5. The reconciliation actually is just a methodology to compare the measurements level 5 and level 4. Why? Because it tells you, first of all, were you able to capture the right amount of leaks within your sources? And the second thing, it also gives you an idea if the technology you've been using to detect the leaks are accurate or not. In addition to the methane emissions and the flare reduction global initiatives, there are other initiatives within the GCC that requires you to measure also air quality. So you're not only required to measure the methane and flare, but actually through the environmental departments, you are required to measure H2S, you're required to measure ammonia, you're required to measure VOCs, you're required to measure different elements or components that affect the environmental, right? And that brings us to the challenges that operators face with all the global pressure to measure methane and flare, and at the same time, the local pressure to measure environmental components. First of all, the cost pressure. Right now, you have many devices, continuous monitoring, mobile devices like ours, many devices that claims that they can measure and detect leaks. But in some elements, you are required also to quantify, not only detect. And in some elements, you're required to quantify different components at the same time. So that puts a pressure on the cost element that an operator has. In addition to that, the limited in-house expertise. Most of operators rely on third parties to perform the leak detection and repair methodology for them. There is very few expertise inside each company or worldwide even that understand methane emissions and flare reduction, flare emissions. At the same time, there is a global pressure that focuses on methane, although methane is very harmful to the environment. But as we all are operators and we work in the oil and gas, we also know that there are fatal elements that are more important than methane. So the push or the pressure to focus on methane sometimes provide a pressure to remove the other elements from the picture. At the same time, because each department looks after specific, so you have a department that looks after flare, you have a department that looks after methane, and then you have another department that looks after environmental, it becomes an extra fragmented operation for each one. And that's why mainly the challenges exist, but they don't require that we invest in extra infrastructure or actually import more equipments or rely on more things. The challenges actually can be fixed on what we've learned, which is utilizing expertise or devices that have a multi-components parameters monitoring. What does that mean? It means that when you're sourcing the equipment that you will use for certain elements and different departments, a very small addition you might think about is actually to focus on devices which can actually quantify multi-sources for you. So from our work on the level 5, for example, most of the time operators would come to us and say, we are OGMP, we want to be OGMP level gold standard, which means that we want to do the level 5 and the reconciliation with the level 4. Can you do that for us? And definitely we have a TDLS component that can measure methane. But at the same time, while we're flying on the air to do the methane, we can definitely do the flare emissions, the flare combustion efficiency at the same time, measuring CO2, CO, and VOC. That saves the cost, saves the additional hassle of having to arrange for a new campaign to do that and stop operation for a little bit. That's, for example, when we talk about, most of the time, our utilization becomes related also to drone efficiency. So what we've realized through the time when we were utilizing our devices is that, yes, we can do handheld, we can do semi-fixed monitoring, but the drones bring a huge element of efficiency to the measurements. Basically, why? Because it covers large areas in a very quick time. So you're able actually to see where are the areas where you have emissions very quickly. It also safe. It does not require that you go into ATEX zones when you're doing the quantification of emissions. At the same time, it can achieve the hard-to-reach areas. And I'll give you an example from our discussion. I don't know if you guys have been on the BP PDO panel, but they were talking about measuring the flare efficiency, right? And one as a requirement of OGMP. And one of the things that they've mentioned is that they did not find a way to measure it except for using a volume flow in, flow out, and calculating how much is that. But with drones, you can actually fly in a very safe area, as what I'm showing right now, right? You can fly safely around the flare, be able to capture the emissions, the concentration of gas coming from CO, CO2, VOC, methane, and calculate and directly, from direct measurements, understand your combustion efficiency related to the flare. So let me skip this. Okay, another important, I skipped the slide because I didn't want it to be a sales slide. Another important aspect that we've learned is the deployment approach. What does that mean? It means that one of the things that we've learned is also that when you're flying drones, you will need to take into consideration the way you measure wind specifically. So most of the time, you will have an anemometer or a wind anemometer within the drone itself. This can affect your emissions measurements and concentration hugely if you are not taking into consideration that it is far away, at least 1 meter away from the drone, to avoid the wind disruption that the drone brings with it. At the same time, utilizing a wind sensor on the ground also bring value because you can actually do extrapolation between the winds that you're measuring on the ground and the wind that you're measuring up high and understand the difference between them. One important part also is calibration. Gas calibration is really very important to ensure that there is no drifts from the sensors. So most of the sensors that promise 1-year calibration or multi-year calibrations cannot, I don't want to say cannot be trusted. It can be trusted, of course, but you will need to do the recalibration frequently to understand the performance of the sensors. When we look into quantification, it is very important to ensure that you are utilizing not only one methodology for quantification, but at least the minimum is 2 methodologies for quantification of methane emissions and other components. 2 very important methodologies are called reverse dispersion modeling and mass balance. Basically, the difference between both of them is that it is basically the use cases, right? So reverse dispersion modeling becomes easy to use when there is a vent, when there is a flare, or well-defined point sources. While mass balance might be more accurate, or the use case is when you have a big area, big segmented area that you're measuring at the same time. Okay, when we talk about flare efficiency, you need to ensure that there is a big difference between flare destruction efficiency, where people are measuring the methane emissions and trying to see how much methane emissions is being burned. It is also essential to measure simultaneously the methane, the carbon dioxide, monoxide, and VOC to ensure that you understand the balance between the hydrocarbon burned within your flare. One of the trials that we've done, and it was actually very successful, is to combine the measurement with a thermal camera. The thermal camera actually provides huge value to look into the temperature profile and segmentation. It will give you a visual imaging of where are the areas exactly that hydrocarbon is not being burned. One of the case study that we've done in Thailand with PTTEP was actually that their flare performance was being able to improve dramatically just by changing the BTU settings from 192 to 213. So no infrastructure requirements, no extra cost is required. It's just a simple settings change in the parameters. And to be very honest, that was one of the reasons we utilized the thermal camera, because it gave us exactly where are the areas that we see the changes. The picture is not as rosy as it shows. Of course, when you're using specifically drones, there are challenges that you see. One of the challenges is that because it's a snapshot, you might fail to capture the intermittent emissions. Intermittent emissions are easily captured when you have a continuous monitoring. So that complements continuous monitoring, because you cannot basically put a continuous monitor everywhere. So it complements the weather dependency. So if it rains, for example, or if you have high wind, or if you don't have any wind at all, it becomes a little bit difficult to measure and quantify emissions. At the same time, the background concentration levels requires you to spend more time on the field so that you can measure fence line upwind and downwind to be able to remove the background noises from that. Time constraints. You have an operation that is running, you don't disrupt the operation, but you're spending time on their flying, right? So that's a very important point. I think I think I've shared. I know it's late and I too much information to capture, but I think I've shared what I want to share with you guys, and hopefully you're all gonna think about when you're doing emissions monitoring, you're gonna think about the multi-parameter emissions measurements, and instead of measuring only one parameter. Thank you all very much for your time. Appreciate it. Thanks. Oh, I forgot to ask if anyone have questions. That's what I assumed. Thank you all.
Dear guests, we'll have 5 minutes break and come back. What's next? What's next in renewables? A fireside chat with Mr. Siddharth Malik, who is the exclusive leader in energy transition, and the moderator Ms. Hebel Kindi, a business reporter from Oman Observer.
How are you? Nice to meet you as well. Let's go to right. There we are. Do you have a mic?
Thank you. Can we wait for more people to come in? Can we start?
You can start.
All right. Good evening, everyone, and thank you so much for joining what I believe is the last session of the Oman Petroleum and Energy Show. My name is Hebel Kindi, and I'm a business reporter at Oman Observer. Today, I'm honored to be joined by Mr. Siddharth Malik, a global energy leader and entrepreneur with over 20 years of experience across the US, Asia, and the Middle East. Over his career, he has led more than $3 billion in clean energy investments, developed over 7 gigawatts of solar and wind projects, and scaled industrial decarbonization ventures that delivered successful exits and breakthrough returns. He has incubated startups, built independent power producer platforms, and advised family offices and public institutions on low-carbon strategy. He most recently led group strategy and energy investment for a $25 billion diversified industrial conglomerate, focusing on early and growth stage ventures in renewable power, low-carbon manufacturing, and digital infrastructure. A TED speaker and a patent holder, Mr. Malik is widely recognized for his work at the front lines of the global energy transition. He holds a master's degree in engineered materials from the University of Pennsylvania. So we'll begin with a few questions, and then we'll move to the Q&A. Thank you so much for joining us today, Mr.
Thank you
Malik.
for having me, and thank you for that warm introduction.
Anytime. So let's start with the global picture. Post-policy setbacks of the Trump era, how would you describe the current momentum of the energy transition? Has investor and market confidence fully returned?
You know, it's interesting. Yes, there has been certain setbacks. It seems like it post certain changes in political leadership in the US. At the same time, if you look at how we have progressed from 2023 to 2024, there's been a record $2.1 trillion of investment in renewable energy. And that's about 11% year-on-year increase, right? And I don't quite believe that that trend will stop. We see a delinking between political narratives and the value that renewable energy actually brings to businesses and geographies and economies. So I believe, particularly in the region, which is driven to diversify its economy from oil and gas to non-oil and gas, I think renewable energy, energy transition investments will play a massive role, be it in solar, wind, storage, green hydrogen, or new vectors of energy as well. So all in all, yes, there are certain headwinds, but I don't quite believe they will have a massive impact on the growth that we're going to see here on.
All right. So you've built ventures that were both climate positive and commercially viable. What do you think is driving real returns in renewable investments today, and what are still the critical gaps?
Well, the value that renewable energy brings to any business or even the economy in general is multifold. One, needless to say, it is the cornerstone of renewable energy, of clean energy, emission-free energy, and it lines perfectly with net zero goals of many countries. The second bit is renewable energy is very, very competitive today. So there is a standalone business case for why one should adopt renewable energy compared to, let's say, the conventional. And it's not either or. I think both new forms of energies as well as conventional form of energies coexist, and they have to find a place to coexist. But the fact remains that the cost of generation of renewables is very, very competitive. Of course, something more needs to happen. They need to be more dispatchable and firm power, which requires storage to come in. But fundamentally, the fact that it helps to diversify oil and gas economies, it is fundamentally more competitive than a lot of grid-based power in different kinds of the region in the world. And third, that it is directly in line with the net zero emission targets and clean energy goals. I think those are the critical drivers for adoption of renewables.
All right. Since you mentioned energy storage, how important is investment in it, whether it's in the form of battery storage or hybrid systems, in addressing the intermittency issues associated with solar and wind energy?
Right. I think what we have done by using solar and wind is use what is called the lower hanging fruit, right? So whatever energy could be displaced by renewables, that has been very well done by solar and wind in different parts of the world and continues to be. The next stage of renewable energy development critically hinges on energy storage, for the simple reason that while the cost of solar and wind are very, very low at the generation point, when you look at the system level costs, they're actually fairly high because you need a tremendous amount of backup generating capacity to firm up that renewable power. And hence, energy storage has a very critical role to play, right? So it's the next holy grail for renewable energy development, since it helps firm up renewable power, brings dispatchability for renewables, and comes closest to mirroring what is called a conventional power station, be it gas or thermal power.
Speaking of other renewable sources, from your perspective, what other sources in Oman, such as wave energy or geothermal energy, hold potential for development and should be assessed for commercial feasibility?
I think I've touched upon a topic which is very close to my heart, and that is Oman. Oman is one of the few regions in the world that I believe is very well poised to be the clean energy hub, not for the region, but pretty much in the world. And there are various reasons for it. One, fundamentally, there is no dearth of good solar radiation and wind resource, right? So there's a renewable energy resource potential that is very, very high, and it mirrors one of the best in the world. The second leg of the stool is availability of large parcels of land, which of course also Oman ranks very high on. And the third bit is a long coastline, which allows both import and export of clean energy molecules. That is the next phase of energy transition. Last but not the least, the regulation that we're seeing in Oman is being developed by under the aegis of Ministry of Energy and Minerals. I think that they're doing a phenomenal job at it, right? Very few places in the world you will see such active regulation to be able to support the cause of renewable energy in Oman for the reasons that I mentioned. So I think resource potential, large tracts of land, a very forward-looking policy approach by the regulators are all very, very critical aspects to actually move the cause of renewable energy forward. So from that perspective, Oman is very, very strongly positioned to be the hub of sustainable manufacturing and a country, probably one of the few in the world, which is going to be 100% driven by renewable energy.
Oh, wow, that sounds very promising. So let's move on to capital. What does the financing landscape look like for renewable projects here in Oman? Are we seeing enough appetite from private equity, institutional investors, or development finance institutions? And what models are most cost-effective, in your opinion?
Right. Of course, you need a tremendous amount of capital for financing this energy transition, right? As I mentioned to you, we have seen trillions of dollars being invested into renewable energy. The good news about capital and its allocation in renewable energy is there are two large buckets to it. One is the stuff that we see is already de-risked, such as large solar and wind power plants, which is a very low-risk affair. The bankers understand it. The lending community has gained an appreciation for it. There have been large offtake agreements that have proven themselves out with the right kind of sovereign-backed guarantees. And hence, that is the area where capital is available, right? And you can raise large billion-dollar investments to build large de-risked solar and wind power projects, right? The second bucket is what I call the phase two. And the phase two is energy storage, green molecules, and the other things that will use renewable energy as a prime driver, right? Have they been completely de-risked? Probably not yet. But I think we're exactly at the position where we were with solar and wind a couple of decades ago, right? So the path to de-risking is very, very clear. And once that happens, capital inflows will already occur in this sector, right? Last but not the least, Oman particularly offers a very interesting regulatory regime with a very forward-looking policy decision-making to be able to actually attract that kind of capital and build the renewable energy portfolio out. So I don't think capital is going to be a constraint.
All right. So I think one other issue that gets neglected, or I think they are trying to focus on it right now, is ICV and empowering SMEs in the renewable sector. In your experience, where are the entry points for SMEs in the renewables value chain, and what needs to happen for them to thrive as suppliers, installers, or service providers?
It's a great question. When we talk about renewable energy, we mostly discuss projects, right? Renewable energy projects. But if you go beyond that, there's a tremendous supply chain effort that goes into making that project happen. That includes the manufacturing of those solar cells and panels, wind turbines, and of course, installation erections, civil works, and there's a long list of things, right? Renewable energy offers a great potential for actually supply chain reconfigurations in the world. And what I mean by that is the ability of this sector to create large in-country value in Oman, be it through direct or indirect interventions, I think is at an all-time high. Not only that, if you start thinking about Oman is just not a place to install renewable energy projects, but also a place to actually set up manufacturing facilities for those renewable energy equipments and components and devices, right? For the reasons that I mentioned. I mean, it's got the right regulatory framework, a very promising policy intervention, and a very forward-looking sort of approach towards attracting FDI. So in that perspective, the ICV potential, the potential for small and medium enterprises, I think is absolutely at an all-time high within the region. So I'm quite excited about what that can bring. And we're already seeing some green shoots where a lot of installation, erection, commissioning contractors, some wind manufacturing companies, solar manufacturing companies have started to set up shop in Oman. And I think that's all very positive.
All right. So Mr. Malik, you are a patent holder, right? So how do you see the role of R&D evolving in the Middle East energy transition? Is there enough investment and collaboration in climate tech innovation, in your opinion?
So climate tech is always a work in progress, right? So we have seen climate tech 1.0, one would say, and now we're in the 2.0 or maybe even 3.0. The ability of educational institutions, small, medium enterprises, to actually participate in that IPR revolution, which is waiting for happening in renewable energy, that also is very large. We're already seeing a very forward-looking policy approach by the government in Oman to actually encourage the universities to come forward, partner with the industries, and vice versa, for industries to come forward and partner with educational institutions to drive that complete technology development, research, and the idea of proving technologies on a small scale or a pilot scale. And a tremendous amount of intellectual property stands to be sort of coming out of such initiatives. So even from that perspective, I think Oman is very well positioned to create a hub of technological development for the renewable energy sector and energy transition in general.
All right. So you've worked across many markets. What lessons or warnings would you offer Oman as it ramps up its renewables push?
One thing that I have seen is we have witnessed in certain other parts of the market where the ambitions sometimes are ahead of the capability to actually implement those projects. And you see tremendous amount of large announcements, but the project activity does not follow through, right? On the contrary, I think Oman is taking a very, very thoughtful and a cautious approach, which I think is very impressive. It is not, the country is not being swayed by all that we hear around the world, but is not putting cart before the horse, right? So projects are happening, they're developing, there are phase 1, phase 2, phase 3 interventions, and given the size of the grid, of the power grid, the renewable energy ambitions are very well aligned to ensure there are no socio-economic disruptions. At the same time, we have seen what we've just witnessed in Iberian, right? Where there's been a large power grid failure Some attribute it to renewables, some do not. The jury's out. But I think Oman is already on a very cautious path, which will be realistic and will meet all the objectives of its net zero targets.
Right, so that's about it. We can head to a Q&A if there are any questions in the audience.
Well, I have a question. Given that I'm in the industry of oil and gas, I want to talk about the agility of the GCC region when it comes to renewables. And we have seen a rapid shift, let's say over the last 5 years, technically, probably a post-COVID transition, I would say. How do you think that this shift or the rapid shift in renewables technically would have a potential risk or an unintended consequence in the region, and what does it mean for job opportunities or creations? And the more rapid it is, the more inconclusive it becomes in terms of forecast. So what's your take on that?
It's a great question with a lot of aspects to it, right? The GCC region has typically been an energy exporter, right? And this opportunity also is no different. As we're seeing the advent of new energy vectors such as low-carbon hydrogen coming in, low-carbon methanol, ammonia, that falls right into the alley of producing it here, just like oil and gas, exporting it by putting it on a ship or a pipeline or whatever means of transport there is. So that strategy falls well in line with how the region is typically operated. In addition to that, here's the big benefit I see. These energy vectors also offer a tremendous advantage into changing the landscape of the domestic economy, right? So the region stands to gain from such interventions that have occurred in the past 5 years by way of renewable energy and other interventions, not only for export, but also to change the energy landscape within the region. And that has tremendous amount of benefits to your point. Imagine data centers today. They're looking for places where there is abundant availability of clean energy. Look at new cement plants, aluminum plants, and a variety of other heavy industries. They are looking for geographies which are abundant in clean energy to be able to drive their operations more sustainably. So in that context, GCC offers the perfect platform to be able to actually attract such FDIs and investments to drive sustainable manufacturing. And what happens when you get these FDIs, you create jobs, you create economic value, you create in-country value, you mobilize and galvanize the small and medium enterprises, and microeconomic activities flourishes at an all-time high. So in my opinion, I think it's a great opportunity. Of course, there is always caution in the wind, as you alluded to. One has to be careful that the ambitions are calibrated and the project development capabilities are in alignment with the ambition and the targets that you have set out, which I think the region already is very, very focused on. And Oman particularly, of course, just because I live here, but I see that there's a very interesting, cautious, determined and a focused approach towards making that transition happen.
Any other questions? All right, so I think that's it. Thank you, Mr. Malik, so much for joining us today. I'm so glad that we were able to make this happen. So it's been a pleasure moderating this final session. I hope everybody has a great evening.
Thank you very much. Thanks for your patient listening, and thank you, Eba. Thank you.
Thank you both for your discussion. As we conclude today's session, we thank all speakers and participants for their valuable contributions. We look forward in continuing this insightful discussion and collaboration in our future events. It has been an honor to be with you this week. I'm Rahab Badr Al-Amri. Until next time, stay sustainable. Thank you. Have a good evening.